Starting with our new course named Learning Data Structures Using JavaScript. And over here, I would like to focus on the keyword or our programming language, that is JavaScript. Over the past few years, JavaScript has been used more and more as a server-side computer programming language, owing to platforms such as Node.js and SpiderMonkey. Now that JavaScript programming is moving out of browser, programmers will find that there is a need to use many of the tools provided by conventional languages, such as C++ and Java. Among these, the basic thing comes into the picture is the data structures. If you're a computer science student, there is a common thing which comes in your mind while creating a data structure. So data structure includes linked lists, stacks, queues, and graphs, as well as classic algorithms for sorting and searching the data. So there is a particular protocol or I can say a step-by-step rule which is followed while creating a data structure. So with JavaScript, we can even manipulate these data structures, and that is what is this course completely all about, or this tutorial. Like how we work or manipulate or implement data structures with the help of JavaScript. So that let's start with this course, like assuming that you are a JavaScript programmer and you know basics of JavaScript. So let's start off with introduction to JavaScript. As I said, JavaScript is a very powerful language. It is a powerful scripting language. In short, I can say it is a powerful server-side scripting language. It is used by many of the computer science students. And the most important thing is that JavaScript helps you to discuss with data structures and algorithm within the constraint, and it places them in such a way that you can easily manipulate it so that it will be very easy for a developer or a programmer to understand and implement it. JavaScript is not only used for front-end languages, it is also used as a back-end language also. It is a functional language and can be used for better understanding of data structures. So that is a basic understanding for JavaScript, or I can say description in a gist for JavaScript. Now, studying algorithm is a very important thing if you are a computer science student. The basic thing which comes in your engineering subjects is like before starting up with the programming language, there is always a description about data structure. So studying algorithm is also one part of them, which is important because there is always more than one algorithm that can be used to solve a problem. And knowing that which ones are the most efficient algorithm is important for a productive programmer. For example, if I say there are at least 6 or 7 ways to sort a list, but knowing that quick sort algorithm is more efficient than selection sort will lead to even much more efficient sorting problems, or that it is fairly easy to implement a sequential or a linear search algorithm for a list of data, but knowing that binary sort algorithm can be sometimes used twice as efficient, then sequential search will lead to a better program. So understanding these concepts is very important, and that we are going to learn with the help of JavaScript, as JavaScript is well known for both front end as well as back end, so it has support in both the ways. So in short, it will be very useful for understanding data structures with the help of JavaScript. Let's understand the programming practices for JavaScript. First of all, we'll understand about the JavaScript environment. So let's go through what is the JavaScript environment, and we will also understand declaring and initializing variables. One we have done with the installation part. We'll understand about declaring as well as initializing a particular variable in JavaScript, which is a part of a programming practices. And then comes the basic logic for arithmetic and math library functions. Once we are done with this part, in the next chapter, we'll understand about the decision constructs, repetition construct. Decision construct means using a if condition and if else, switch statement, and so on. And repetition construct means using while loop, do while loop, for loop. These loops are also used in JavaScript. The logic is same, but there is some syntactical difference. After this comes the functions, like using various type of functions with respect to JavaScript, and how functions are implemented and how they are desired output is achieved with the help of JavaScript. So let's go to our browser and install the desired JavaScript environment and have a look of these two basic topics, like declaring and initializing a variable and arithmetic and math library functions. So let's go to our browser and download the JavaScript environment. JavaScript environment can be used in like various ways, or you can simply declare a script tag and develop a JavaScript environment. For me, this is the official website for declaring the JavaScript functionality, that is www.jsdb.org. So JSDB is nothing but a JavaScript shell functionality, and you need to just download this particular zip file for Windows. And once you're done with this file, say for example in C drive, for me I have stored in my C drive. So let's go to our C drive, and there I can see the folder structure. So this is my C drive. Here you can see that there are n number of folders, and this is the JSDB folder which I have installed. Better, it is nothing but a zip folder. Now I've just extracted this, and now on clicking on this, I will get a particular shell. So I'll just open this particular file. So this is my shell. So here the shell will interact with JavaScript, and here we will focus on various JavaScript programming practices. So in this section, we discuss how we use JavaScript. We realize that programmers have different styles and practices when it comes to writing programs. And we want to describe ours here at the beginning of our course, or I can say beginning of our tutorial. And there you will understand more complex code will be presented very easily with the help of shells and many more. The first section which comes while using JavaScript is like declaring a particular variable. JavaScript variables are global by default and strictly speaking don't have to be declared before using. When a JavaScript variable is initialized without first being declared, it becomes a global variable. So in this complete course, however, we follow the convention. We will follow a particular convention which will be used for compiling languages such as C++ and Java by declaring all variables before they are first used. The added benefit to do is like declared variables are created as a local variables. So let's have a look. Like here is my variable. So I will declare a variable using keyword var, and after that I'll declare the variable name. For example, my variable name is number, so I'll say var number. So var number will give me the declaration of number. Now if I just print on number, because I have not initialized my number value, so if I just say number, I will not get any value. On the other hand, if I initialize my particular number with some value, so if I say again var number equals 5, and now I again print the number value, or I just call for number, so it gives me the output as 5. So in this way, shell scripting, or we can say JavaScript shell binding, we saw for number declaration, but there are certain variable declarations also. For example, if I say var name equal to some particular name, say for example my name is Radhika. So here if I just mention the name, it's just a demo name which I'm mentioning for now. So here you can see, just by printing the name value, I get the value associated to it, which means that JavaScript also has a support with n number of data types. There can be variables such as var rate equal to 1.2. So in such a scenario, my rate will be declared properly with the help of float value, that is 1.2, and if I print on rate, I get the proper value as rate. Apart from number and string and float values, JavaScript also supports Boolean values. Boolean values are very strong with respect to JavaScript. So if I say var flag equals false, so and I print on the flag value, so I get the value as false. So this way JavaScript variables are included, like we can declare it by default, or we can have a particular scope for it. And whenever a variable is initialized without first being declared, it becomes a global variable. And when it is within the particular function, like in the later chapters, we'll also have a look on the functions. So whenever a loop or a particular function has some variable associated to it, in that particular scope, I can say the variable is local. So in this way, we can manipulate our variables. The added benefit to doing this is that declared variables are created as a local variables, and the one which is set as global can be accessed all through your JavaScript file. So this was about understanding the variable section. The next is arithmetic and math library functions. So JavaScript utilizes a standard arithmetic operators. So the arithmetic operators include addition, that is the plus sign, Subtraction means the minus sign. Multiplication means into, that is product of two or three numbers. And then comes the division and the modulus function. So I'll just show you one simple basic example for understanding the arithmetic and math functions. So this is my shell. Here I'll just go through a basic example. So now I'll just do one thing. I'll declare a variable. So my variable is var x equals 3. Then comes the next variable, that is var y equals 1.1. Okay, so one is of a number type or integer type, other one is of a float type. Then I just say I'll print my values. So I'll just do a print with the help of a function. So that is print x plus y. And I get the value as 4.1 if you check it out over here. So 4.1 means 3 plus 1.1, that is 4.1. So I'm getting my arithmetic operator in the proper way. Now if I print, say for example, I want to print x minus y. So it would be 3 minus 1.1, that comes as 1.9, which is proper. Now I'll do one thing. I'll just declare another variable. So my next variable will be var z equals 9. And then I print a square root of this particular variable. So square root has a particular arithmetic operation. That arithmetic operation is actually nothing but a square root of a particular number with the help of a math function. So that is done as print math dot square root z. So this gives me the square root of 9 as 3. Now I just want to get the absolute value of y divided by x. So that is done with the help of another print loop. So that is print math dot absolute y divided by x. So that gives me 3 divided by 1.1 as 0.36666, which is a round out figure to 0.37. So this is the output I get when I get the particular decision to be done. Now I just want to check out for various type of the products functionality, and I just want to print the product of x divided by y, that is 3 divided by 1.1. So I'll just say as x into y gives me 3 into 1.1, that is 3.30. As 11 into 3 is 33. So I just get a decimal over here, that it is 3.3000. So in this way, I can do n number of arithmetic operations and the functionality related to arithmetic operation with the help of JavaScript. Why introduction for this part was needed? Because whenever we create a particular data structure or understand the logic behind it, it is very important to take a particular stand or a particular functionality into picture. So now in our next chapter, we'll focus upon decision construct, repetition constructs, and implementation of functionalities in JavaScript with the help of the shell, that is a JavaScript shell. So let's move on to our next chapter where we will have a focus on each one of them. Last chapter was the complete understanding about the variable declaration and use of various functions in JavaScript and manipulating them and getting the desired result. Now moving on to our next topic, that is decision constructs. So decision construct allow our programs to make decisions on what programming statements to execute based on the Boolean expression. The two decision construct we always use are if statement and switch statement. So the if statement comes in three forms, I can say. If is like a simple if statement, then comes the if else statement, and then if else if statement. So here we will have a simple example. We will call for a if else statement that will give you a better picture like how if else statement logic works in JavaScript. So let's start with declaring a variable in our shell. So this is my shell. So here I would say var, inside this I would mention var mid equals 25. This is my middle value. After this I'll say var high equals 50, and then I'll say var low equals 1. After this I'll give the current value, that is var current equals 13. So I've declared with this variable. After this, I'll give for found variable. So I'll say where found equals -1. So I've declared for all these variables. So I have mid value as 25, high value as 50, low value as 1, current as 13, and found value as -1. So now I will just print for every result whether my values are correct or not. So first I'll check for mid, so it's 25. Then I check for high, it's 50. And the low value, so its low is also 1. After this, I'll call for the next value, that is current. So here it will be current. So the current value is 13, and then comes the found value, which is -1. So all the values assigned to this variables are proper and it is properly saved in our shell. Now starting with the if condition. So here if I say if my current value, that is 13, I'm giving a condition that if my current is less than mid, then in this scenario I would say mid equals current minus low divided by 2, and then I close my if loop. So here I'm getting current is less than mid, because if my current is 13 and my mid value is 25, so my condition is said to be true. So my mid value now will be current minus low divided by 2, that is 25 minus 13, that is 12 divided by 2, which corresponds to the value of 6. So this is how if statement manipulates when it comes to a JavaScript. On the other hand, if I want to say the other thing is that else, my else statement will start now. So before that else statement, I would like to complete my if, so it should be in continuation. So I just start over here in the same format, or else it will throw the error like this. So if mid current is less than mid, then mid equals the same value I would like to repeat, that is mid equals current minus low divided by 2, and after that I'll close the loop and again I'll say else. I'll start with else. Here I will say, so this is how else works. Mid equals current minus high divided by 2, and this completes my statement, and now I complete my else. So this is how it does. On the other hand, if I get that if mid value, now the scenario is such that my mid value is 6. So my current is actually greater than mid value. So my current minus mid, that is nothing but 13 minus 6. So that is minus 19. So in that way the division takes place and the calculation for mid is done. So this is how is the working logic when it comes to if else state. So now let's start with the next thing, that is to understand about the repetition construct. So one of the most efficient way is always to use the if else statement or switch statement, which is also possible in JavaScript. Now coming up with the repetition construct, so here I will just do one thing, is to print a value from say 1 to 11, or it is like printing addition of all these values. So for that I will use first thing is the while loop. So let's start with the while loop in the repetition construct. So here I will say where number, I can scroll it down because that would be even more beneficial. So this is my variable, that is number, equals 1, and after that I will say where sum equals 0. Then in such a scenario I will check for two values, that number value is 1 and sum is 0. So it is assigned properly. Now I start with my while loop. So here I will say while my number, that is 1. So while my number is less than 11, inside this I will iterate my sum. So I'll say sum should be added with the number. So that is 0 will be added with 1. So it will be 0 plus 1 plus 2 in that scenario. And after that I will say number plus plus. So it is like I am iterating my value, or I can say incrementing my number value. So my number value will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because I am giving the condition till 11. So it is like until and unless it is less than 11. So my number value will be incrementing. After this, I complete my while loop. So if you get over here, I'm getting the value as sum as 10. Why? Because it is just iterating in that way as 0 plus 1 plus 1 and plus 1, because it is not taking a proper condition that whether my number has the proper logic which is less than 11. So for getting the proper Fibonacci series, I would just say var number equals 1, the similar way I did, and var sum equals 0, and after that I will say for, and inside for I would mention var number equals 1 and number less than 11, and after that I will say number plus plus. So it is like I'm incrementing my number value. Just remove the extra spaces, so that would give the better understanding like what we are iterating inside our loop. So this gives my start of for loop. I start with my curly braces. After that I will say sum plus equals number, and then I complete my loop. In this scenario, I'm getting a proper Fibonacci series because my number is iterating properly when it comes to for loop, because here I'm saying number less than 11, and after every time whenever you add a particular sum, in that scenario I get 0 plus 1 plus 2 plus 3 plus 7 plus 8 plus 9 plus 10, and when it reaches till the point 10, and there I get a print value for the sum, that is 55. Now, how to use a for loop with the help of array. Next chapters, like upcoming chapters, we'll be understanding about the array concept also. So let's have a look. So for that, I will say where numbers. So numbers I will initialize as an array with some values, say 3, 7, 12, 22, 100. So this is how array is initialized. We'll have a better understanding in our next chapter. Now if I just print for numbers, so I get all these arrays which I have declared over here. Then the next thing I do is like I declare a sum. So my variable sum equals 0. So my sum is 0. After this I'll call for loop. So inside for loop, how a for loop is declared, we have for. Here I would start with my for loop as variable I equals 0 semicolon, I less than numbers dot length. Numbers dot length will tell what is the length of this particular array. For us it is 0, 1, 2, 3, 4. So that is like we have 5 elements over here. The number spelling should be proper. So it is numbers dot length, and here I say I plus plus. After this I'll do a summation. So here I will say sum plus or equals numbers of I, and then once I'm done with my summation, then I will just get the print value, that is 3 plus 7 plus 12 plus 22 plus 100, that is 144. So this is how we have a summation construct when it comes to a particular logic, that is the logic behind designing a for loop for an array. After understanding the repetition construct, the next thing which is important to understand from JavaScript perspective is the functions. JavaScript provides the means to define both value returning functions and the functions that don't return values, that are even called as the sub-procedures or void functions. Let's have a simple example for declaring a function where I just want to declare a void function in JavaScript, where I have a function, say function name is function, and the function will take 2 parameters. So my function name is curve, and it is taking 2 parameters over here, that is array and amount. And I start with my function over here. Here I will specify the for loop, that is the repetition construct. So my for loop begins over here, and then I say for var I equals 0 semicolon. I just specify with the help of a length parameter, that is length, and then I do I plus plus. After that I will say array of I corresponds to some amount. So it will correspond to some amount, and after that I'll complete my loop. So this is my function. Now I'll call for a variable. Say my var is grades. Inside this grades I'll declare an array. So my array will have values like 77, 73, 74, 81 and 90. So inside this array, now I've declared my array. Now I'll call for my function. So my function will be curve grades and the parameter will be 5. So I call for my function. So now I'll print my curve. So it would be print grades. So printing this grade value should display the value as 77 plus 5, that is 82, 73 plus 5, that is 78, 74 plus 5, that is 79, and so on, that is 81 plus 5, 86, and 90 plus 5, that is 95. So it is printing that particular value as the way it is expected. So this was about the functionality, like whenever a method is called or a function is called. Next important thing which comes into a picture. So we had different type of JavaScript programming practices in this chapter. But the most important concept which you should keep in your mind is about the variable scope. So variable scope is nothing but like defining a scope of a particular variable. The scope of variable refers to where in a program a variable's value can be accessed. The scope of variable in JavaScript is a function scope. This means that variable value is visible within the function definition where a particular variable is declared. Where a variable is defined outside a function, then it's said to be called as a global variable. For example, consider for this variable, it is called within a function. So my variable I is of a local scope. On the other hand, if I will declare a function and before declaring a particular function, I have declared some variable, then that variable will said to be have like a global scope. So this was about the two major scopes for understanding the variable. The scope variable defined in the global scope and local scope should be maintained properly when it comes to JavaScript terms. So this was about understanding the variable scopes. The next chapter we'll basically understand the complete overview of data structures. What are data structures? Why are they so prominent and important? And afterwards we'll start with our first data structure which comes into picture for every programmer, that is the array. And we'll begin with implementing array with respect to JavaScript. This chapter is a complete focus for understanding the data structures, or you can say to get to know what is data structure all about. In our last chapter, we had a complete focus about the data structures like various type of JavaScript programming practices and how we implement those programming practices in our day-to-day life. So that we'll focus for now in this chapter. First of all, before starting implementing data structures in JavaScript, it is very important to get to know different basics of data structure. So basics of data structure compromises with a definition. So my definition begins over here, like data structure is a systematic way to organize data in order to use it efficiently. So learning data structure is a very important, or I can say a primary thing for any technology professional. Working as a developer means that you are able to solve problems with the help of programming languages, and data structures are an indispensable piece of solutions that we need to create to solve these problems. Choosing the wrong data structure means choosing the wrong path can also impact the performance of the program which we write. This is why it is important to get to know different data structures and how to apply them properly. So before understanding the different data structure thing, it is important to get to know the basic thing, that is like two important definitions of data structure, that is interface and implementation. So what is interface and what is implementation? If I say for interface, each data structure has an interface. Interface represents the set of operations that a data structure support. Implementation means what? It interface has certain rules and regulations to be followed. Implementation is the working procedure which takes place inside the interface. So if I say implementation provides the internal representation of a data structure, the internal structure in short. Implementation also provides the definition of the algorithms used in the operations of the data structure. Now let's move on to the next important concept is analyzing the different characteristics of a data structure. So there are basically three important characteristics for data structure. The first one is called as the correctness. Correctness means what? Whether the data I'm getting is accurate or not. So data structure implementation should implement its interface correctly. Whatever I mentioned previously in my previous slide with the help of interface and implementation, the same should be followed in the proper way when it comes to correctness. So whatever I implement with the help of interface, it should be in the correct and the accurate path. So that is the first thing is the correctness. Next comes is the time complexity. Whenever you design for a web application, there is a major constraint which comes into a picture, like how much time does it take to execute from moving from one page to another. So solving this particular complexity comes into a picture with the help of time complexity. Running time or execution time of the operations of our data structure must be as small as possible. So that is called as the time complexity. The next comes is the space complexity. Memory usage of a data structure operation should be as little as possible. It means that whatever memory is being designed for a particular data structure should include that particular constraint, that it should not be that space complex. So memory usage of a data structure operation should be as little as possible. So these are the basic three characteristics of a data structure, that is correctness, time complexity and space complexity. So we had a better look of what are the features for data structure. Let's move on to the next thing, that why there was a need for data structure. Need for data structure. Before you create something, there should be something, because of this we created this. So these three reasons are the primary reasons which contributed for creating a data structure. So as applications are getting rich and data complex, or you can say which are more complicated and moving on to a big data perspective nowadays, then in such a case there was three more common problems which are observed nowadays. The first primary constraint comes as the data search. Consider an inventory of say 1 million items of the store. If the application is to search an item, then it has to go through this particular 1 million items. So just imagine you have an application with 1 million items and you have to search for a particular item. In such a case, what would you do? You will better give a search algorithm and call for each and every record. So imagine how much record you need to search and what will be the website condition. It will be so slow. So this would be a major problem. So if application has to search an item, then it has to search through particular 1 million items every time, slowing down the search. As data grows, search becomes very slow. So in such a case, it is important to introduce a data structure. The best example over here is nowadays you can see that there is something called as an auto search. Like just putting a letter or putting a keyword, you get a list of items associated to it. For example, if I want to search for a name from the particular list, say my name is Radhika. In such a case, I just put my letter as R and I get the list of possible solutions for that data structure or the particular search in my website. Then this is nothing but we are defining some kind of a protocol and we are following that particular protocol or the set of rules. So that is why it is important to include a data search in a very simpler way, because that should not slow down my website. Slowing down a website is a very major drawback. The next comes is the processor speed. Running time or execution time of operations of data structure, it should be very small as possible. So the processor speed should be in such a way that processor speed, although it's said to be very high, falls limited if the data grows to billion records. If you have a processor speed, like if for example I have a billion records and I have to search for a particular element or I have to list down for n number of items in it, in such a case your speed should be on a greater height so that you can list down all the elements required to it. Then comes is the multiple requests. As thousands of requests or thousands of users can search data simultaneously on a web server, Even the fast server fails while searching for a particular data. So that is why I can say, to solve the mentioned problems which I have mentioned over here, data search, processor speed, multiple requests, data structure comes into rescue. Data can be organized in data structure in such a way that all items may not be required to be searched, and the required data can be searched almost instantly. For that, it follows n number of execution time cases. So there are three cases which are used to compare various data structures execution time. So there is a worst case scenario, there is average case, and the best case scenario. Coming out for the worst case of execution is when there is a scenario like a particular data structure takes maximum time to operate. So that can be called as my worst case. Average case means there is a scenario depicting the average execution time of an operation of a data structure. Like it takes average limit for taking up the output in the particular data structure. Then comes the best case. This is a scenario depicting the least possible execution of time of a data structure. So these are the different type of the scenarios when we need to understand for the particular time cases. Let's move on to the next topic, that is to analyze the basic terminologies. Before you start up with the data structure analysis with JavaScript, it is important to get to know the basic terminologies, because these definitions we will be going on and off while in each and every tutorial. The first comes is called as the data. What is data? Data is nothing but a value or a set of value. So data can be said in the data structure as a values or a set of values. After that comes is the data item. So data item refers to a single unit of values. If you can say like I have a value and that particular value which has a single unit in it, and that can be called as a data item. Another word for data item is nothing but an element of a data structure. Then comes is the group items. So data items that are divided into sub items are called as the group items. If I can see that my data item can be divided further, in such a case that I'll keep that data item separately and I will name it as my group items. After that comes is the elementary items. So elementary items means data items that cannot be divided are called as the elementary items. If you can see there is a data item and which cannot be divided further, then in such a case it is called as an elementary item. Then comes the attribute and entity. An entity is nothing but the one which contains certain attributes or properties which may be assigned some values. Why I say an entity? For example, entity is nothing but a person. So a person has certain attributes like a mobile number, or I can say a phone number, or even I can say like the address of a person or a unique ID. So my entity is person which has these set of attributes in it. So that is why I say an entity is that which contains certain attributes or properties which may be assigned values. Entity set. Entity set means what? Entities of similar attributes form an entity set. If I see that I am also a person with which have same set of attributes in it, and some other person also include that particular attribute in it, then we two together combine as an entity set. Entities of similar attributes form an entity set. Then comes the field. Field is nothing but a single elementary unit of information representing an attribute of the entity. Field I can say is nothing like I have some elementary information in it and I represent a particular attribute of an entity, then that can be confirmed as a field of that particular entity. Then comes is the record. Record is a collection of a field values of a given entity. After this comes the next thing is the record is nothing but a collection of field values of a given entity, and then is file. File is a collection of records of the given entities in a given entity set. If I get a records and these records I have to save in a particular file, then I can say that definition as a file of a given entity. So this was understanding the different terminologies which are used in our data structure. Moving on to the next thing is to understand the basic operations. You will definitely go through these set of operations while you are creating a particular data structure. So let's have a look on each one of them. So what are these operations for and how to implement this particular operation? First is traversing. Traversing means like it's moving from one point to another. This can be moving forward or this can be moving backward. But you are moving from your location to another location, and that is said to be called as the traversing movement. Then comes is the searching. Searching, like I am searching for a particular element in my list. So that is searching. As I mentioned in earlier in a particular example, like I have a 1 million record in my inventory and I have to search for a particular record, then that operation of searching for a particular element is called as searching. And next comes is the insertion. You have n number of lists in your record, but you have to insert an element in between. In such a case, you can say that it is inserting an element in a record, which is called as an insertion property. Then comes is the deletion. So deletion means that I am deleting a particular element. It is unwanted. I don't want it right now in my data structure. In such a case, I say it is like deleting from my data structure. Deleting a particular element is such like you cannot again recall that particular element, or you cannot again add that element. Like there is nothing called as an undo option, which is like, okay, I deleted this element, let's try to add it again. For adding it again, you need to call for insertion operation. Then comes is sorting. You have to show a particular list. Like for example, I want to show a list in a alphabetical order. I have a list of elements. Say the inventory example, I have the inventory for 1 million inventory, but I want to show it in my alphabetical order. In that case, it is called for an operation of sorting. Sorting involves ascending as well as descending operation. It is not only for a particular string, it can be even for numbers. If I want to sort as per the number values, then that is also possible for data structure. Then comes is the merging. Merging, like I'm merging two data structures into one. Two arrays I'm concatenating into one. So that all operations combines to a basic functionality which is called as the merging. So these are the basic operations for data structure. First is traversing, then comes searching, then insertion, then deletion, and sorting and merging. In the next chapter, we will be focusing about arrays. First thing, we will understand what is array is all about, and after that we will implement an array using JavaScript. A basic example like a demo of array and how array is implemented in JavaScript. So let's move on to our next chapter, which is called as understanding arrays. Focus about understanding arrays. So this chapter is complete focus to understand what is arrays, our first data structure where we will understand the basic concept of an array, and then we will move on to the implementation of array with respect to JavaScript. Array is nothing but a container which can hold a fixed number of items. So it has certain elements associated to it, and there is also one more condition. It is like these items should be of same type, or I can say in specifically of same data type. So I can comprise these two statements as a single definition, saying that array is a container which can hold a fixed number of items, and these items should be of same type. Most of the data structures make use of arrays to implement the algorithms. So it is like the first basic, or I can say the topmost data structure which is used nowadays in our day-to-day life is nothing but an array. So array is one which includes something which is of same data type, and all the elements should be of same data type. That is the major constraint. Let's move on to the two basic terminologies which you will go through whenever you create a particular array. And while calling for this array, let it be not only in JavaScript or let it be in C, C++ or Java. While evaluating an array, you go through these two terms, and these are element and index. Element means each item stored in an element is called as an element. So whatever the item which is stored in an array, it is called as the element. Suppose my array has a values from 0 to 9. So my 0, 1, 2, 3, whatever each unit which I have are called as an element. After this comes the next thing, that is the index. So index means each location of an element in an array has a numerical index. If you have an element say from 0 to 9, then in that scenario, each element over there in the particular index will be called as an index, or it is like a position of a particular element in an array. So let's understand element and index with the help of our pictorial representation. So this is what is the array representation all about. Suppose I have an array. So this is my int array, means it is an integer. But in JavaScript, it is not declared in this format. We'll have a look how it is manipulated in JavaScript. But for now, it is like this is my array and this is the type of an array. So my array is of int type, means whatever values I will have in my array will be of integer type. And if I am saying 10, which means that it is nothing but the size of an array. So if I say my array size is 10, it means whatever elements I have inside my array, it should be within the defined length of 10. This comprises to the list of elements which are present in the array. So each element over here, if you'll get to know, is like I start with 35, 33, 42, 10, 14, 19, and all these elements, they comprise together inside this array. So array has three major points, which is like index. It always starts with a 0. You never start an index or the position of an array with 1. It always starts with 0. If array length is say 10, then it should comprise of 10 elements. So my array index position number will start from 0 and it will end till 9. So it will be like 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So my index numbers will be up till 9. Each element can be accessed via index. If I am saying I want to get the element, or I can say the element which is having index say 2. So it would be 0, 1, 2. So my element respect to the index 2 number is 42. So each element in the array can be accessed via index. So this is the basic points when it comes to array. Now moving on to the array operations. So there are various set of operations as we have seen in our previous chapter for data structures. So similar way comes over here with the array. So first one is the traverse operation, or the transverse, or you can say the traverse kind of an operation, which prints all the arrays one by one. It is like it moves from the index position of 0 to the next position. Consider for the slide again. Here my traverse position will be, it will be moving from this point till this point. So it will move from 35 to 33 and then to 42 and then to 10 and so on. And this was the basic need for the traverse operation. Next comes is the insertion. When you want to add an element to the given index in such a scenario, the process it is called as the insertion. Then comes deletion. So for insertion, it follows the basic algorithm. It checks whether the array length is specified or if it has occupied. If I get the array length is occupied and the array length is 10 and it has 10 elements in it, then insertion will throw me an error. On the other hand, if the array length is 10 and there are say suppose 8 or 9 elements, it means that there is some empty space left, then my insertion will be successful. Deletion. So deletion means removing a particular element from an array. So deletion will be successful if the array length is at least 1. So it should be at least 1. It should have at least one element in it. If there is no element in it and still you are specifying, suppose for example there is no element present in the array, but still you are specifying for the deletion operation, in such a case, it would return the value, or it would return some kind of an exception saying that the deletion would not be possible. So in both these scenarios, insertion and deletion, these points should be kept in mind. Then comes the search. As we have seen in our last chapter, search is a very primary important motive for a data structure. Let it be any kind of a data structure. Say for an array, say for linked list, say for stack, for queue or anything. We have the search operation, and search means searching for a particular element. So for an array, it is very simple. Considering for a single dimension array, in our further chapters, we will also have a look on multi-dimensional array. But for a single dimension array, let's keep this in our point as a basic example. Search means searching for a particular element in that given array. For that searching, we need to call for some algorithm, or we need to follow an algorithm. So searching is a very primary criteria. You should search for a key or a value, or you will search for everything which is associated to that array. So searching may also low or it may slow up your website. So you need to design the algorithm properly as per the requirement. Then comes is the update. Say now you have 10 elements in the array it's full, but you want to update the particular index element. Say for example, in this example we saw, if I call for index 2 element, then that is 42. Instead of 42, I want to replace it as 44. Then that operation or that process will be called as an update. So these are the basic array operations when it comes to a data structure point of view. Moving on to next thing, we need to analyze now. Now in this complete course, we are focusing on implementation of data structures using JavaScript. So we will analyze now how an array is designed in a JavaScript. So this is my array. Say my array has initialized with a variable, say var average temperature. This is the variable name, and it is initialized with two brackets which is mentioned over there, that is the square brackets, which means that I am calling for an array. Here I insert as per the index. As I mentioned, the index number of an array always starts with a 0. So I always say that with the variable name and specifying the index inside the square brackets, and I'm assigning the values. So for 0 I'm assigning 31.9. For the index number 1 I'm assigning 35.3. For 2 I'm assigning 42.4. For 3 I'm assigning 52. And for 4 it is 60.8. So it is like all the float numbers are there and they are of the same data type. I am not including any string in between. So they are of same data type. It means that all are numbers. So I have assigned the array inside it. So my structure of array in with respect to JavaScript perspective would be in this format. The index number of 0 will have 31.9 as I mentioned, 1 will have 35.3, and 2 will have 42.4, and 3 will have again the same value, and so on. So this is how a structure helps in JavaScript. The other important point comes into a picture, like arrays in JavaScript as compared to any typical programming languages, say for C, C++ or Java. The implementation of arrays in JavaScript are very flexible. There are several ways to create arrays, access arrays, and perform tasks such as searching, sorting the elements which are stored in the array. From JavaScript version say 1.5, it also includes certain array functions which allows the programmers to work with arrays using functional programming techniques. So let's move to our code base. We'll create a code base. There I will show you the basic example of creating an array and how the array is being accessed. And then we will move on to our next chapter where we will have a simple example which shows the implementation of arrays with respect to JavaScript. So this is my code base. I'm using Visual Studio Code. That is a better coding editor when it comes to JavaScript. Now I have a project base and I have arrays in it. Here I create a sample file, say array demo.js. Okay, here I will just show you what are the simple illustrations, like what are the syntax for creating an array and how we print a value. And then we'll move on to our next chapter where we will link an HTML page to this array and we will get the desired output which is needed. After showing it in our code base, I'll move on to our shell. I can see the JavaScript shell where you will get the desired output. So declaring an array is in this format. It's like you have to declare a variable and with the variable name. See, my variable name is numbers, and then I give an empty array and a semicolon, which means that I have declared for an empty array. I'll mention this in my comment that this refers to declaring an empty array. Okay, I'm done with this part. And after this comes the next thing is to print these numbers. So now there is nothing, so I'll not print my numbers for now. Another way of declaring an array, I would say, it's in this way. So there are various flexible options for declaring an array in JavaScript. So another way is like you have to just say var number equals new array. So that's all. This also initializes your array. So this is like initializing a variable, as array. So these are the two basic things when it comes to JavaScript. To get the length of the array, it is done with the help of dot length function. So that will be done like, if suppose I have to print in my console, so it should be done as console.log numbers dot length. So once I'm done with this part, so dot length will show me whatever the length parameter has. So this was about the array declaration. Let's move on to our shell. So this is my shell. So here I'll declare my array. So declaring of an array will be done the same way we did for now. So here I'll not declare an empty array, I'll declare an array with some values, say for 4-5 values. So here I'll say var numbers equals, I initialize it with some values. So the values would be 1, 2, 3, 4, 5. So I have taken 5 number values. Now I just say print numbers. So it will print me all the numbers over here. So print functionality is to print whatever the value I have. Now I want to print the number length. So I'll just say print numbers dot length. So the number length is 5, starting for the index number 0, 1, 2, 3, 4, 5. 4. Index number will be till 4. So this is the way you can create an array. Now let's start off with the constructor. Now I'm initializing my array again, the same I did with my code base. It's like var numbers equals new array. In that scenario, let's again check for my numbers. Now I'll get an empty value because I have reinitialized my array as an empty array. So that is why I'm getting as the empty value for the array. So this was about the array declaration, like how an array is being created. Now how to access a particular array. So accessing an array will be in this way. Suppose I want to access the array with the index position of say 3. So I will just print over here as numbers 3. So this will be like, you have to just include the print functionality, that is print numbers 3. Now it will not show me anything because I have reinitialized as the null value of the array. Let's again initialize my array. So I have taken 5 numbers over here. I'm getting 1, 2, 3, 4, 5. Now I will print my array. Printing of the array numbers of 3. So index position 3 is printing me the value as 4. So in this way you can access and write a particular array elements. You can also create an array from the string. Suppose you have a sentence, then you can create an array from that particular string value. So this is our code base. Here we will start with implementing arrays in JavaScript. For that I'll just create an HTML file inside my arrays folder as array example.html, and here I'll start with my doc type declaration. So I'm just increasing the font size so that it would be visible. So my doc type declaration would be doc type HTML. Once I'm done with this part, I'll start with my doc type declaration as HTML tag, and my HTML tag will be enclosed with head and body tag. So starting with the head tag, it will be head, which includes of a meta tag. So it will be meta char set UTF-8, and then I'll start with my title. So my title would be as title execution of various array methods. After this I'll take a body tag. My head tag is completed over here. So I'll also take a body tag. So my body tag will be enclosed with, first thing is the h2 tag, like a demo example of, it's a demo example of JavaScript implementation with array. And then I'll call for a script tag. So my script tag will have script type equals text JavaScript, and this will be enclosed with a src tag, that is I'll call for a JavaScript file, so that my JavaScript file will be array. This is array example, so my JavaScript file will be array example.js. So this is my HTML file. So let's go inside our browser, like I'll run this particular HTML file and check how it looks. So this is the demonstration which shows for my HTML file. Here I just get the h2 tag, but now I have not called for any of my console. So my console will not show anything because one file is not found or we have not created that. So let's go to our code base. So this is my code base, and over here I'll create a new file, and the name of the file will be array. First of all, I'll save this file inside arrays as array example.js. Here I'll create the complete code. Now let's start with the first thing is to create a number line. So my first implementation of array data structure in JavaScript is creating a number line with the help of arrays in JavaScript. So creating number line begins in this way. So first thing, I'll create a variable. Say my variable is 0 equals 0. Then I'll say where positive numbers. So I'll have positive numbers over here. Say 1, 2, 3. And then I have another variable. Say my negative numbers as -3, -2, -1. So I have declared my variable 0 and positive as well as the negative numbers. Now I'm going to concatenate these two numbers. So concatenation of two arrays would be done with the help of a function, inbuilt function in JavaScript, which is called as concat. So I'll say where numbers equals negative numbers dot concat. So it will call for concat functionality, and here it will concat two things: the 0 value with the 0 variable which is there, and the next is positive numbers. So it will concat positive numbers as well. So now with the help of this concat function, I'll mention in my comments. So this is actually used for concatenating two or more strings. If you will focus now over here in this example, my numbers will be concatenated in such a way that it will print -3, then -2, then -1. After that, it will take a 0 value, and then it will concatenate the positive numbers, that is 1, 2, 3. So let's go to our browser. Before that, I'll just print my numbers. So printing the numbers would be in this way. It will be console.log numbers. So this was the first functionality, or I could say my first output. So I'll just mention over here as this is my output 1. Now I'm going in my browser. Here I'll just reload the page. Now you get the output over here. See, I'm getting it in my console because it is a JavaScript language. So everything printed over will be somewhere associated in the console. So here I'm just checking for my number. So I'm getting a number line properly with the index of 0 as -3, 1 as -2, 2 as -1, 3 as 0, 4 as 1, 5 as 2, and 6 as 3 with the total length as 7. So concatenation operation in array was successful with respect to JavaScript. Now let's take our next example. So next example is to check it is like whether the particular variable is even or not. So I'll create a variable, say where is even. So where is even will have a logic associated inside the function. So my function will be equals function taking a parameter as x, and inside x I'll take the logic designed for is even. So for that I'll check it with the comment that it returns true if x is a multiple of 2. After that, it will say console.log x. It will print the value for x. Now I just want to check, this is a function, so it is taking some parameter. So we need to return a value inside this function. So I'll just do return x modulus 2 equals 0. So it will return the modulus part of it, like whether it is true or false. So if I get 0, it will be true. If I get it as 1, it will be true. For 0, it will be false. So I take this with the help of this operator, which checks for a decision support operator. So if I get as 1, it will be true, or else it will be false. So this condition is given. So is even is a function which takes as x parameter, and the x parameter checks with this modulus, like whether I get it as 0 or whether I get it as 1. Now I declare a variable. So my variable is, say, where numbers 1, because I have already declared numbers over here. So I'll declare a new number, and here I will initialize my variable till number of 15. So it would be 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I've declared it. Now I just need to do one thing, is to check whether my numbers 1 inside this is even function. So for that, for going each and every element inside a function, there is an inbuilt function in JavaScript called as every. So what does every does? It just prints the values. So if I say numbers 1 comma every, and inside this I will say is even. So this is my function. So this will do a basic thing, is like it's going to execute the function only once with every element. Okay. So once it has executed, it is very easy to get the console. So I just print the console over here. So I'll do a console.log with this functionality. So let's go to our browser and check. So on running the look, I get a value as 1 for the console of x, where only one number I'm getting, like for my variable, say it begins with 1. So it checks 1 modulus 2 is actually not equal to 0, so it's false. So it just execute it with once. It executes a function only once with a random number from the given array. Now you need to check out for the length of this array. So for that, there is a simple function. Here only I print the value as console.log numbers 1 dot length. So this will print me the length of the array. Should be numbers 1 dot length. So this is actually output 2 for printing the length. So this is printing up the array. Let's go to our browser. Now on refresh, I get the length of the array as 15, which means that my array had 15 elements in it, which is clearly visible over here. So this is a way array length functionality takes place. There is also a function for example, say for comparing. So for comparing, there is an inbuilt function called as compare. So how the compare function works, let's have a look. So I have function, so it is function compare, and it takes two parameters a and b. Inside this, I will check the first thing, if a is less than b. So if a is less than b, in that scenario, it will print the according value for the comparison. So if I get something like this, so I will say return return -1. On the other hand, another condition, if A is greater than B, then I return a value as 1. Now I just copy paste this particular condition and then check out. So if A is equal to B, this condition is not needed also, but still, if A is equal to B, then it should return 0 equals B. If you will remove this particular path, your statement should specify with the return statement as return 0. Now to call for this function, I will just say, I'll sort out my numbers. So I'll pass with two parameters. So I'll say console.log. Say for example, I'm passing parameters 15, 14. In such a scenario, A is greater than B, so it should return the value as 1. So here I call for the function as compare, and compare is taking two parameters over here, that is 15 and 14. I'll again take this statement, just copy paste it and take two values over here. The value over here is 11 and 14. In such a scenario, it should return -1. After that, I take one more value, so both the values A and B will be 14. In such a scenario, it should return as 0. So let's go to our browser. So in my browser, it is reload my file. So here I get the desired output the way I need it. 1, because if you check in our code base, 15 was greater than 14, so which means it is returning a value of 1. Other case I gave 11 and 14, so that is why I'm getting it as -1. And after that I'm getting the value as 0 because my value of A and B is 14 and 14. So this is the way various manipulation takes place with the help of JavaScript implementation in an array. Next chapter would be complete focus about understanding the multi-dimensional arrays and how to get the multi-dimensional array executed in our program. So let's move on to our next chapter where we will understand the multi-dimensional arrays first of all, and then we will check our execution or implementation of JavaScript with multi-dimensional arrays. Usually JavaScript arrays are only one-dimensional. But you can create a multi-dimensional array by creating arrays of arrays. So this is a picture which depicts creation of arrays where we have a number of rows and columns in it. So in this section we will focus on creation of two-dimensional arrays. So two-dimensional array is just like a structured spreadsheet. Consider for this one, this is the two-dimensional array where I have rows and columns associated with it. To create a two-dimensional array in JavaScript, we have to create an array and then make each element of the array to create another array as well. So it is like a structure which includes array of an array. So that is a JavaScript focus all about. At the very last thing which you need to keep in the mind, after creating arrays of an array, you need to print this particular array in such a format that it will print the one-dimensional array. It is like you have to process this particular two-dimensional array as a one-dimensional array. So this is how it works, where we have row 0 with the columns. And when we specify A0 of 0, which means it is of row 0 and column 0. And A0 of 1 means it is accessing row 0 and column 1. So this is a way of accessing a particular elements in the array of a JavaScript. So this was a typical pattern. So one pattern emphasizes accessing arrays by columns. So this is either you can access arrays with the help of columns or you can access arrays with the help of rows. Let's go to our code base where we will create an HTML file and their associative JavaScript file and check how we get the particular multi-dimensional array being processed inside JavaScript. So this is our code base. Here I'll create a new file and save it inside my arrays folder, and the name of the file will be two-dimensional array .html. Now I'll declare for the doc type. We'll follow the similar pattern the way we did in our last chapter. Doc type HTML. Inside this I'll specify HTML tag with head tag. So first will be our head tag. Here it will include the tag as the title. So first thing I would like to mention over here is the title. So title here will be two-dimensional arrays. After that comes the next thing is the meta tag. So meta cassette UTF-8. So this is my meta tag which is mentioned. Then comes my body tag. So inside body tag, I'll call for the h2 tag, which says it is the example of two-dimensional arrays. So this was the first constraint. After this comes my script tag. So my script tag will be script type equals text JavaScript, and after that I'll call for the source tag, which says it will call for two-dimensional array. So I'll call the same way we had for HTML file, the same we'll have for our JS file. So it will be two-dimensional array.js. So I'm done with my script tag. After this, what is the next focus? The next focus is to create a JavaScript file. So I'll create a new JavaScript file. So this will be my new JavaScript file. Save it as two-dimensional, the way I did over here. But here I'll call as .js file. It's not an HTML file. Now inside this, the first thing I'm going to do is create a particular array, print it, and later we will access that particular array with the help of for loop. So here I'll create an array. So my first array is say var average temperature as temp day 1 equals the average temperature is represented as 72, 75, 79 twice. So this is a simple one-dimensional array. So I created one variable average temperature day 1. After this, I'll just copy paste this particular format and I'll create one more array. So here I will say it is the average temperature for day 2, and the values will be, obviously the different values will be associated over here as 81, 79, 75, 75, 73, 72. So I have done with my two arrays over here. Now I will do one thing with respect to my index of 0. Okay, so this would be my first, this was illustration with respect to single dimensional array. Now starting for two-dimensional array. So this was my example for single dimensional array. Now how to declare a two-dimensional array? So the best approach for this is like, first I'll declare a variable where average temperature equal to blank array, and after this I'll specify my average temperature. Okay, average temperature of first index, it will have the first index 0 over here as the value which I declared over here. So this is like I'm creating array of an array because JavaScript supports this kind of a multi-dimensional array pattern. In the similar way, I'll create for index 1. So for index 1, I'll just rename these values with the values which we created over here. So I just create a value inside this. So JavaScript supports this kind of a pattern because it supports only one-dimensional array. It does not support matrices. However, we can implement matrices or multi-dimensional array using this particular standard of including array of an arrays as in the mentioned example. Now, if you want to go for another value, so I'll just create a matrices with the column the way I mentioned in my diagram. So it will be like row column. If I say 0, 1, it means row 0, column 1. So let's assign each values over here. So my values will be here for day 1. It will be printed as average temp 0, So 0 will be my row, corresponds to an empty array, and there it will call for average temp 0 of 0. So it means row 0, column 0, that is the first value will be 72. In the similar way, I'll call for other values. So here other values will be 0 of 1, that is 75. This is this associative value. So I'm doing in that way. Again, I'm copy pasting this particular value. Row 0 of 2 means the second column will be 79, and so on. So this is the way the representation takes place in JavaScript. The next will be row 0 of 3, that is again 79. Again it will call for another row column which will be 0 of 4, which means row 0 fourth column, which will have the value as 81. And after that it will be row 0 and fifth column, which will call the value again as 81. So this was my first declaration. For day 2, I'll call again for the matrices in this way. It will be matrix, it will be array of, and it will follow the same pattern, but the values here will be for column, for row 2. So it will be here as mentioned as 1 with the value of 1 of 0, and 1 of 0 will be value 81 because the value over here is 81. So here it will be 81, and then it will call for the next value, that is 1 of 1, so that will be 79, and after that it will be 1 of 2, so 1 of 2 value will be 75 as mentioned over here. Then I have the next value, that is 1 of 3, so that will be again 75, and after that it will be 1 of 4, that is 73, and then comes the next value, that is 1 of 5 as 72. So these values are called. So this array representation, how it looks, let's have a pictorial representation of how my multi-dimensional array in JavaScript will look. So this would be the structure. Here I assign 0 of 0 value as 72, 75 for 1, 79 for 2. So this was my pictorial representation of two-dimensional array. So my matrices will look in this way when it comes to JavaScript. Now let's analyze in our code and just run this example in our browser. So this is how I get it, like example of two arrays. But now, for now, I have not printed anything in my console. So printing some value in the console, we need to go to our code base, and here I'll specify console.log average temp. So this will give me the complete print or the complete access of the array. Like it is like we have two arrays embedded in it, and each has a 6 character to it. So it is like 2 by 6 value. So here we have a matrix with a 2 by 6, that is 2 rows and 6 columns. And these are the values associated to it, which we created right now. Now let's create a function. So my function would be, here I will mention for the function as function, and the name of the function will be print matrix. So I'm going to print my matrix as print matrix, and inside this I'll specify my matrix, that is the attribute I would like to send or the parameter. And here I'll call for the for loop. So my for loop will be for variable I equals 0, and after that I less than my matrix dot length. It will call for the length of my matrix, and then I plus plus. So this is like calling for the associative row. So this was for the row, first for loop. Next for loop will be for column. So here I'll say variable j equals 0. J will have a value less than my matrix of I. So it will go with the index of I dot length, and then it will increment my loop. So it will increment my loop with increment operator. So we have access with respect to row and with respect to column, and then now I'm going to print my console. So my console would be my matrix I j. So with respect to index as well as columns, I'll have my each and every element printed over here with the help of this function. So we can call the code with the help of a simple parameter like which is mentioned over here, that is print matrix. I'll call my function now, and I'll send my array, that is average temperature, over here. So let's go to our browser and check how the code is executed. So in this way I get the code as 72 because I have the first element 0 of 0 is 72, then 75. Twice I'm getting 79 because my value of 79 was repeated. 81 is thrice because 3 times it is repeated, then it goes to 79, then 75, then 73, then 72. So each and every element is printed as mentioned over here. If you will check in our figure, so let's go to our figure. Printing of the matrices was in this particular pattern. Like it was in 72, then it printed for 79. Twice it was showing 79 because it was occurring for the second index number as well as third. It is like 0 of 2 also has 79 and 0 of 3 also has 70. Then thrice it was 81 because 0 of 4 was 81, 0 of 5 was 81 and 1 of 0 is again 81. So that is why it was giving a value as 3 times 81. Then it moved to the next value, that is 79, then 75. Twice it was repeating and twice 73 value was printed. So in this way a systematic approach is maintained for printing a particular multi-dimensional array in JavaScript. So JavaScript actually does not have any support for multi-dimensional array, but you can manipulate it. Like you can keep a best approach for keeping a multi-dimensional array is like creating array of an array. So with the help of this manipulation, like creating a particular array of an array gave you this matrices structure. Like we had this 2 by 6 matrix, and in this matrix we got the complete structure, and we also saw a for loop or a function through which we executed for printing elements of each and every array. So which is like a very good plus point. So this was implementation of multi-dimensional arrays in JavaScript. Moving on to our next chapter will be understanding about the list, which is not a linked list, which is quite unique than linked list, which is a simple list which we go through our day-to-day life, or a simple thing I can say to-do list, which is also a part of a data structure. So let's move to our next chapter for understanding the list. Lists are one of the most common organizing tools people use in our day-to-day lives. We have to do to-do list, grocery list, top 10 list, bottom 10 list, and many other types. Our computer program can also use lists, particularly if we only have few items to store in the list form. Lists are especially useful if we don't have to perform searches on items in the list or put them in some type of sorted order. When we need to perform long searches or complex sorts, list becomes very useful. So as I mentioned, we have this list kind of concept in our day-to-day life. So that is also a kind of a data structure. When we need to perform long searches or complex sorts, list becomes very less useful because they are of complex data structure type. So if I want to say about the definition for list is a ordered sequence of data. It's like you put a point-wise list every time, like step number 1, what is to be needed, step number 2, and so on. So that is a pattern of a list. Each data item is called as an element. So whatever the data item which is mentioned in the list is called as an element. So every data item stored in a list is called as element, and in JavaScript, the elements of list can be of any data type. So this elements of the list can be of any data type when it comes to the module of JavaScript. It is also called as the abstract data type, which is nothing but the abbreviated form called as ADT. One more thing which should keep in mind, a list with no elements is an empty list. The number of elements stored in list is called the length of the list. Internally, the number of elements in a list is kept in a list size variable. You can append an element to the end of the list. You can insert an element into a list after an existing element or the beginning of an element. Elements are deleted from a list using remove operation. You can clear a list so that all its current documents are removed. So let's check out for the list class implementation when it comes to JavaScript, how we create a list class, how it is implemented properly, and how to perform the JavaScript implementation when it comes to a data structure called as list. So this is my code base. Here I have a folder named list where I'll create a new file, and the name of the file will be list.html. So I'll create a file with list.html. Here I'll create the doc type representation. So my doc type will be doc type HTML. Once I've created with the doc type, I can start with the HTML tag. So this is my HTML tag. Now inside the HTML tag, once I've given the doc type declaration, after the declaration of HTML tags, I need to start with the head tag. So I'll start with my head tag, and head tag will have meta tag, that is meta cassette UTF-8, and inside that I'll specify the title. So the title for me will be list implementation in JavaScript. So I'll just give a title as list implementation in JavaScript. After this, I'll specify the body tag. So inside the body tag, I'll call for my h2 tag, which mentions this is the list example in JavaScript. And after this, I'll specify the h2 tag, so the src tag, like the script tag. So I'll specify the script tag, and the script will have the source file in list.js, which we will create right now. So this completes my list.html file. After this, I'll create a new file, and the name of the file will be the same one which we have sourced our link to, that is list.js. Here the first we will begin with implementing a particular list. So implementation of a list starts with a list class. So class is declared inside function list, and the parameter list as L in capital, and the function will begin now. So list function will include some of the parameters. So that parameters is list size to get the list of the, or I can say the size of the list, list size equal to 0. Then comes the position, so I'll say this dot position equals 0. Then comes the data store, that is data store is nothing but the value present inside the list, so that will be nothing but an empty array. So it initializes an empty array. After this comes clear. So this is like this dot clear equals clear. So these functions will be initialized basically inside my constructor. And after, there is one more function to find a particular element in the list. So that is done with find. Okay, let's give proper indentations. That is like it good for programming practices concern. After this, I'll specify two strings, that is this dot toString equals toString, and after that it will specify the remove method. So it will be this dot remove equals remove, and then comes the length parameter. So length will be specified in this way, this dot length equals length. So these are the basic parameters which are used when it comes to list. After this comes the length of the list calculation. So here I'll specify length of the list as function length, and length will specify the list with respect to the list size. So it will return a value this dot list size. So this was for length of a particular list. After that comes appending an element. So for appending also you need to append a particular element. So for that you need to initialize over here. So that is very important. Every functionality should be initialized. So this dot append equals append. Check out for the proper spellings. So I have declared for length of the list. After declaring length of the list, the next part is to declare the appending of element. So append an element. So that is done with function append element. Inside this I'll specify the append parameter as this dot data store with this dot list size plus plus equals the element. So it will append the element to the last of the list. So it is like in the last, after I get the particular list size, then the incremental value of the list size will append the particular element. Then comes removing an element. So removing element will also have the logic associated to it, removing the element. So that is done in function find element, and after that I'll specify removal of the element with the for loop. So that is for where I equals 0, I less than this dot data store dot length I plus plus, and over there I'll specify if this dot data store of I equals element, then it will return the element I. If I don't get this particular logic inside the for loop, then it will return -1. So it will return -1. So this is a logic for finding a particular element, or we can say it is for actually to get a particular element. It's like finding the element. After that comes the logic for removing an element. So removing element will be, the last logic is for removing an element. Removing an element is done with this logic as function remove element, and inside this I'll specify where found at equals, it will find a particular error for finding an element, whether it is existing or not. So I'll say to check if the element is present with the perspective of the variable, and then if the found at element is there, if found at element is there, will be checked if it is greater than -1, then it will use a JavaScript functionality called as splice, that is to remove a particular element from the array, and it will return the value. So this is the basic logic. After this, it will decrement the list size. So it will say minus this dot list size, and then it will return as true. So if this logic is successful, then it will return true, or else if I get that if found out is equal to -1 or it is not satisfying the particular condition, then it will return false. So this is a logic for removing an element in list. So this was about getting out the element thing. Now we will do one thing, is to create a particular list element in the string format. So that is done with the help of toString. So I'll just say function toString, and over there I'll mention the toString logic will be nothing but to return my string value. So that is this dot data store. So it will return the complete data store set. Now let's initialize the list. So I'll say where names, I'll initialize my list as where names equal to new list. So this was my class, and after this I'll say names dot append, and it will append the values. So my first name is Cynthia. After mentioning the first name, I'll call for the next name. So that will be names dot append. It will call for function names dot append. The name will be, say for example, Raymond. So these are the demo names which I'm giving for now. Then after that, the next name, the last name I want to append is Parker. So in this way I specify the name values, and after that I print console as console.log names, and also I will print in toString format. So for that I'll say console.log names.toString. So this will help me to print a list in the string format. Now let's go to our browser and check whether I'm getting the proper output as desired for the particular list. Before that, we'll also include a logic for clear. Like suppose you want to clear a particular list. So I'll say function clear, and I will call, like I will return data store as null. So this will clear my complete list. Let's go to our browser. So this was the list.html which we created now. Now if you check in on my console, I get a list format over here which is calling for a number of functions, and the data store includes of 3 elements. So we added 3 elements, so that's why I have Cynthia, Raymond and Parker. Now on the other hand, if I specify the element of Cynthia, so this is like I'm getting for the toString format. So I call for toString, which was my console. If you get in my browser and the code base, this my console printed for name.toString, which has been printed properly here. So I have 3 elements, the length is specified over here as 3, and I am getting the values over here as 3 elements. So this is a way like it is very beneficial to print a list and how to get it done. Now if you want to check it with a number of functions associated to it, you can try using that also. You can try with the various functionalities like clearing a particular element, inserting a new element, or even finding an element from the list. So these logic are implemented, and this is the way JavaScript usually tries to implement various type of list and execute the test cases or whatever the use cases is designed for the particular list. Now moving on to our next chapter will be a complete focus about understanding stack, which is a proper data structure most commonly used after array. So we'll have a look about stack, the functionality, and then we will implement various type of logic with stack and what all logic can be developed with the help of stack. Stack is one of the data structure which we will focus for now, and it is called as a ordered collection of an item. In the previous chapter we saw about list as a natural form of organization for data. We have already seen how to use a list class and how to organize the data in a particular list, and that we had a look in our last chapter. When we order a particular data being stored, it doesn't matter, or when you don't have to search the data stored, list works wonderfully. For other applications, plain lists are too simple and we need a more complex list like data structure. So for that, there is a picture which comes into our mind is analyzing about that. A list-like structure that can be used to solve many problems is computing is the stack. Stacks are efficient data structure because data can be added or removed only from a top of stack, making these procedures fast and easy to implement. Stacks are used extensively in programming languages implementation for everything from expression evaluation to handling functions. So stack is nothing but an ordered collection of an item, and here there is a main case which takes place is that stack is a list of items that are accessible only from one end of the list, which is called as the top. That is why it follows a typical pattern which is called as a LIFO structure, that is last in first out. The addition of the new items or the removal of the existing item, everything takes place at the same end. One common real example of a stack which comes in my mind is like stack of trays in a cafeteria. You go to a cafeteria, you have a particular set of trays, or say for example you go for some buffet. There you take a plate and you take a plate which is present in the top of your particular plates. You don't take a plate in between. So that is a typical example for stack. Trays are removed from the top, and whatever which are washed and whichever you want to put a tray, that is also kept on the top. And when the trays are put back on the particular stack after being washed, they are also placed on the top of the stack. So that is why stack follows a structure which is called as a LIFO, that is last in first out. Because of the last in first out nature of the stack, any element that is not currently at the top of the stack cannot be accessed. So that is also a kind of a drawback. To get an element at the bottom of the stack, you have to remove or dispose all the elements on above the stack and get it. So let's understand the diagrammatical representation of stack. So this is a basic structure of a stack. So there is a push and there is a pop operation. Stack can be implemented as an array, a structure, a pointer and a linked list. Stack can either be of a particular fixed size or it may have a sense of dynamic resizing. As I mentioned, the real world stack, it always takes from one end only. There is also one more example is like you have a stack of cards, stack of plates. So likewise, stack, which is also an abstract data type, that is ADT, like the one which we had in our list example. So stack ADT allows all the data operations at one end only. at a given time, we can access the top of the element of a stack. This feature makes it a LIFO data structure. LIFO meaning last in first out. So here it is placed like it is inserted and added. So last is accessed first. So in stack terminology, we have two operations basically for stack which is visible in this figure, called as push and pop. Push means you are adding a particular element. Pop means you are removing a particular element from the stack. So we are going to implement stack using arrays, and we will keep one notion in our mind, is that we need to keep a fixed size of stack implementation when it comes to JavaScript point of view. So basic operations over here is push and pop. So this is the overall structure for the stack. We have all these data elements listed, and you are adding the data element at the top of it, and the one which is accessed is the top element which is also removed. So it is not like in between something you remove this particular data element. If you want to access this data element, you need to remove all these data elements, and then only you can access this data element. So that is a major drawback for stack. Let's analyze each of these, or we can say the operations which are associated to stack. So basic operations begins with the first one, that is push. Pushing, or I can say storing an element on the stack. So that is done with the stack operation of push. Before starting off with these operations, stack operation may involve initializing a stack, using it, and then deinitializing it. So once we initialize a particular stack, we have this list of operations to be performed, and then again we deinitialize it so that my stack is ready to be used. My data structure is then ready. So push operation is nothing but pushing an element on the top of the stack. And pop means removing, or it can be even accessing a particular element from the top of the stack. So everything happens on the top of the stack. Then comes like when a data is pushed onto a stack. So you have your stack ready. To use a stack efficiently, we need to check status of the stack as well. So we need to have some operations for having the status of the stack. For the same purpose, these three functionalities are used in the stack. First one is the peek functionality. Peek to get the top data element of the stack without removing it. So peek functionality is such that you have to access the top of the stack without even removing the stack. So it is just like you are accessing a particular stack without performing any kind of operation such as removal or addition. Then is full. Is full is like you have a predefined stack structure with some amount of length in it. You are just verifying whether the stack is full or not with the help of this functionality is full. So it's clear from here that we are just checking whether my stack is full or not. Then comes is empty. Is empty is to check if the stack is empty or not. If my stack is empty, then I can add new elements. So is full will help you to check if whether I can add an element. If I get this is full value as true, then obviously I can't add an element. I will get an exception or some error should be managed over here. And is empty is a scenario where you particularly say I'm going to remove an element from the stack, but I get is empty value as true. Well, in that scenario, you get an error that there is no element which is to be removed from the stack. So how will you remove it? So in such a scenario, these two functions are very useful. So at times we maintain a pointer at a last push data on the stack. As this pointer always represents on the top of the stack, hence it is called as the top, the one which accesses the top. The top pointer provides the top value of the stack without actually removing it. So these were the basic operations for the stack. So we will perform all these set of operations in JavaScript. Prior to checking for various type of the implementation of stack with the help of JavaScript, which you also analyze that there are two major operations in stack that comes with pop and push. So pop is like we are removing an element from the stack. So this is the diagrammatic representation for pop. So it follows some set of step, or I can say some algorithm which is followed for pop operation in a stack. So step number one is that this is my stack. Here I check if a stack is empty or not. So it is like accessing the content while removing it from the stack. It's called as the pop operation. And in array implementation of pop operation, the data element is actually removed. Instead, top is decremented to a lower position in a stack. So it is like this is my top element and this top element is given access to the next element. Instead of top is decremented, but the linked list implementation of pop actually removes the data element and delocates the memory space. So that is the two major concepts. So for linked list, we'll have a look in our further chapters. For now, keeping one thing in our picture, we are going to implement stack as an array representation because we had a brief about array in our previous chapter. So for pop, step number 1, it checks if the stack is empty. It checks whether the stack is empty or not. Okay, if I check the stack is not empty, it means that some elements can be removed or the pop operation can be done. So if you can see over here, I have 1, 2, 3, 4, 5 elements. So it is like my stack is not empty. But if this scenario occurs that if the stack is empty, then it produces an error and exit operation takes place. But on the other hand, in this scenario, we are getting that stack is not empty. So it accesses the data element at which the top element is pointing. And it decreases the value of top by 1. So this will be my top element and it removes the topmost element, that is my element E will be removed, and it returns a success value. The same situation arises for push. So push operation is such that it does the addition. So for that, the first thing it always checks is that if the stack is full or not. So step number 1 for push operation is to check if a stack is full or not. For me, I have some memory allocated over here, so my stack is not full. But on the other hand, if the stack is full, if the stack is said to be full, it produces an error and exit. On the other hand, for now, I have some memory allocated over here. It means that my stack is not full. So if my stack is not full, it increments the top value. Say for D value is given the top value. So my element of E will be added over here and the top value will be assigned over here to E. So it adds a data element to the stack location where the top is running and it returns success. So that is what is a major focus for understanding the algorithm for push operation. So we had an overlook of what is stack all about with various type of the operations. Now with the next chapter, we will implement this complete logic with the help of JavaScript and analyze how stack functionality actually works. So this is our code base and here we will start with our implementation of stack using JavaScript. So inside this, first thing is like I would like to create a folder. So folder inside data structures. So within that I will create a new file. So first of all, let's start with creating a file. So that is doc type HTML. I'll save this file inside data structures and the new folder would be with stack implementation. So here we'll check for everything related to stack. So my first example is stack demo. So I'll just give it as stack demo.html. And here I will create a file with the HTML tags. So I've created the HTML tag. After that comes the head tag and head tag will have the title. So my title tag is stack implementation. Okay, prior to that I will also include a meta tag. So that is meta char set utf8. Now I will include a body tag. So my body tag will have the h2 tag which says this is the first example of stack with JavaScript. And after that I have the script tag. So this is my script tag which it has of the type text JavaScript and it will source it to stack demo.js. So I'll say it as stack demo.js and I'll just close this tag. So this is how I created for the HTML file. After this, the next comes into our picture is to create a new file which is stack demo.js. So this is a JS file. Here I'll create a function for stack the way we did for lists, for arrays and everything. So similarly we'll do function. So that would be function stack and within this I'll call this dot data store and after that I'll call for top. So I'll say this dot top equals 0. Then I'll say this dot push. So the push operator equals push. After that I'll say the pop element will be called. So this is like adding and removing a particular element. So that is the operation with push and pop. We will give proper indentations. So once we have provided with these characteristics, then we'll start with the next functionality after push and pop is the peek. So I'll say peek equals peek. Then comes the clear functionality. So this dot clear equals clear. And after that comes the length functionality to check the length of the stack. So I'll say this dot length equals length. So this was about the stack structure. After this comes the push element. So push functionality will be included in this format. Function push element, and inside this I'll specify the functionality, that is this dot data store. So data store will add the element, so it will add the element on the top because everything inside the stack is added on the topmost format. So this would be this dot top plus plus, and the element will be added over here. So this is for adding a particular element. So I'll mention a comment over here, that is adding an element in stack. So I have just mentioned my comments over here. After adding the element that is in the push, we have the next functionality, which is the peek, that is to access the topmost element. So for that we'll just mention the peek functionality as function peek, and inside peek I'll return the value as return this dot data store, and it will return the topmost value. So that will be this dot top with the decremented value of 1. After peek comes the next functionality, that is pop. So for that I'll say function pop, and inside pop I will specify return this dot data store, and it will remove the element. So it will decrement the topmost value of the element. So this was for removing an element. So this is like removing an element from stack. So we are done with the pop functionality. After that comes the clear functionality. So for that I'll say function clear, and this will clear my data structure. So clearing of the data structure will set my topmost value as 0. So I'll say this dot top equals 0. So after the clear functionality, the next functionality is length. So I'll say function length, and inside this I'll return the data store value. So for that it will, for stack it will return the topmost value. So it will say return this dot top. Here I'll mention the comment, that is returning length of the stack. After this comes the next variable, that is var s. So I'll declare my stack. So it will var s equals new stack. The way we did for list, the similar functionality we'll do for now. So I'll declare my stack. So my stack declaration is done. After that I'll do the push functionality. Like it is an empty stack for now, so I will add up some elements. So say for example I'm adding 3 elements in my stack. So I will add up s dot push David. So this is my first element. After that I'll add one more element. Say my next element is Raymond, and after that I'll do the next element, that is Parker. So this is my last element which I'm adding. So in short, my stack will have 3 elements inside the. So now I need to print my length of stack. So printing length of the stack is done at console.log, and inside this I'll specify length. So length parameter will be concatenated as s dot length. So it will call for length function. So my length parameter will return the topmost value of the stack, that is the length of the stack. The next console I want to say is I want to print the peak value. So I will just say s dot peak. So this will return me the peak value of the stack. We have already designed the functional logic for every related functions. After that, the next thing comes into a picture is the pop. So I'll just do var popped, because automatically the last element will be popped. So I'll just say s dot pop. So I'll also print this popped value as console.log. The popped element is, and I'll just print my pop element as popped. So I've done with this console. Now after this I will again try to print for the speed functionality. So I'll just say console.log s.peak, and I'll just print these values. So if you check it out, this would be my output 1, and on the other hand this would be my output 2. Checking out for the peak. After that I have output 3, that is to check the popped element, and after that I'm again printing the peak value, so it is output 4. So in total I have 4 outputs. Now I will do one thing, I'll add an element. So adding element is done with the push functionality. So adding the element is done as s.push, and inside push I will give the parameter as Cynthia, and after that I'll add the element as s.clear, and after that I'll print my console as console.log. Length is specified over here as s.length. So I'll print the length value over here. After that I'll again push one more parameter. I'm clearing the stack and then I'm printing this. So after that I will add one more value. So in this scenario, so this is like my output 5. So this is output 5, the way it is mentioned over here. The same thing, I'll mark each and every output. So I have added Cynthia, then I cleared my stack. Now I'll add one more thing, is like the final value, that is Clayton. And this means that only one element is there in the stack, which means the topmost element is the last element of the stack. So now again I will do a peak console. So I'll just say console.log s.push s.peak. I'll call for this function and I'll just print it. Now we have designed all the logic. So in short, we have 5 outputs to check. The last output is also there, that is output 6. So we have 6 output should be visible on our console. First thing, we added up with 3 elements and then we have printed. So my expected value over here should be 3. The peak value should be the topmost access value. So that should be Parker, because we are adding David, then Raymond, then Parker. And after that I will remove an element. So my element Parker should be removed. So that should be expected over here. Then the peak element should be present, that is Raymond. Then I again add an element, that is Cynthia, and then I clear my stack. So here I should get the length as 0. Then I add one element, that is Clayton, which means all these elements are now removed and I have only one element over here, that is Clayton. So that should be presented in my expected output of 6. So let's go to our browser. So this is my browser. So this was with respect to list, but now I'll call for stack, because we created a separate folder for stack. So this is stack demo.html. You get the output over here, like first example with stack, or that is with JavaScript, and the 3 outputs are visible over here. So first I'm getting length as 3, because this was the expected output. If you check in my browser, so I'm getting length as 3, which is perfect. That is my s.length parameter is 3. Then I have Parker, which means the topmost element is access. I added David, then Raymond, then Parker. So peak is showing me the topmost element. So s.peak is representing Parker, which is proper. Then I remove that element. So removing element will remove the topmost element Parker. So that is removed. So the popped element is pop. So popped variable is nothing but Parker value stored in it. Then I print console.log as s.peak. So s.peak will have a value. So my peak value now moves to the next most element after the topmost element, that is Raymond. And after that I clear my stack. I add a new value. So again here also you can check for the peak value. So this is also a possible thing. After adding up Cynthia, my peak value should come as Cynthia. So let's go for line number 45. I'll just change the output numbers for now, just to verify whether my output is working or not properly. So again, I'm checking the peak value over here. So I added up Cynthia. So now my peak value changes to Cynthia. Then I cleared my stack. So the length is assigned as 0. Then I added up with only one element. So my topmost element is Clayton. If you want to check for the length value after adding up this element, so I just say console.log. I just add up the new length parameter, that is length, and here I calculate the length. So my length expected over here should be 1 because there is only one element. So this would be my output 7 not, it's 8 because 7 is the peak value. So I'm getting the peak value as Clayton. Now the length value should be 1. So let's go to our browser. So here I get length as 1. So in this way, my stack functionality is properly working from end to end. Next chapter, we will focus on a basic implementation of stack, that is the palindrome example. So that is like a similar kind of functionality which is always followed in a stack. So let's move on to our next example. We had a look about implementation of stack, a basic example in our last chapter. This is to understand now about the palindrome example. So now in this chapter or in this course, we will be focusing about palindrome, which is nothing but a word or a text which starts and ends in the same format. Say for example, this is my word madam. So if I want to check for this word, it starts with M-A-D-A-M, and it also, if you want to start from the end parameter, then it gets M-A-D-A-M. So madam is a palindrome. So palindrome is nothing but a text or a word which when started from the beginning and from the end gives the same word. So we are going to implement it with the help of our stack logic, because every time we focus on one thing in stack is like creating a word or a sentence in such a way that beginning and end would mark on the similar manner. So stack will access the topmost element. So by removing the topmost element and moving till the end point, we should get the same word as the word which is fetched as a palindrome word. Now let's create an HTML file. So I'm going to create this file inside stack folder as palindrome.html. As a computer science student, this is always there in your mind that you will create a palindrome with the help of a typical programming language. Say for example C, C++ or Java. We will now create a same way following the data structure with respect to stack, and we will implement this with our JavaScript functionality. So let's create a doc type. So my doc type will be doc type HTML. Here I'll create a tag that is HTML, and inside this I'll create a head tag, and head tag will have the meta tag that is meta char set as UTF-8. After this I'll create a title. So my title will be palindrome example. After this I'll create a body tag. So my body will be script type as text JavaScript. Inside this I'll create the source file with palindrome.js. So this is how I created my palindrome.html file. Now I'll create a new file which will be nothing but palindrome.js. This will be my new file. So I just copy paste this particular file name, palindrome.js. Now I'll create a function as the way we did in our last chapter, that is function stack, and inside this I'll specify all the parameters inside my function stack, that is initializing my stack. So it will take data store. So this dot data store equals a blank array, 2 square brackets, then this dot push equals push. After that comes top parameter, that is this dot top will be 0. For now it is an empty stack. Then I'll say this dot pop equals pop. Then I will do a peak character. So this would be this dot peak equal peak to get the access of the topmost element. After that is clearing up this array value. So this is this dot clear equals clear. Then I do length parameter. So that is this dot length equals length. So I've done with these functionalities. Now I will create a functionality for push. So that would be function push element, and after that I'll specify this dot data store with the parameter this dot top plus plus equals element. So this is like I'm adding up the topmost element inside my push functionality. After that, next comes the peak functionality. The way we did in our last chapter, we'll call for all the functionalities over here. Peak, and it will take return this dot data store with this dot top minus 1. And after that comes the pop functionality. So that is function pop. So pop will have return this dot data store. It will remove the topmost element, so it will be minus minus this dot top. And after this comes the next functionality, that is clear. So it is function clear. So clear element will clear the topmost element, so it will be this dot top equals 0. Then next comes is the length parameter. So I'll say function length, and it will pass on the length parameter as return this dot top. So it will return the topmost parameter as a length value. Once it's done with the length parameter, the next is I'm going to create the main function. So this is like main logic for palindrome. So I'm going to create my main logic for palindrome over here. So that is like function. My function name is palindrome. Takes a word parameter, and inside word I'll specify where s equals new stack. So I'm initializing my stack over here, and now I'll create a logic for function with the help of for loop. So here I'll say for where I equals 0, I less than word dot length, and I plus plus. Inside this I'll push my word. So I'll say s dot push word of I, and after that I'll specify the reverse word, that is word r word. So that is my reverse word, should be same as that of this word. So reverse word will be the r word variable. I'll declare it as a blank string. So this would be my logic. Here I'll start with my length parameter, that is s dot length. I will check in my while loop. So while s dot length is greater than 0, you need to just pop this elements inside word. So I'll say r word concatenates with the pop parameter of my new stack element. So I'll push my stack variables over here. So I'll do pop here. So it's like it will remove variables, words, letters from the word, and then it will push in my reverse word. And after that I'll check the condition. If word equals our word, means the word and the reverse word, if they are equal, then return true, else return false. So once this part is done, then I will start with my implementation. So I'll take two words over here. Say for I'll take word, that is variable first word equals hello. Obviously this is not a palindrome because Start and end is completely different. HELLO and the reverse would be OLLEH, which is not the same word. So this would be my first variable. So here I'll call for the function if is palindrome and the word parameter is sent over here. If I get the value as true, then I will print console.log. Before that, I'll print my word and I'll concatenate it as is a palindrome. On the other hand, if I get as false, then I'll print console.log as word concatenated is not palindrome. So I'll just take this parameter over here that my word is a palindrome if I'm getting the reverse word and the word as equal. On the other hand, if I don't get this value and I get the value as false, then it is not a palindrome. After this comes the next word. So my var word, so that word 1 will be race car. So race car is a palindrome because start and end like RACECAR and the reverse is RACECAR is same. So it is a palindrome. So here I'll use the same logic. If my is palindrome and the word is same, then I'll say console.log word is a palindrome, and after that I'll check for the else loop. Like if I get a false value, then console.log the same thing will do it. Here I'll declare for word 1, so same I'll do for word 1 over here, concatenated with a string is not a palindrome. So we'll check for the proper indentations and the spaces. So now I have done with the logic for palindrome. Here I first of all do one thing is to push each and every letter inside word, and after that I pop all these letters in my reverse word and I pop it and concatenate it inside it. So in such a way it happens that my reverse word and word I get two various variables, like two different type of variables, and then I compare them and I get the value of true if they are equal and I get the value of false if they are not. Let's go to our browser and check what is the output we are getting. So this is my browser. Here if I reload the page, it is redirecting to stack. Now I'll go for palindrome. So here I'm getting the output over here that hello, it's not a palindrome, and race car is a palindrome. So two different words are calculated over here. If you want to apply for the same logic with the word, like example I did for madam. So here I'll declare a variable, say var word2 equals madam. Then in such a scenario, I will just use the same logic like if is palindrome, and here I will check for word 1. So here I'll do for word 2. So it should be madam is a palindrome. So just reload this thing and I'm getting hello is not a palindrome, whereas race car is a palindrome. And again it is coming as race car because I took as word 1. So instead of word 1, it should be word 2. So the proper word will be concatenated. So now let's go to our browser. Then I get three different words, like hello is obviously not a palindrome. On the other hand, we have race car as a palindrome and madam as a palindrome, because madam on the reverse end gives MADAM and race car also follows on the same scenario. So this was for the palindrome implementation, which also follows the stack logic, like the first on the topmost element at the last we get it, and then from the last to the top we keep on adding it. And in both the scenarios, like the push and the pop structure are working on the similar way, then we declare the particular word as a palindrome. Moving on to our next chapter will be complete focus about understanding what is the factorial, and we'll use the same logic of stack inside the factorial implementation, and there we will decide how a particular number can be calculated, like a factorial of a number. Say for 3 factorial is 3 into 2 into 1. So how to calculate that particular factorial with the help of stack and implementation of JavaScript. So that will be focus in our next chapter. Last chapter was a focus understanding about the palindrome and how palindrome is implemented in JavaScript. This chapter is a complete focus for understanding the factorial. So factorial said, I'll just close all these files and then I'll explain you what is factorial all about. So I'll create a new file and here I'll start with explaining the factorial. So factorial of a number is nothing but product of a number with its decreasing number, or something like you can say till the number reaches 1. If I say for 5 factorial, so this is the way factorial is represented, 5 and exclamatory mark. So factorial will be 5 into 4 into 3 into 2 into 1. It would be in this particular format. So that would be factorial as 120. I get the result as 120. So with stack implementation, we'll follow the same loop. If I'm saying for some number factorial, then I will give a product of all the numbers till it reaches the end of the element. So if I have say 5 numbers in it and these numbers are mentioned as 5, 4, 3, 2, 1, then my 5 factorial would be presented as 5 into 4 into 3 into 2 into 1. So with the help of stack logic and JavaScript, this chapter we will focus on creating a factorial of a number. So let's start doing this. First of all, I'll save a file inside stack and this would be my HTML file, that is factorial.html. So here I'll first start with creating a doc type. So that would be my doc type and then comes the HTML. Then after that we'll give HTML tag and then we'll give a head tag. Head tag will have meta tag, that is meta char set UTF-8 and after that I'll give the title tag as factorial of a number. Then I will create a body tag. So my body tag now will have an h2 tag showing factorial implementation with stack and JavaScript. We'll follow this particular pattern and then I'll call for the script tag, that is script type text JavaScript, and again it will call for source tag, that is factorial.js. So this completes my factorial.html file and now I'll create a new file and I'll save this file as factorial.js. So inside this I'll create a function. First I'll start with the stack function, that is function stack. I'll initialize all the values over here as a constructor. So here I'll say this dot data store equals to blank array. Then I'll start with the top element, that is this dot top equals 0. Then push element, that is this dot push equals push. And after that comes the pop element, that is this dot pop equals pop. So all these values are initialized over here. Now after declaring the pop comes the next value, that is peak. So I'll say this dot peak equals peak. And after that comes the clear value. So that is this dot clear equals clear. After that comes the length value. So length will be calculated as this dot length equals length. So I've done with my stack valuation. Now I'll create a functionality for push the way we did in our previous examples. So function push element. Now I'll say this dot data store will push the element, that is this dot top plus plus equals element. And after the push functionality logic, the next comes is the peak logic. So for peak I will say function peak equals element, and the peak value will return the topmost value, or we will access the topmost value. So this dot data store we'll say this dot top minus 1. So once we are given with the push and the peak values, now I'll give the next thing is for pop. So for pop, I will create a logic as function pop, and here I will define the logic as return this dot data store. It will remove the topmost element. So that is like this dot top. After that comes the clear functionality. For that I'll say function clear. So I'll clear my stack value. So I'll assign my topmost value, that is this dot top equals 0. So once I'm done with this part, the next logic comes is for length parameter. So for length I will say function length, and inside length I will specify return this dot top. So just check for these spellings also, this dot top. After that create a factorial number. So I will say function factorial. So I'll create a function name as fact. So it will take the parameter over here as the number, because we need to have a factorial of a particular number. So it will say function factorial with n as the parameter. So once I'm given with the parameter, then I'll create a new stack. So I'll say var s equals new stack. And now I'm done with the stack creation. Then I will create a while loop. So inside while, I'll specify n is greater than 1. If n is greater than 1 means 1 factorial will be 1, 2 factorial is 2, 1 into 2, 3 factorial is 3 into 2 into 1, that is 6. So we need to always check whether n is greater than 1. So this is a logic for checking whether the value of n is greater than 1 or not. Once it is greater than 1, I will push all the elements till it is decremented for the value of 1. So I'll decrement the operator using minus minus. So s dot push minus minus n. Then comes the next variable. After the while loop, I'll declare a variable. So that is the product, which equals 1. And inside this, I will specify the while loop as s dot length. It should be always greater than 0. So I should check my stack element should be always greater than 0. Then here I'll create my product concatenation operator as product concatenated to s dot pop. So I will remove each of these elements. Once I have pushed the elements, now I'll remove each of them and I'll create a product of that particular element. So my product will be as, suppose if I say for 3 factorial, then it will be product will be as 3 into 2 into 1. So this is how the logic for factorial works. So I will declare my product in this way. After that, for factorial, here I'll say return product, because it will definitely return some particular value to it. So this is the way like factorial logic is being designed. So here I pass with the n parameter and I check if the value of n is greater than 1. Once it is greater than 1, then I push my stack element with the decrement value till it reaches a point of 1. Then I create a variable of product as 1, and then I check if the value of s dot length should be always greater than 0, which means that there should be some element included in the stack. And after that, I concatenate my product operator with the pop functionality. Like I will take 3 first, then I'll product it with 2 and then with 1. And after that, I return this value of product. Now let's check for this functionality whether it is working properly or not. So I'll say console.log. I want to print factorial of say 5 factorial, and I also want to print factorial for 6. So here I'll say factorial of 5 is, and I'll just print my factorial over here as factorial of 5. And after that I want to print 3 factorial. So here I'll say console.log. Now I will print factorial as factorial of 3 is, and then I'll call for the function fact. We pass the parameter as 3 and console.log. The next parameter would be factorial of 10. a greater number which I want to check. Factorial of 10 is a large number. So it will be calculated as plus factorial 10. So I created the logic for factorial. Let's go to our browser and analyze whether I'm getting the output as I need it. So this is my browser. We check out for the palindrome example. Now moving on to the factorial example. So here I get factorial of 5 as 120. My h2 tag is represented here in the body section. So my factorial of 5 is 120, which is perfect. After that, factorial of 3 is 6. 3 into 2 into 1, that is 6. Perfect. And 10 factorial corresponds to 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So that is a very huge number. So that comprises to this value, that is 3628800. So this is how we implemented the logic for factorial using the same logic for stack, where last in first out structure is actually followed, where each and every number is taken in such a way, like we have taken number 5 for, say for example, factorial of 5. In that scenario, we took 5 and then we took 4. After that, we took 3 number and then 2 and 1, and we pushed all these elements in a stack. After that, we created a product of all these elements and then threw the output of factorial. So logic for factorial and stack go hand in hand, and that's how we implemented this complete thing with the help of JavaScript. Moving on to our next chapter, we will analyze first what is the base conversion, because we always go through a term called as a base conversion, converting a particular number from base 2 to base 8. Then we will convert a particular number, say from base 10 to base 8 and so on. Even that logic can be implemented perfectly with the help of stack. So let's go to our chapter where we will analyze our base conversion and how to implement that. Base conversion is something which is a unique topic for every developers, and you must have understood about these concepts in mathematics also. While going through a base conversion, like converting a particular number with a specific base, so that is whole concept, and this we are going to analyze first of all what is base conversion, understand its logic, and then in the next chapter we will create base conversion implementation with stack logic and JavaScript. So a stack can be used to convert a number from one base to another. Given a number n which we want to convert to base b, the algorithm for performing the conversion is as follows. Consider for the rightmost digit of n, so n divided by b, this is like a modulus sign. So whatever modulus you get the remainder, you push that digit onto the stack. Then you replace n with n divided by b. Suppose for example my n is 10 and n modulus and b is 2. So n modulus 2, that is 10 modulus 2 is 0. I push that 0 into that element and then I replace n with b. So my n divided by b is 10 divided by 2, that is 5. I repeat step number 1 and step number 2 until I get n equal to 0. And there are no significant digits remaining. So I get 10 divided by 2 as 5. Again I do 5 divided by 2, 5 modulus 2. I get a digit of 1 and I push that onto stack. So I get 0 then 1. Again I divide 5 divided by 2. That I get a answer as 2. Again I do 2 modulus 2 which gives 0. Again I do 2 divided by 2 and this gives me 1. And 1 divided by 2 gives me 0.5 and 0.5 divided by 2 gives 0.025 and so on. So we repeat this step till I get n equal to 0. And whatever the element I get, say for example 1, 0, 1, 0 and so on, I build the converted number string by popping the stack until the stack is empty. So popping up the stack will give you the particular base conversion. And that is how the exact working with the base conversion actually takes place. Let's have a pictorial representation of the same. So this is a conversion to base 2. Here I write 1 for odd numbers and 0 for even numbers. So I do the complete numbers, say for 13. So I take 13 divided by 2. So 13 modulus 2, I take it. And then I get a remainder as 1. I keep it in my stack. Then after that I do 13 divided by 2 which gives me the answer as 6. So I do 6 divided 6 modulus 2, which gives me 0. 6.5 and then 6 and so on. So my binary digit conversion for 13 to binary number, that is to base 2, will be a result of 1101. The similar case application applies for conversion to base 8. Consider for this number. So base 8 actual conversion is like that number divided by the position of the number, like 8 raised to that particular position and so on. Say for example 3 into 8 raised to 0 is 3. So this is my decimal number which I get it. It is like I am converting a particular base number to a base, say for example base 10. So I am converting base 8 to base 10. So this base conversion procedure keeps on going because we have to maintain a typical structure when it comes to base 8 to base 10. Now moving on to our algorithm. Here we have also seen that there are several problems for which a stack is a perfect data structure and a needed solution is there for this kind of base conversion algorithm. So stack implements this particular algorithm in a per section wise, and this section algorithm is further implemented in JavaScript, and so on you get the base conversion. Say for example I want to convert a number, say 32 to base 2. Then 32 for base 2 will give me number 1 and 5 times 0. That is 1 0 0 0 0 0. So that is a base conversion, that is a binary digit formation. If I want to convert 125 to base 8, I get the number corresponding to that. So that is very easy with respect to stack because it maintains all these elements. Like we repeat step number 1 and step number 2 in such a way, like it pops all these elements inside the stack and automatically we get the representation of the number until the stack is empty. So let's move on to our next chapter where we will analyze how the base conversion is implemented with respect to stack and JavaScript functionality. We understood about the base conversion. So let's start implementing base conversion. For that, I'll first of all create an HTML file and the name of the file will be baseconversion.html. Here I'll create the file as doctype HTML. I'll start with the HTML tag and then I'll start with the head tag. Head tag will be enclosed with meta tag, meta cassette, UTF-8. After that we'll have the title tag. So the title tag will have the title as it is for base conversion. So I'll mention this as base conversion. So I've given with the head tag. Now it starts with my body tag. So my body tag will be body. Inside this I'll specify the h2 tag as base conversion using stack and JavaScript. Once I'm done with this, I'll create a script tag. So this is my script tag. So script tag will have first parameter, as we did in the previous chapters, we'll have the type parameter. So here I'll say type as text JavaScript, and then I'll specify the next parameter as base.js, or I can say it as base conversion.js, and I'll complete my script tag over here. Now the next step is to create this particular file. So let's create this file. I'll just copy this file name and create inside my folder. So my new file will be baseconversion.js. The first step is to initialize my stack. So I will initialize my stack as function stack. Inside this I'll specify this dot data store, and data store will be given a value as empty array. Then comes this dot top equals 0. Afterwards I'll give push parameter. So this dot push equals push, and then comes the peak parameter. So this dot peak equals peak. So push parameter is given, peak is given. After that I'll specify the pop parameter. So my pop parameter will be this dot pop equals pop. So I've done with all these logic. Then I'll create a clear function. So it will be this dot clear equals clear. And the length parameter will be assigned over here as this dot length equals length. So specified with these parameters. Now I'll create a push logic for push element. The logic for push element will be given as function push and the parameter will be element, and inside that I'll specify this dot data store and the element will be this dot top. The first element will be aligned with the element which we have searched. So I'll align that element. After that I'll create another function that is called as peak. So it is function peak and I'll create a value for that. It will return a value of the topmost element. So peak functionality is to access the topmost element. So it will return this dot data store this dot top -1. After that I'll create a pop functionality. So my pop functionality will be function pop and inside pop I will specify return this dot data store. I am going to remove my first element over here inside the pop functionality. So pop functionality is for removal of the stacked elements. So I will use it with the decrement operator this dot top. So once I'm specified with these parameters, so I've created a logic for push, for peak and for pop. I will assign the comments over here. So this is for adding an element in stack. Peak is nothing but used for accessing the topmost element. So it is used for accessing the topmost element in stack. And pop is for removing topmost element in stack. So I'm done with these declarations. After that comes the function for clear and length parameter. So clear and length parameter will be given as function clear and inside that I'll specify this dot top equals 0 and afterwards I'll say the length parameter will be given as function length as return this dot top. So clear will clear all the elements. So it will assign the topmost. I'll mention in the comment. Assign the topmost element as 0, which means I'm resetting my stack, and the length parameter will return the length of stack. So the basic functionality is designed for stack. Now the main comes as the converting of a number. So converting numbers to base 2 and base 8 we are going to check over here. So I'll create my logic here. So let's start with the comment. Converting numbers to base 2 and base 8. And then I start with my function, that is function multiple base with B as capital. Then I give the number parameter and B. So here I start with declaring a new stack. So it will be var s equals new stack. So I've initialized my stack. Now after that I'll do a do loop. So I'll create a do loop. So inside do loop I'll create a logic that I will push. I'll follow the algorithm, the step number 1 to get the modulus. So I'll say s.push. The number should be divided with the base parameter, number modulus base, and the number should be fetched in some variable. for division. So number, I'll call for JavaScript functionality floor function to round out a particular number. Number divided by base. So this would be my first logic. And now after do I specify the condition? So that is why I'll specify the condition like while number is greater than 0. In do condition or do while loop, it is always seen that the while condition, the condition which is specified in while, is executed afterwards. So we're following the same structure over here. Now after this comes the next is to create the converted number. So my converted number will be specified over here as var converted equals a blank element, and here I will specify while s dot length is greater than 0, then I will convert it. So I'll use converted plus or equals s dot pop. So I'll create the converted value. I'll pop that particular element in the converted variable. Then I will return this converted value in my function. So whenever a function will be called, it will return this value. That is multiple base function, where it takes two parameters, the number and the base to which we want to convert it. Now I create a variable. So my variable will be num equals 32. And then I create a variable base equals 2. So I'm converting 32 to base 2. Now I do a new variable assignment, that is new num equals multiple base, that is num comma base. And here I create a console. I want to print whatever I'm getting as inside this particular functionality. So I write it down in my console as console.log num is like converted. So my number converted to base, and the base value will be concatenated over here. Again I concatenate my string and I specify it. So I give a proper string assignment, and then I get the value over here as new num. So I'm done with this logic. After that I give base 8. I give assign base equals 8. Then I again call for this number. So I say var new num equals multiple base, and the parameter is number comma base. So here the number will be converted as the base. So my number now I want to declare is 125. So my 125 number to base 8 will be converted over here. So again I print console.log, and then I say num as converted to base. Then I specify the base parameter over here, and then I convert it as is. So I give a space between is as new number. So I'm converting two things over here, 32 to base 2 and 125 to base 8. So let's go to our browser. So this is our browser. Here I'll reload it, and here you get the base conversion.html. And 2 output is visible over here, that 32 converted to base 2 is specifying with this value. On the other hand, 125 converted to base 8 is specifying this value, that is 175. Let's try to remove the extra spaces over here, so it should be proper as the way we need it. So I've done my output in this systematic manner. So I'm getting 32 as 100000 and 125 as 175 with base 2 and base 8 conversion. I have an online converter which helps you to check if the base conversions were proper or not. So my first number was 32 and I'm converting that, it's from base 8 to base 2. So here on the conversion, I'm getting the value properly as 100000. So my conversion was successful while implementing the stack logic in it and JavaScript. Now when it comes to 125, so I say 125 and convert it to base 8. As it is of base 10, I convert the logic and accordingly I get the value as 175. So my output is actually proper and accurate and it has been fetched as the way we need it. So these were some of the basic example of the implementation of stack with respect to base conversion. We saw an example for factorial, for palindrome, and the simple stack implementation. Next chapter will be a complete focus for understanding queues, which is also a kind of stack structure, but it follows different kind of logic. For stack we had last in first out, whereas in queue the logic is completely different. It follows a pattern of FIFO, that is first in first out element. So let's move on to our next chapter to analyze queues and various type of implementation in queues. For stack we had operation of push and pop. For queue we have two operations similar way, which is called as DQ and NQ. But everything happens from the first element. It is not like last in first out kind of a structure. So let's move on to our next chapter, which is like understanding queues, and later we'll analyze the implementation of queues in JavaScript. Hello, today we'll start with queues. Till now we had a look about what are arrays, what are stacks, and how they are implemented with JavaScript. Today the main concept is to understand about queues. Queue is a type of a list where data are inserted at the end and are removed from the front. So this kind of a data structure is such that data are inserted at the end and are removed from the front. So it is like you have to insert your values from the end, and whatever the values which are to be removed are removed from the front. Unlike stacks where whatever is inserted first and whatever is removed is from the first element only. Queues are used to store data in the order in which they occur, as opposed to stack, in which the last piece of a data entered is the first element for processing. Think of a queue like a line at your bank where the person into the line is the first person served. That is the common example for a queue, a layman example. And as more customers enter the line, they have to wait in the back until their turn is to be served. So that is the best example for a queue. And as I mentioned, it is like a structure where a data is inserted first. So it is in such a way it is called as the first in first out structure. A queue is an example of a first in first out data structure. So that is why it is called as a FIFO. For stack it was LIFO, last in first out. Queues are used to order processes submitted to an operating system or a print spooler, and a simulation application uses queue to model scenarios such as customers standing in the line at a bank or a grocery store and so on. So it is used to store data in the order similar to the stack but performs the operation in a different level. So I would like to repeat, like queue is an ordered collection of an items that follows FIFO, first in and first out, also known as first come first serve principle. The addition of new elements in the queue is at the tail and the removal is from the front. The newest element added to the queue must wait at the end of the queue. So popular example for the queue as I mentioned. So this is the structure of the queue which would give you a better understanding. So here you can see a data is inserted. So it is in last out and first in first out. Everything is kept in a systematic order. So whatever is inserted has to wait until all the elements previous to that element is removed. Okay, so we have lines for movies, for cafeterias, and the checkout line at grocery store among other examples. The first person in the line, consider this is the data as the first person. So first person in the line is the first one will be attended to. So it is first come first serve. And after that comes the next person and so on. So this person has to wait till all the data over here is cleared. A very popular example in computer science is printing line. Let's say we need to print 5 documents. We open each document and click on the print button. Each document will be sent to the print line. The first document that we have asked would be printed and will be printed so on until all the documents are printed properly. So printer takes everything in a queue and accordingly it prints the document, like first one, then second, then third and so on. Now comes understanding for creating a queue. So we are going to create our own class to represent a queue. Okay, so basic thing will be, it will be called as function queue, and it will have n number of items associated to it. Now there are basically two operations in queue. First comes is the enqueue. So we will focus about the basic operations in queue, and then in the next chapter we will analyze about the implementation of queue and the output in JavaScript. So there are two primary operations involving queues, like inserting an element into a queue and removing an element from the queue. Insertion operation is called as enqueue. So this is the pictorial representation of an enqueue. And the removal operation is called as a dequeue. The enqueue operation inserts a new element at the end of the queue, and the dequeue operation removes the element from the front of the queue. So if you want to follow for a particular algorithm or something, it follows stepwise representation, let it be for enqueue as well as for dequeue. So this is my queue, rear end means the last end, and this is the front end. So I just check if there is any empty space over here. So there is a typical algorithm followed for both the process, that is enqueue as well as dequeue. So as I mentioned, enqueue is used to add or store an item into the queue, whereas dequeue removes an access and for the particular item in the queue. So for enqueue, like there is a set of algorithm which is to be followed. So queue maintains two data pointers as it is visible over here, the front and the rear end. Therefore, these operations are comparatively difficult to implement than that of stack, because for stack, everything whatever operates, it's there in the front end. You don't have to move to the back end, because if you want to access this element in stack, you have to remove all these elements, then only you can access the last element in the stack. So the steps that should be taken for enqueue data is like, first of all, you should check if the queue is full or not. So that is your step number one. So here I can see there is some space, so one element can be added over here in this queue. Step number two, if the queue is full, if I see that the queue is full, I should produce an overflow error and exit from the programming language. On the other hand, if the queue is not full, increment the rear pointer. So this will be, my rear pointer will be incremented to this element, to the next empty space. Add the data element to the queue location. So my data element will be added over here, where the rear pointer is pointing, and you should return the value as success. So sometimes we also need to check if the queue is initialized or not to handle any unforeseen situations. So this was the typical step-by-step algorithm for enqueue operation. Check if the queue is full. If the queue is full, produce overflow error and exit. If the queue is not full, you should increment the rear pointer to the next element which would be added over here. Add the data element to the queue location where the rear is pointing and return success. So this was for enqueue operation. Let's move on for dequeue operation. This is the pictorial representation for dequeue operation. Accessing a data from the queue in the process of two tasks, like we have to access where the front is pointing and remove the data after success. So the number of steps that are taken to perform the dequeue operations are: step number 1, check if the queue is empty. Step number 2, if I found the queue is empty, then you should produce the underflow error and exit, because dequeue operation refers to removing an element from the queue. And if the queue is empty, which means that there is no element which is to be removed or added over there. So for that, I will get an overflow error and I will produce an exit loop over there. After that, if the queue is not empty, I get that the queue is not empty, then access the data where the front is pointing. You should access the data where the front is pointing, and afterwards you should increment the front pointer to the next element and you should return success, and whatever the element which is there on the top will be removed. Say for us, in this example, we have element A which will be removed from the operation. So as we have to repeat whatever steps are included in dequeue. Step number 1, check if the queue is empty. Step number 2, if the queue is empty, produce underflow error and exit. If the queue is not empty, access the data where the front is pointing. Increment the front pointer to the point and next available element, and you should return success. So these are the basic operations which are involved for enqueue as well as dequeue operations. There are certain functions which are available in queue, like some functionalities which is very important for queue. So few functions are required to make queue operation efficient. So first one is getting peak. Gets the element at the front of the queue without removing it. So it is called as the peak element. Then comes it checks that whether the queue is full or not. So as the name suggested, is full is a functionality to check if the queue is full or not. Is empty. Checks if the queue is empty. In queue, we always dequeue, that is access the data pointed by the front pointer. And while enqueuing in the queue, we always take the access with the help of the rear pointer. So these were the basic examples to understand with respect to that of queues. So as I repeat, like dequeue and enqueue are the basic operations in queue. Apart from that, we have some other important queue operations like viewing an element at the front of the queue and all. So that operation is called as a peak. The peak operation returns the element stored at the front of the queue without removing it from the queue. Besides examining the front element, we also need to know how many elements are stored in the queue, which we can satisfy with the len property. And there is also an operation which helps to clear all the elements in the queue. So with respect to JavaScript, there is a functionality called as a clear operation, which would remove all the elements in your queue and clear your queue completely so that you can add as many elements you want. So let's move on to our next chapter where we will focus about implementation of queues in JavaScript. Hello, now we'll start with implementing array-based queue class implementation. So implementing the queue class using array is straightforward. Using JavaScript arrays is considered to be a many advantages like in other programming languages, and it don't have JavaScript contains a function that can be easily added to the data, which can be done with the help of push as well as pop functionalities. The push function, which is there in array, places an argument at the first open position of an array, which always brings it back to the array when there are no elements added to the array. So let's start with implementing our queue class implementation. So here I have a folder which is created for queues. So I'll create a new file and the name of the file will be queue.js. Here I'll start with the basic functionality of a queue. So that can be said like we are going to begin implementing the queue class by defining the constructor function. So for that I'll say function queue, and it will include this dot data store, that is the data element associated to it. So it will be this dot data store equals blank array, and after that I'll take the blank array in this format. After this I'll take enqueue operation. So this dot enqueue equals enqueue, and after that I'll say dequeue operation. So this dot dequeue equals dequeue. After this comes the front and the back. So we have front end as well as the rear end in the queue. So we'll say this dot front equals front. After front comes the back, which is also called as the rear end. So I'll say this dot back equals back. And then comes toString functionality. So this dot toString equals toString. And once we are done with this, I'll start with the empty string. So that is this dot empty equals empty. So this was for function queue, where we have initialized or implemented the queue by defining the constructor function. Now the next step, the enqueue function adds an element to the end of the queue. So let's create the enqueue function first. So it will be function enqueue, and it will take a parameter of element, and then it will add this dot data store dot, it's going to add an element. So it is done with the push functionality, because here we are implementing queue in the format of an array. So enqueue function, so here I'll mention the comment, the enqueue function adds an element to the end of the queue. After this comes the dequeue function. So I'll mention here the dequeue function removes an element from the front of queue. So it will be function dequeue. It will remove an element, so it will just shift the parameter. So it will just say it as return this dot data store dot shift. It will shift the parameter, that is our rarend, to the next element, which will be the last element. Then after that we examine the front and the back elements of the queue using some functions. So these functions are nothing but front and back. So let's start creating that. So front function will be function front, and it will take a parameter of return this dot data store, and the parameter will be 0. So it will return the 0th element, which is the front end. So we are considering in the form of an array, so that is why the index number 0 will be returned if we call for the front function. Then comes the back function. So for back it will say front function back, or you can even say as the rarend, and it will return the last element. So that is done with the help of return this dot data store, and it will return the element with the length less than 1, length minus 1. So this was for implementing front and back ends of the queue. Now after this we need to add a toString function to display all the elements in the format of a string. So for that we'll create a function, and the name of the function will be toString, to show elements in format of string. For that I'll say function toString, and here it will call for a variable, that is return string equals a blank element. For it will call for a for loop for variable I equals 0, I less than this dot data store dot length I plus plus. So here it will return a value. So it will say return string equal, it will be concatenated with this dot data store of I plus a new line element will be added over there, and the function will return a parameter return string. So this was to show the elements in the format of a string. Now let's create a function. So finally we need a function that lets us know if the queue is empty. So for that I'll say for empty queue, I would create a function, say function empty, or we can even say the function will be is empty. So if I get if this dot data store dot length equals 0, then it will return true. On the other hand, else it will return false. Okay. Now we have implemented the functionalities for the queue. So we had empty queue, we had back end, front end queue, everything. Now let's create a test program. So my test program will be, it will be mentioned over here as test program. So here I'll create a variable, say var queue equals new queue. This is my variable which I have initialized. Then after that I'll create an enqueue. So I'll add new elements in the queue. with some name. So first name I'm going to add is say Cynthia. Then after that q.enqueue. The next element is Raymond. And after that I'm going to create an element that is q.enqueue. The next element is Parker, and so on. So now I'm going to print console.log q.toString parameter, and after this I'll print q.dequeue, which means I'm going to remove the first element. So again I'll print my console value over here so that I'll get the difference, like whether the first element is removed or not, as q follows a pattern of FIFO, that is first in first out. After this comes the front of the queue, so that is console.log front of the queue. So front of the queue will be q.front. So my front of the queue will be printed with the help of functionality front. The next functionality is console.log to get the rear end of the queue. So I'll say rear of the queue is actually back of the queue. So rear of the queue colon plus q.back. So this would automatically print me the values of what is the front of the queue and the back of the queue. So this would be my output 1, and the next one is output 2. After that comes is output 4. It's output 3 and then 4. In here it will be output 4. So this was a complete queue implementation in JavaScript. After creating the JavaScript function, so next thing I have to do is to create a new file, that is queue.html, which would call for this JS file so that we can check the output in the console. So I'll start with a doc type. So this is my doc type, and after that I'll create an HTML file. So HTML tag, then comes the head tag, and after that comes the meta tag, that is meta char set as UTF-8, and after that comes the title tag. So the title tag will be queue implementation in JavaScript. So I have mentioned with the title tag. Now after the head tag, the next comes is the body tag. So my body will have h2 tag as queue example in JavaScript, and then I'll source my element, that is the queue.js over here. So it will be first inside the script tag. So I'll mention the type first as text/JavaScript, and after that I'll mention the source element. So my source element will be queue.js. So I have done with these functionalities. Now we will go in our browser and have a look like how the output we are getting for queue. So checking out for the output, so this is inside queues, and I'll call for queue.html, and this is the output I'm getting in my console. So first element is Cynthia, then comes Raymond, then comes Parker. So once I do with the dequeue operation, with enqueue I have added these elements. With dequeue operation, the element Cynthia is removed and I get two elements, that is Raymond and Parker. So front of the queue is Raymond and rear of the queue is Parker. So if you remove this element again, so let's go into our code base. Here, if I remove an element again, if I say again dequeue, and then again I print the values. So again I say, let's print these values. So again I'd like to add over here with dequeue what happens. So this would be my output 5, and then comes output 6. So here you can see the front of the queue and the rear of the queue will be same if you again remove an element over here, because the element left over here will be only Parker, because Raymond is removed. We call for the dequeue operation. So now the output comes in such a way like front of the queue and rear of the queue is Parker. So this was the basic implementation of queue in JavaScript. Hello, now we'll start with implementing our array-based queue class implementation. So implementing the queue class using array is straightforward. Using JavaScript, arrays is a considered to be a many advantages like in other programming languages, and it don't have JavaScript contains a function that can be easily added to the data, which can be done with the help of push as well as pop functionalities. The push function, which is there in array, places an argument at the first open position of an array, which always brings it back to the array when there are no elements added to the array. So let's start with implementing our queue class implementation. So here I have a folder which is created for queues. So I'll create a new file and the name of the file will be queue.js. Here I'll start with the basic functionality of a queue. So that can be said like we are going to begin implementing the queue class by defining the constructor function. So for that I'll say function queue, and it will include this dot data store, that is the data element associated to it. So it will be this dot data store equals blank array, and after that I'll take the blank array in this format. After this I'll take enqueue operation. So this dot enqueue equals enqueue, and after that I'll say dequeue operation. So this dot dequeue equals dequeue. After this comes the front and the back. So we have front end as well as the rear end in the queue. So we'll say this dot front equals front. After front comes the back, which is also called as the rear end. So I'll say this dot back equals back. And then comes toString functionality. So this dot toString equals toString. And once we are done with this, I'll start with the empty string. So that is this dot empty equals empty. So this was for function queue, where we have initialized or implemented the queue by defining the constructor function. Now the next step, the enqueue function adds an element to the end of the queue. So let's create the enqueue function first. So it will be function enqueue, and it will take a parameter of element, and then it will add this dot data store dot, it's going to add an element. So it is done with the push functionality, because here we are implementing queue in the format of an array. So enqueue function, so here I'll mention the comment, the enqueue function adds an element to the end of the queue. After this comes the dequeue function. So I'll mention here the dequeue function removes an element from the front of queue. So it will be function dequeue, it will remove an element, so it will just shift the parameter. So it will just say it as return this dot data store dot shift. It will shift the parameter, that is our rear end, to the next element, which will be the last element. Then after that we examine the front and the back elements of the queue using some functions. So these functions are nothing but front and back. So let's start creating that. So front function will be function front, and it will take a parameter of return this dot data store, and the parameter will be 0. So it will return the 0th element, which is the front end. So we are considering in the form of an array, so that is why the index number 0 will be returned if we call for the front function. Then comes the back function. So for back it will say front function back, or you can even say as the rear end, and it will return the last element. So that is done with the help of return this dot data store and it will return the element with the length less than 1, length minus 1. So this was for implementing front and back ends of the queue. Now after this, we need to add a toString function to display all the elements in the format of a string. So my function for dancer, because we are going to implement our dance function, so each dancer is stored in the dancer object as function dancer, and the value will be this dot name equals name and this dot sex equals sex. It's like the gender parameter we are passing through the function. Then the next function is to get the values of the dancer. So for that, I'll take two parameters, that would be male and female. So here I'll say function get dancers, function get dancers. The parameters are males and females, and these parameters will take a value. So first thing, it will take a variable, say names, and it will be an array. So my array will have these values. Say first is Cynthia, after that I'll have Raymond, and after that I'll have a value, say Parker. Then the next value is Lena. Then after that comes the value as Jennifer. So these are the n number of values which I would like to add over here. After Jennifer comes the value is Brian, and after that comes the value as David. So all are in the string characters. Then after David comes Lucy, and after that comes the value Aurora. So this is like some values is a template values which I am sending, or I can say the demo values I am giving for an array. So my names is included. Now I am going to add a value inside names.i. So I'll just say for where I equals 0, I less than names.length I plus plus. Now it will trim for any extra spaces. Suppose I have the first name and last name, so it will take only the first name part. So I'm just trimming this value over here as names.i, names of I equals names of I dot trim. It will call for trim function. Okay, so we are done with this logic. Now after this, I'm going to split whatever the values I have inside a variable, and my variable name will be dancer. So I'll take another for loop for variable I equals 0, I less than names dot length I plus plus. And after this, I'll specify where dancer equals names of I, whatever names of I am getting will be my dancer. My gender, so gender will be the 0th parameter. So before that, I would like to specify the gender for each one of them. For Cynthia, it is female. For Raymond, it is male. For Parker, it is male. And for Lena, it is female. For Jennifer, it is female. And Brian, it's male. This is like a sample values which I would like to include in my names. David is male and Lucy is again female. So like the female value is 1, 2, 3, 4. 1, 2, 3, 4. We'll add one more value over here. This will be male. And the next value I would like to include is Clayton, which is female. So I'll say it as female. And the value is Clayton. So here names of I would like to take it in a split character. So I will split the value over here. Dot split the blank spaces in it. And after that I will specify where sex equals dancer of 0, whatever the value we are getting in the 0 thing, and name equals whatever the value we are getting in the next parameter, that is dancer of 1. Now I'm going to split the male and female value. So I just check the female is 1, 2, 3, 4, 5. Now here 1, 2, 3, 4, 5. So we have a proper 5 and 5 pair. So now what we are going to do, we are going to enqueue two parameters over here. So my enqueue parameter will be, I'll just take the name as name1 and here as name1. So this is my for loop. I've started with the for loop initialization. So I'll just take the enqueue parameter as if sex equals female, then I will enqueue female dancers. So I'll take female dancers as a queue dot enqueue the values whichever are there as new dancer, name and sex. These two parameters will be taken over there. Or on the other hand, if I get a value as something else, like I get male, then I will enqueue my male dancers with this name as new dancer with parameter name and sex, that is nothing but our gender. Now I'll create another function. So for that we'll move on to our next chapter. We will focus on two functions. First we'll create a function for dance, like how to arrange the dancing according, and then we'll create a test program where we will check like this name is associated to this name of a particular dancer. So now we created a function for get dancers. Let's create a function for dance. So continuing with the program what we had in our last chapter. So we'll have function dance and the parameters will be again males and females. Now what I'll do, I'll create a console. So we are going to create a console over here saying that the dance partners are with the new line parameter. So new line parameter will be concatenated later outside the loop. So here we are going to announce the various dance partners as per the values which we had. So first thing is like I'll have a while loop, while not equal to females.empty, I'll check whether females and males are there, and not equal to males.empty, and after this I'll specify the person value as, so that will be specified over here after the while loop, and here I'll specify person value as console.log female dancer is with a space person dot name. Prior to that I'll declare the variable person over here as person will be nothing but female members. So we'll have female members over here as females. So I'll first of all say person equal to, we can specify this parameter over here as person equal to females dot dq. So the first person in the female will be this one, and she will be paired with another parameter, say person males dot q. So the first member from males and first member from female will be paired together. So here it will be console.log male dancer is with the colon and parameter as person dot name. So these parameters will be taken over here. Then again I'll print console after my log. So it will be console.log a blank value. So we have declared for functions in test. So here in dance function, we are going to announce the male and the female parameters over here. So which one is the male and which one is the female. So the function pairs up the male and female dancers and announces in the console. The names are read from the array. The function then trims the new line character for each line. And in the second loop, it just splits the character of which would be the name and which would be the sex parameter, or I can say the gender parameter. Now what to do after this? After this, we are going to create a test program. So my test program will be test program where male dancers equals new queue. So I'll declare those queue over here, and where female dancers equal to new queue. So I have male dancers and female dancers. Now I'll call for function get dancers, and there I'll call male dancers and female dancers parameter. As it takes two parameters, male and female, I will pass these both queues over there. Then after that, I'll call for functionality dance, the function which we created right now for announcing the male and female dancers. So it is male dancers and female dancers. And now I'll print a if condition, like if not equal to female dancers dot empty. Like if my female dancers is like my queue is not empty, in such a scenario I will print a value like console.log female dancers dot, I'm going to continue it with the name, so it will be front value dot name plus is waiting to dance, and then I'll concatenate the value with male dancer in another condition, like if not equal to male dancers dot empty. In such a scenario, it will just say console.log male dancer outside the loop. It should be within the console.log statement. Male dancers dot front dot name with the value as a new string parameter. So male dancers dot front dot name with the name is waiting to. We'll take the same statement over here, so that would be better to understand. So here I'll say after the function declaration, I will say if male dancers dot front dot name is waiting to dance. Now what to do? After announcing all the logs and everything, we'll go to our browser and have a look like how the output we are get. For that, it is also important to create an HTML file. So inside queues, I'll create a new file as queue square.html, and here I'll declare the doc type HTML. Inside this, I'll specify the HTML tag with head and meta tag, that is meta char set UTF-8, and inside this I'll specify the title, and the title of the name would be Q square implementation. So we are going to implement the Q square with the help of the dancing arrangement. So I'll say Q square implementation. After this, I'll have the body tag, so it is body, and inside this I will specify the h2 tag as assigning partners at square dance. Okay, and after this I will specify the value as script src q square dot js, and after that I'll specify the type as slash JavaScript. Now let's go to the browser where we'll have the look of how the Q square implementation, like assigning partners at the square dance, takes place. So this is my browser in which I have queues. We already called for q.html. Let's go to q square.implementation, and here you can have a look like the dance partners are female dancer Cynthia and male dancer Raymond, Lena and Parker, Jennifer and Brian. Whatever we had a pair with male female, all of them are presented over there. If anyone was pending, they would have called with the console that this person is waiting for this person to occupy. So this kind of implementation was clear, where we had a scenario in which we simulate the queue in the square dance for singles, where men and women arrive at a square dance. So this was the desired output which we have achieved with the help of queue implementation for assigning partners at a square dance. Starting with the next section, which is called as the priority queues. In this course of normal queue operations, when an element is removed from a queue, the element is always the first element that we can say is inserted into a queue. There are certain applications of queue, however, that require the elements be removed in an order other than a typical structure called as first in, first out. When we need to simulate such an application where we want to remove a particular element or add an element based on the priority, then it is said to be called as a priority queue. Priority queue, it is one where elements are removed from the queue based on the priority constraint. For example, you can say a waiting room at a hospital's emergency department, which is called as a ED. It operates using a priority queue. When a patient enters ED, he or she is seen by the so-called main nurse. This nurse's job is to assess the severity of the patient's condition and assign the patient a priority code. Patients with high priority code are seen before patients with a lower priority code, and the patients that have same priority code are seen on first come first serve basis or first in first out basis. So this is the basic functionality for understanding the logic for a priority queue. You can set the priority and add the element at a current position or the proper correct position. You can queue the elements as added to the queue. So basically priority queues are nothing but where elements are added based on the priority constraint. As queues are largely applied in computer science and also in our lives, there are some modified versions of a default queue that we have implemented with the help of queue class constructor in our previous chapter. One modified version in priority queue, elements are added and removed based on the priority. An example of the real life best can be say is a boarding line at an airport. The first class and business passengers get higher priority over the coach class passengers. This is the second example which I can say. In some countries, elderly people and pregnant women or senior citizens, we can say, are given higher priority. Patients that are in severe condition are given higher priority in emergency ward. So they get a priority based on the condition. So there are two ways for implementing a priority queue. What you should do exactly is you can set the priority and add the element at a current position, or you can queue the elements as they are needed to the queue and remove according to the priority. For this example, we'll go to our code base and we'll start scripting with our JavaScript file, and there we will add a priority queue with basis of our patients. So let's start doing that. This is our code base. Here I'm going to create a file. First of all, we'll analyze our creation of the file with the help of a priority queue. So I'll create a file name as priority queue.js. So I've created a file. Now after this, as we did in our last chapters, we will focus on adding a queue constructor. So let's create a queue constructor as function queue, and later we'll add a value, this dot data store equals blank array, and after that I'll say this dot enq equals enq, and after that I'll say this dot dq equals dq. So I specified with these parameters. Now I'll say this dot front equals front, and comes the parameter this dot back equals back. After that we have toString parameter, so I'll say this dot toString equals toString, and after this we have parameter empty to specify the empty value as this dot empty equals empty. So you specified with enq element. Now I'll add the enq element the way we did in our previous chapters. Function enq, the value is element, and we'll push this element in the data store as this dot data store dot push element. Okay. Now we need to create a DQ function. So DQ function is priority is slightly different for priority queue. Let's create that. So DQ function will be in such a way that removes an element in the queue with the highest priority. We will define the highest priority element as being the element with the lowest priority code. So which element will have the highest priority will have the lowest priority code. So this new DQ function which we are going to create now will move through queue's underlying array and find an element with the lowest code. Then the function will use a splice function, the inbuilt function in JavaScript, to remove the highest priority element. So here is the definition for DQ. Let's start with it. Function DQ, and here I'll start with specifying the priority equals the parameter this dot data store of 0 and code, because every queue element will be assigned to a particular code. I'll start with a for loop for variable I equals 1, I less than this dot data store dot length, and then I'll specify plus I. After this I'll specify if this dot data store of I dot code is less than priority, then it will set priority equals 1, or we can say the priority can be set as I parameter. Now after for loop I'll return this value with the splice character as return this dot data store dot splice priority with the first character. So this was for the DQ implementation, which removes an element based on the priority basis. After this comes the next element, that is the front element. So we'll create the front parameter as function front, and inside this we'll specify return this dot data store of 0. After this we'll specify the back parameter as function back this dot, it will return a value, so it will return this dot data store as this dot data store dot length minus 1. Now we need to create a toString parameter. For that I'll use the same implementation in our previous example. So here I'll call for toString and empty parameters. So I'll just take these two elements over here and use it over here in my priority queue. toString to return elements in the format of a string, and empty parameter to return the value or to whether the queue is empty or not. Now the focus is to create a patience character, or we can say the patient element is created over here in a function format as function patient name and code. Once we have specified this parameter, so I'll say this dot name equals name, and this dot code equals code. So my patient value will be initialized with the name and code in it. The way we did in our last chapter where we created the dancers with two parameters, namely name and gender. Now we'll initialize a patient parameter over here and we will create a priority. So let's move on to our next chapter where we'll analyze the priority queue implementation in detail. Now after creating patient like the way we did in our last chapter, we are going to create a variable and we are going to create a test program. So my variable var p equals new patient and the value would be Smith and the next parameter is 5. After that I'll create a new patient with ed parameter and this would be my priority queue. So I'll initialize my queue over here. And after this I would like to push whatever the parameters I'm creating for a new patient using enqueue operation. So I'll just say p dot enqueue, rather it would be ed dot enqueue and the value will be p. Now let's create n number of patients over here. So let's say p equals new patient and the value would be Jones and the next parameter after that would be 4. After this it would be ed.enqueue p, next parameter after Jones 4 code, the next value I would like to say is p equal to new patient and the value is Brown and the code for the patient is 1. Now we'll do one more thing. First of all, let's enqueue this particular queue. So I'll say queue ednqueue with the patient p. Now after this I'll create a patient name with the same code. Let's check how the priority queue works for the patient with the same code. So we'll say p equals new patient, the values will be in gram, and inside this and the value code would be 1. Okay. After this comes the next parameter ed.enqueue and I'll enqueue my parameter p. Now I've added all the queues. So after that I'll print a console, say console.log ed.toString. So this would print whatever the queue I have added over here in this toString format. Now I'll print a console, that is console.log patient being treated and the value over here would be scene 0 dot name. So we'll create a variable for that. So my variable scene would be nothing but whatever the value I'm going to dequeue. So I'll say var scene equal to ed dot dequeue. So after patient being treated, next would be the patient who would be waiting in the queue. So I just print a console over here that patients, or I can say the patients waiting in a queue, waiting in to be seen, and after that I'll print the value as console.log the same parameter ed.toString. Now I'll again say var scene equals ed.dequeue. Inside this I'll specify the parameter console.log patient being treated as plus scene 0 dot name. After that I'll print whatever the patients are waited to be seen as console.log patients waited to be seen as concatenated with the parameter in the next value as console.log ed.toString. So I've created the values associated over here. After this, let's create an HTML file inside queue. So my HTML file here would be priority queue dot HTML. Here I'll create a doc type first. So this would be doc type HTML HTML parameter, and inside this I'll specify the head parameter over here as head type meta character, meta char set UTF-8. After that I'll specify the title as title priority queue implementation, and after this comes the body tag as h2 priority queue example, and inside this I'll specify the script tag as script src. Value will be nothing but priority queue .js, and the type would be text/javascript. So we have analyzed with the code base, we have done with our scripting thing. Now let's go to our browser and have a realization like what exactly we are getting, whether the implementation of priority queue is successful or not. This is my browser system, and here I can see the priority queues are visible over here. And clicking on priority queue example, I can see the code base system is such like Smith with code 5, Jones with code 4, and French Benz with code 6, and Ingram with code 1. Patient being treated first taken is Jones. Patients waiting to be seen is Smith with code 5, and Ferenbanch with code 6, and Ingram with code 1. After patient treated for Jones, the next patient taken as per the priority is Ingram, and after that the patient being treated will be from Smith or Ferenbanch. So in this way priority queue is actually implemented. Starting with our next data structure, which is called as a dictionary. Dictionary is a data structure that stores data as a key value pair such a way that a phone book stores its data as names and phone numbers. When you look for a phone number, you search for the name and then you find the name. The phone number is found right next to the particular name. The key is the element which is used to search, and the value is the result of the search. If I want to say dictionary, you can say a simple Oxford English dictionary where a word and the meaning are given, where word is nothing but a key and the meaning would be the value for that particular key. Dictionary is a data structure follows this pattern, which includes a data as a key value pair. The JavaScript object class is designed to operate as a dictionary. So JavaScript object includes a class which is designed to operate this dictionary, and in this chapter we'll use the features of the object class to build a dictionary class that simplifies working with a dictionary type object. You can perform functions like we'll focus in this chapter using JavaScript arrays and objects, but creating a dictionary class makes doing the work easier and more fun. For example, it's a lot easier to use to reference keys rather than using the use notation. There is also, of course, the advantage of being able to define functions for performing collective operations, such as displaying all the entries in the dictionary rather than having to write loops in the main program to perform some operations. So focusing on the dictionary class, let's have a look in our code base where we will create a dictionary class and the associative functions to it. For each one of them, I would explain why it is needed for the dictionary representation in JavaScript. This is nothing but our code base, and inside dictionary, I'm going to create a file, say dictionary.js. Here I'm going to start with my major implementation, which is called as the dictionary implementation of JavaScript. So let's focusing on the first aspect as we do is to create a constructor for dictionary, that is function dictionary, D in caps, and here we'll have the values. Here we'll create the parameters associated to dictionary. So my first will be to add a particular value as this dot add equals add, and I'll call for add function. After that comes data store. So my data store would be this dot data store equals a new array, and after that comes the next parameter is to find the value. So this dot find equals find. After this comes the value to remove a particular value. So that would be this dot remove equals. So we are done with these values. Now we need to understand the basis of our dictionary class is the array class rather than the object class. Later we'll also analyze that we want to sort keys with the dictionary. That is also possible over here. So we started with the definition of the dictionary class over here with the function add to add a particular value. So let's start with the function add as function add key value, and inside this I'll specify the parameter as this dot data store key which equals a value, and after that I'll specify find parameter. So function find as key which takes a parameter return this dot data store, and it will return the key value of it. So add is nothing but the first function to define this add, where it takes two arguments, say key and value. The key is the index for the value element. So this is the basis, or this is the code association for the add functionality. The next function is find. This function takes key as the argument and returns the value associated to it. Removing a key value pair is also equally important. For that, the function is function remove key, and this will take a parameter, or it will call for delete functionality, that is delete this dot data store of key. So delete will delete all the associative parameters with respect to the given value. Now next comes the logic, which is like we'd like to able to view all the key value pairs in the dictionary. For that, the associative code would be show all. So I'll create a function here. So this would be this dot show all equals show all. So this would be function show all, and here I'll take a value like with for loop as for each. I'll take a for each loop because it is inside a variable. For each variable key in object dot keys, and the associative index would be this dot data store, and the logic will be initialized over here as console.log. You'll have to print a value of key, and this key will be nothing but our data store key. So I can just say this dot data store and key value associated to it. So this was for the show all functionality. After show all, now we are going to create a phone book, and it will be nothing but our phone book. So let's start creating a variable for phone book as where pbook, or I can say the phone book as pbook equals new dictionary, and the dictionary will be initialized over here. After that, I'll say pbook.add value would be say Mike, and it will take a parameter or the number, or I can say the extension number as 123. Then I'll add pbook.add the next value as David, and the parameter would be 345. After that comes the next value, that is pbook.add. The value over here is say Cynthia, and the value over here would be again 456. So once we are done with this, I'll print the console for David extension as console.log David's extension as pbook.find. The key associated to it is David, and after that this comes the Mike's extension. So it will be console.log Mike's extension as the value over here would be again pbook dot find, the next parameter would be Mike. So this would associatively give me the extensions for Mike as well as David. Now I'll remove again the David's extension. So I'll use the function say pbook dot remove, and I'll remove the key for David. So what it does, after this I'll again print a value of David's extension over here. So here it should not give me the value of David. After this I'll call for pbook.findDavid. So this should return me the value of false because I have removed the key with David extension. So this has been done. Now after this comes our HTML. Let's create our HTML file inside Dictionaries, and the name of the file will be dictionary.html. Here I'll create the doc type first as doc type HTML. And after that I'll create the HTML tag. After that I'll create an head tag. So my head tag will have meta char set as UTF-8. And after this I'll have the title tag. So my title tag would be dictionary example. Now after this comes my body tag. So my body would be script type as text/JavaScript, and after this my next would be to show the source code as dictionary.js. Here I'll also include an h2 tag as h2 dictionary implementation. Okay, I've done with this part. So I've created the HTML file. Now we need to check in our browser and analyze whether the output which we have designed for Mike, David and Cynthia, we are getting the proper output or not. So this is our browser. Now I'll access for dictionaries and call for dictionary.html. So I'm getting David, Mike and whatever the extension associated to them. So for David we gave the extension 345 and Mike 123. So I got the according extension. Then I removed the key for David, so that's why I'm getting the David's key as undefined. If you check for our code, so this is our code. Over here I had explained that once you remove David, I will get the value over here as undefined. On the other hand, now I would like to print the extension for Cynthia. So here I will take a value, say console.log, and the value over here will be represented as Cynthia's extension, and it will be called within the concatenation operator as pbook.find. The key will be Cynthia. So let's go to our code base, and again I would like to reload it. So here I get Cynthia's extension as 456. So this is how is the basic implementation or the dictionary implementation, dictionary data structure implementation in JavaScript. Our next data structure is called as a set. Set is a collection of unique elements. The elements of a set are called members. The two most important properties of a set are that the members of a set are unordered and that no member can occur in a set more than once. So that is a unique characteristic of a set. So as I mentioned, set is a collection of unique elements. The elements of a set are called as the members, and it is very useful to create a data structure which comprises of unique elements because the elements one formed cannot be repeated. Sets play a very important role in computer science but are not considered as a data type in many programming languages. Sets can be useful to create a data structure that consists of only unique elements, such as list of unique word in a text or something. In this chapter, we will discuss how to create a set class for JavaScript. Prior to that, it is important to understand some structural symbols for the sets. So this is how is set representation, or I can say the pictorial representation of the set is in this particular format. Set is an unordered collection of related members in which no member occurs more than once. If you see for set 1, I have 1, 3, 5, 2. Here the elements are not repeated. So it's like whatever elements I have, say 1, 3, 5, 2 are unique. Similarly for set 3, it is 8 and 9. Two elements are there but both the elements are unique. Set 2 can be said that with the elements 4, 0 and 6. And set 4 includes of the elements which are 10, 12 and 11 and 12. So these elements are created in such a way inside a set, or I can say the members of the set are unique in nature. We can write set in any order, like we can have it in reshuffle order or the shuffled order, or any combination of the members such that all the members are written only once. Sets play a very important role when it comes to discrete mathematics concept. So set definitions are there. Some set of definitions are very important. So some of them are here, presented over here. A set containing no members are called as the empty set. So if you have no members in it but the set exists, then it is said to be called as an empty set. The universe is the set of all possible numbers. After that, I can say two sets are considered to be equal if they contain exactly same members. I have two sets with me and they are said to be equal if they have same members, or I can say same elements present in it. In the similar format, a set is considered as a subset of another set if all the members of the set are contained in the second set. Subset is nothing but we can say it is a child class of a particular set. So you have a parent class and you have to declare for a child class, then you can say that set can be a subset if it has the elements which are in common with respect to the particular sets. Now in this chapter we understood about set, the structuring and everything. So we will create a data structure in set format, or we can say ECMA script 6 always allows implementation of a set class. So we will have a skeleton description of the set class with the basic examples and everything that we will have deep in our next chapter. A deep focus will be done in our next chapter, where each and every operation of the set will be performed. As I mentioned, the members in the set are declared only once. So we'll have the structural look like whether the members can be repeated or not. So based on that, we will have our implementation, and that will be focused in our next chapter. So our next chapter will be our first implementation of set in JavaScript. Now let's start creating our set implementation. So for that, we'll create a file over here as setdemo.js. This is our code base, and here the first step we will do is to initialize our constructor inside a set like we did in our last chapters. So we'll follow the same structure over here. So initializing a constructor is also a very important thing, because set class implementation is built around an array for storing the data. We also create the functions for each of the set operations, and that we will focus in this chapter. So here is the definition for the set class as function set, and the values associated to it would be this dot data store, and inside this I'll have a blank array. After that it would be this dot add equals add, and this dot remove equals remove. And after this I'll call for the size parameter to check the size of the array. So that would be this dot size as size. Now the next function is add function. Because a set can contain only unique members, before the add function can store data in the array, it must check to make sure that the data is existing in an array or not. We can do this with the help of index of function of our JavaScript. So I'll say function add data. I'll check for the if condition, that is if this dot data store dot index of data is less than 0, then I'll print this dot data store dot push data. After that I'll return the value as true. So I've done with this. Now the else part would be if the value is not, it's like it's already existing in my set, then I will return it as false. So this was for the add functionality. After add, the remove function works similarly to the add function, where we first check to see if the requested data is there in an array or not, or the requested data which you want to remove is there in the array or not. So I'll say function remove and data parameter in it, where it will remove the value as where position equals this dot data store dot index of the value as data. Inside this I'll specify one parameter, that is to check the position. So I'll say if position is greater than -1, then you should remove that element as this dot data store dot splice, and the splice element will remove whatever the elements which is to be removed. So I'll say position 1. Now after this comes the parameter to return, so I'll say it as return true. So I've set this position. Now I'll say else return as false. So this was for my remove function. Now before we create for any of the functions or create a test data, it is important that we should create a show function where we can see the members of the set. So I'll say function show, and over here I'll implement the logic as return this dot data store. Okay. Now let's start creating a set. So my set would be, it would be nothing but a values associated to it, like a names. So I would say where names equal new set. Okay. So I started with initializing of the set. Over here I'll say names dot add as first value is David. Then after that I'll add names dot add, the next value I would like to add is Jennifer. After that I will add the next value as Cynthia. Names dot add value is Cynthia, and after that comes names dot add value as Mike, and after Mike the next value would be Raymond. So overall we added 5 elements in our set, and each one of them is unique as it is clearly visible over here. We are not repeating any value inside this element. Now I'm going to add an element, but I want to add say Mike, but I'm unaware of the fact that Mike is already existing in my set. Then how to handle such kind of a situation? For that I will say if names dot add, the parameter is Mike, then I will print the value as console.log Mike added, and then I'll say else console.log can't add Mike, and I will also mention that it will be already there or must already be there in the set. I will declare this console in this particular format. After this, I would like to say that I will like to show whatever the elements I have in my set. So for that I'll call a function that is console.log names.show. So this will show whatever the values are there in the set. After that I would like to add one more element. So my element is names.add. The value is Clayton. So it would be added in my, so now my element, so the members in the set are 6. Now I need to remove an element, so my element name is Mike. So I'll declare it in my variable say var removed equal to Mike. So as I mentioned, remove functionality also checks whether the element is there in the set or not. So it will check the value as if names dot remove, it will call for remove function with the parameter removed which we declared over here, and here I will say console.log removed concatenated with the operator is removed. Okay, and after this I'll print the else condition as console.log. If I see the element is not existing in my system, then I'll say removed plus with a space in it is not removed. Okay. So now we added for a element also Clayton. Now we'll do one thing. I want to remove an element, say, but Alisha is not there in my set. Then I will say it as removed equals Alisha, and then I'll print a value as console.log names. I just like to say we'll follow the same pattern over here like the way we did. If names dot removed with the parameter of removed, if Alisha is existing in my system, then it will be removed over here. The same parameter like the way we did over here. So we'll just copy paste this complete sentence. Else console.log Alisha is not existing in my system, then it will not be removed. Or we can say it's not existing in my system. Alisha is not removed, or the element or member is not existing in my system. Okay. Now what we should do? We should create an HTML. So inside sets, I'll create an HTML file as setdemo.html. Over there, I'll create the doc type first. So this would be my doc type HTML. Inside this, I'll specify HTML tag with head, and the head will have the meta tag as char set utf8, and after that I'll specify for the title. So this would be my title, and this would be set demonstration in JavaScript. After this, we'll call for the body tag. So this would be body tag specified in it, and which will have script tag, script type text / JavaScript, and the source code associated to it would be setdemo.js. Okay. Now we'll call for the h2 tag, which says this is first example of set. So sets with respect to JavaScript, I can say. Now let's go to our browser and analyze what the output we are getting. As per the requirement we can get over here, like Mike is already there in the system. So I should get the output as can't add Mike already there in the system. Then we added Clayton, so automatically Clayton should be added. So we'll again print a console after adding up the element to verify whether the value has been added or not. Then after that we'll remove Mike. So Mike will be removed from the set and only 5 elements will be there. So I'll get the output that Mike is removed. Next I'll check for the other element, that is Alisha, which is not there in the set. But we'll get the output at this is not removed as the element is not existing in my system. Let's go to our browser and analyze whether the outputs we are achieving are proper or not. This is our browser. Over here I call for set demo. So here I see the output properly, like can't add Mike because it is already there in the set. Then afterwards I get the values associated to the set as David, Jennifer, Cynthia, Mike and Raymond. And then I remove the element of Mike, and afterwards I add an element that is Clayton. So that is why I get these 5 elements associated in the form of an array, which is clearly visible over here. The length of the set is 5 and each of these elements are unique. And Alisha is not removed because Alisha is not existing in my system. So this was the basic implementation of sets in JavaScript. Starting with a chapter called as the set operations. Set operations are nothing but the basic operations which are followed in the particular set. Say it for union, for intersection and difference. Focusing on our first operation, which is called as the union. Given 2 sets, this returns a new set with the elements from both the given set. So it is said that a new set is obtained by combining the members of one set with the members of another set. For intersection, I would like to say a new set is obtained by adding all the members of one set that also exist in the second set. Intersection means given 2 sets, this returns a new set with the elements that exist in both the sets. So union is like, suppose one set has an element say 1, 3, 5 and another has an element say 3, 5, 6. So my union of that set would be unique elements like 1, 3, 5 and 6. Now same example, I would like to say I have one element as 135 and another element as 356. Then intersection of those two sets will give me the value as 35. That is intersection with respect to that particular set. Then comes the difference. Given two sets, this returns a new set with the elements that exist with the first set and do not exist with the second set. Difference is nothing but a new set is obtained by adding all the members of one set except those that does not exist in the second set. It is opposite of intersection, where I see one is 135 and another is 356. So the difference would be 1 because I am removing whatever the value which are common with respect to both the sets. Okay, so we had an idea about it, and subset means it confirms whether the given set is subset of another set. Now let's focusing on the operations whatever we had. So let's go to our slide. So this is the basic example for understanding the set operations. This is set A and set B. The union of the set would be like I have 3, 5 element common for both the sets. So it would be 1, 2, 4, 3, 5, 9 and 7, 8. All the elements will be added over here, summed over here as a summation of all the elements, and it will be total inside this set. The more interesting functions is like union, intersect, subset and difference are major set operations which takes place nowadays. So this is the first example where set A and set B are taken in common, and 1, 2, 4, 3, 5, 9, 7, 8 will be my result for union. But when it comes for intersection, it would be 3, 5 because these are the common elements as it is visible over here for set A and set B. 3, 5 are the common elements, and that is why it is listed inside the intersection of these two sets. If I say for difference, it would be that set A and set B, the difference of set A with set B would be 1, 2, 4 and difference of set B with set A would be 9, 7, 8. Like with respect to the particular set which we are calculating our difference. So whenever we declare for union, we always declare a helper function with contains parameter, and later on we create a functionality for intersect with respect to JavaScript. So let's start focusing on these operations in our next chapter. Well, we'll create a JS file, and after that we'll create an HTML file to implement the set operations. Let's create an advanced operator functionality of set with advanced set.js. Here I'll create a function, that is function set, and it will call for this dot data store equals blank array, and then it will call for add functionality as this dot add equals add. After that it will call for remove functionalities, so it is this dot remove equals remove. After the remove functionality, the next is to calculate the size, so it will be this dot size equals size. And after the size functionality is contains, so I'll say this dot contains equals contains, because contains parameter is associated with respect to union and intersect functionality. So I'll start with the first thing is union, so I'll say this dot union equals union, and then comes the intersect functionality as this dot intersect equals intersect. Okay, and after this comes the difference as this dot difference equals difference, and comes the show functionality as this dot show equals show. So we declared all the functions inside our constructor. Now we'll start with the add functionality as function add data. Inside this I'll specify if this dot data store dot index of data is less than 0, then this dot data store dot push data, it will push the data accordingly. Okay, and after this comes the value, and it will return a value as return true. And after this comes the next parameter, that is else, which will return value as false. If the data is already existing in the system, then it will not add the values inside the set, so it will return the value as false. Now comes remove functionality as function remove data. Inside this I'll specify where position equals this dot data store dot index of data. Okay, and inside this I'll specify if position is greater than -1, then it will splice the element as this dot data store dot splice. So it will call for the inbuilt data script functionality, that is splice. So it will splice the position character with the one parameter. So it will return a value as return is true. Now the next thing is like I'll say else, and inside else I'll specify return as false. If the value is not existing in the system, then it will return the value as false. Now the next parameter is to show the elements inside the data structure are set, so that is done with show element. So show will show the values inside it as return this dot data store. After this comes the next parameter, that is to show the size of the element as function size as return this dot data store dot length. This will show the size or the elements which are present, the length of the set. Now comes the parameter or the functionality called as contains. Contains checks if the data is existing in the system or not. So it says function contains and it takes a parameter as data, and it says if this dot data store dot index of data is greater than -1, then return true. On the other hand, if I get a value that the element is not there in the system, then it will return false. Now we call for union functionality as function union of set with var temp set as a new set. And over there we'll call for a for loop, that is for I equals 0, I less than this dot data store dot length, and then I'll increment the value as I plus plus. Okay. Now I'll add my temporary set with the union set. So temp set dot add this dot data store of I. Okay. So I parameter will be added over here, the index of I. Now again I'll run a for loop saying that for variable I equals 0, and then I less than this dot data store dot length I plus plus, and now I'll say if set dot contains this dot data store of I, then it will return a value as temp set dot add this dot data store of I. Okay. Then it will return a value. This complete value will return me the temporary set in this format as temp set. So this was for function union set. Then comes the difference as function difference set, and inside this I'll specify the parameter as var temp set equals. So before difference we can even say for intersect. So we'll focus on intersect first. So intersect set. Okay. And now we'll say intersect temp set as new set, and after that I'll call for for variable, that is for where I equals 0, I less than this dot data store dot length I plus plus. After this I'll say if set dot contains, it contains a value of the data store, that is this dot data store of I, then it will return a value as temp set dot add this dot data store of I. Now it will return me the value of temp set. So it will return temp set. After intersect comes the functionality for difference. So I'll say function difference as set with the value as where temp set equals new set, and here it will call for loop as for variable I equals 0, I less than this dot data store dot length and I plus plus. Now it will say if not equal to set dot contains this dot data store of I, then it will add the temporary set value as this dot data store of I, and it will return my temp set. Now let's calculate the union result. Prior to that, we'll also create an HTML file over here inside sets as advanced set dot HTML. Okay, so here I'll create the doc type first as doc type HTML, and inside this I'll specify the HTML tags, and then comes the head tag and the title tag. So title will be advanced set operations, and after that comes the meta tag as meta char set equal to UTF-8. UTF-8 will be my char set, and after this I'll call for the body tag. So this would be body. Inside this I'll specify the H2 tag, and it would be advanced set operations. Then comes my script tag as script. So it would be script tag. Inside this I'll specify the type as text/JavaScript. Then I'll specify the source code as advanced set.js. Okay, so I've created my HTML file. The next, inside my JS file, I'll create a union result as where CIS equal to new set. Okay, here I'll add the elements as CIS dot add. First value will be Mike, and I'll just copy paste the statement over here as CIS Mike. Then I'll add Clayton. Then comes the next value as Raymond. After this comes the next value, which is Jennifer. Now again I'll create a new set. So this was my first set, that is CIS. The next set is where DMP equal to new set. This will have the values as DMP dot add. The first value will be Raymond. I'll take this sentence, and after that I'll add Cynthia, and after Cynthia I'll add Jonathan. So two sets in common have only one parameter, that is Raymond. So this is common over here. Now what to do? Let's create a new set. Let's say my set is where IT equals new set, and there should be union of the particular set. So new set, over here I'll add the values as cis.add. So for union it would be IT. I'll call in the new line. IT is union of the particular set, so it would be IT equal to cis.union DMP. So it should show me all the elements: Mike, Clayton, Raymond, Jennifer, Cynthia, Jonathan. Raymond will not be repeated because it is common for both the sets. So here I get the console as console.log it.show, and inside this I get the respective values. Then afterwards I call for intersection set. So for that I will say where inter equals new set, and then I'll initialize the value over here as console where inter. So this is my inter as new set, so it would be inter equals cis dot intersect value as DMP, and I will print the console over here as console.log inter.show. Okay. After this, the next parameter is for difference, so it would be where difference equals new set, and that is nothing but difference equals cis dot difference. It will call for difference function, and it will get the difference with IT. So now I'll again print the console over here the way we did over here. So here the console would be it.show. Let's go to our browser and see what the output we are getting. So these are the sets. Now I call for advanced.html, so I get the elements in this format. And when I call for intersect, I get only one element, Raymond. And when I call for difference, I get the value as Mike, Clayton, Raymond, and Jennifer. So this is the basic implementation of advanced operations of sets in JavaScript. Searching and sorting. Now our next section focus would be about understanding the searching algorithm and the sorting algorithm. It would be interesting statistic to find out how much time pre-computer generation ages were taking to search for a particular thing and arranging them in an order, which is called as sorting. When a colossal waste it must have been to use these things manually. When history of computing is written searching and sorting, it would be right there at the top as entities responsible for changing the people do work. So that is the main focus when it comes to searching a particular item or sorting the list of items. So this is also a kind of a data structure part where we often focus on this part of what is to be searched. Suppose for example you have a queue or a linked list or a stack and you have to search for a particular item. Suppose you have 100 elements in that particular data structure. So it requires a lot of time to search for a particular element. For that we need an algorithm which would be easier so that a searching should not take much time. Similar thing happens with sorting. You have unordered sorting list for 100 elements in stack, array, queues or whatever. In that scenario, you should have some protocol or algorithm designed to it which would spend a little time for sorting an element in the particular order, say it like a ascending order or a descending order with n number of elements which is present in the data structure. So we often spend time in searching something or other. If some data is kept properly in some sorted order, then searching becomes very easy. Thinking of searching a words meaning from an unordered list, and then you will appreciate the way the dictionary is designed. So this chapter we are going to discuss about different type of searching and the sorting methods and its implementation in JavaScript. When it comes to searching is an operation which finds a location of a given element in the list. The search is said to be successful if I get the particular element and unsuccessful if the element is not found. I would repeat, search is said to be successful or unsuccessful depending on whether the element that is to be searched is found or not. So here we'll start first with searching and then we will start with sorting. For searching we have binary search, linear search, which are considered like two major parts of searching algorithm. When it comes to sorting, two of the most important operation as I mentioned for computer programming is sorting and searching. So this has been true at the beginning of the computer industry. So this means that sorting and searching are two most important studied operations in computer science. Many of the data structure discussed are designed primarily to make sorting and searching easy and very comfortable for a developer. For sorting, there are n number of sorting methods starting with bubble sort, quick sort, merge sort, heap sort, and various other type of sorts like insertion sort, selection sort, and so on. So let's focus on complete implementation. So first we'll move to searching. We'll understand what is linear search. And analyzing both of the searching algorithm, we'll move to the sorting algorithm where we will have bubble sort, and then we'll understand insertion, selection sort, and then we'll have a look on quick sort and merge sort. So this is like a basic introduction for understanding searching and sorting with respect to data structures. So let's start with our searching algorithm, the first part, and our first algorithm is linear search. Starting with our first searching algorithm, which is called as the linear search, or it is also called as a sequential search. The most obvious way to search for a data in a list to begin at the first element and then move on to each element in the list until you either find the data you are looking for or you reach the end of the list. So that is called as a sequential search. So it is called as linear search also. So both are synonyms, sequential search and linear search. It is an example of a brute force search technique where potentially every element in the data structure is visited on the way to solution. A sequential search is very easy to implement. Simply start a loop at the beginning of the list and compare each element to the data you are searching for. If you find a particular match, the search is over. If you get at the end of the list without generating a match, then this element which you are searching for, it is not present in the list. So that is why you get a value as 0. So searching is an operation where you find a location of a given element in the list. Search is said to be successful or unsuccessful depending on whether the element that is to be searched is found or not. So in linear search, let's start focus with this pictorial representation. Here I'll show you the stepwise searching thing which is to be done. This is the simplest method of searching. Linear search is the most simplest method and the easier method. In this method, the element to be found is sequentially searched in the list. The method can be applied to the sorted as well as unsorted list. Searching is it's a kind of searching in a case of a sorted list, starts from the 0th element and continues till the element which is found whose value is greater, assuming that the list is said to be sorted in the ascending order, and then the value being searched is reached. As against searching in case of unsorted list starts from the 0th element and continues till the element is found or till it reaches the end of the list. Consider for this array, I want to search for this element 57. So what I do, I start with the first 0th element in my array, that is 11. And I keep on searching, like I compare my value with this one. The array which is shown in this figure is consist of like I have 10 numbers in it. Suppose the element that is to be searched is 57. So 57 is compared with all the elements starting with the 0th element. So 57 is the element which I want to search. 57 is compared with the 0th element and the searching process ends either when 57 is found in the list or the list ends. The performance of the linear search algorithm can be measured by the counting comparisons that is to be done. The number of comparisons is say O. Suppose 57 is mentioned in the last of the array. Then the number of counting comparisons, if you want to say from 11 to the 9th element, it would be greater. So based on that, the performance of the linear search algorithm is completely measured by the counting comparisons it's to be done for the particular element. So now we had a look, but when it comes to the sorted list, It happens in such a way that searching of an element starts from the 0th element. Searching ends when the element is found or any element of the list is found to be greater than the particular element which is to be searched. So this is how is the basic concept for understanding the linear search or the sequential search. The sequential search or the linear search is the most basic search algorithm. It consists of comparing each element of the data structure with the one which we are looking for. So every element is like traversed, or I can say is found, and it is compared with the element which is to be searched for. The major drawback of this linear search or sequential search is that it is the most inefficient one because it reduces the performance. If you want to check out for one element and if the element is present at the last, it means the number of iterations. Now 57 is present in middle, but if it's present in the last, then the number of iterations for searching for a particular element will be so much that it would be very difficult for an element to find it out. Now in the next chapter, we will focus about implementing the linear search or the sequential search or in JavaScript, and we will check in our browser how the output we are getting. So this is our code base, and here we are going to start with our first thing is to create a algorithm or a JavaScript file with respect to our linear search. We have a folder searching algorithm over here. Here I'll create a new file and the name of the file will be linear search.js. So here I'm going to start with my all logic for linear search algorithm in this JavaScript file. So let's start with the first function. My first function will be to get the random array. So I'll say function disperse array. Here I'll take the parameter as array, and inside this I'll say for variable I equals 0, I less than array dot length I plus plus. So I have done with this for loop. Now I'll do the basic thing is to print the console. So I'll say console.log array of I plus a blank value. Now I will just check out for two things over here. Inside this for loop, I'll print if I modulus 10 equals 9, then console.log a blank or a new line, I can say. So this was within the for loop. Outside for loop, I'll specify for I modulus 10 not equal to 0. Then you should specify console.log a new line. So we should always have our check condition over here. So this was for if loop. So I've created a disperse array which will generate a random values of the arrays. Now I'll create a variable. My variable will be var numbers equals a blank array for variable I equals 0, I less than 100, I plus plus. In this scenario, I'll say nums of I equals mat.floor, that is mat.random into 101, which means it will generate a random value and it will multiply the product as 101. So this is a main logic to generate a random values in the array. That will be obviously the unsorted format of an array. Okay. So now we'll do one thing. We'll call for this function and send the parameter of numbers over here. So this will be disperse array numbers. So now you can even print this value. Automatically it will print a value of the arrays inside it. Now the next thing is calling a function for sequential search or linear search. So I'll do function sequential search array data, and within this I'll say for variable I equals 0, I less than array dot length I plus plus. Okay, so I'll just call for a variable with the index I and I will search for the particular array. The value to be searched is the parameter, that is data. Now I'll do one thing. I'll call for a if condition which will say if my array with the particular index value equals data, then return true. Okay, else it will automatically return false, because if it is equal then only we will have this if condition statement implemented. Now what I'll do, I'll create a number. So it will be variable number equals 101. If sequential search, I'll call for a function. I'll send numbers, the random numbers which we generated now, and num will be this number which I'm going to search for. For now I'm sending a hard-coded number. We can change the values as and when which is needed and have the code implemented in our browser. Now I'll do one thing. I'll just print console.log number plus I'll print a statement is found in the array. Okay, so this would be my output if the element is found in the array. On the other hand, now if I say else, I will get console.log number plus statement is not found in the array. So this was my JavaScript logic for implementing the linear search or the sequential search. I'll just mention the comment over here. Implementation of linear search. Okay. Now I'll do one thing. I'll create a file and my file will be linear search.html. Here I'll create the HTML file as doctype HTML, and within this I'll specify HTML, and then comes my head tag. After head I'll specify the title, and my title is linear search implementation. And before to that I'll specify meta as meta charset UTF-8. Now I'll specify the body tag as body, and the body tag will have h2, like specifying that this is example of linear search algorithm. After that I'll specify the script tag. So my script tag will be script src linear search .js. So this is how I've done, and now I'll go to my browser and analyze what is the output I'm getting, whether I'm getting the proper output for my linear search implementation. So this was our searching algorithm, starting with our first search, that is the linear search. Now what I'll do, I'll call for linear search algorithm. I'm getting example of the linear search algorithm as it was mentioned. Now if I call for the console inside the inspect element, I get the output that 101 was not found in the array. So if you want to check, there are n number of random elements which are generated, but of this I have 100, but I don't have 101. So the similar thing I can do it over here with some other number which I want to search it, and I can do it with specifying that number in my console in the code section and search it again in my HTML file. I get 82 is not found in the array because I have 83 in it. So linear search keeps on searching for each and every element which is present in the array, and if you get the output, it is automatically visible. 82 is not there because we can easily see it over here. We found 83, but 82 was not there. We have 92, we have 86, like which is the values which are nearer to 82, but we don't have 82 value with respect to linear search algorithm. So that is why we are not getting the output which is desired. So this was the basic implementation of linear search algorithm. Moving on to our next chapter would be understanding the binary search algorithm and the implementation of binary search algorithm in JavaScript. Moving on to our next type of searching algorithm, which is called as the binary search. Binary search method is the very fast and efficient searching algorithm. This method requires the list of elements to be in the sorted order. In this method, to search an algorithm, we compare it with the element at the present and the center of the list. If the match is successful, the search is said to be successful. Otherwise, the list is divided in two halves. One from the zeroth element to the center element and the another one from the center element to the second half of the element. So this is how is the basic searching takes place when it comes to a search arises with respect to binary search algorithm, where the list is divided in two halves. One from zeroth element to center element, first half, and another one from center element to the last element. As a result, all the elements in the first half are smaller than the center element, whereas all the elements in the second half are greater than the center element. When a data you are searching are for sorted element, a more efficient search that is better than a sequential search is the binary search. So this chapter is first like we will understand what is binary search all about. To understand how binary search works, we can imagine a small example like you are playing a number guessing game where a possible number is between 1 and 100 and you have to guess the number as chosen by a friend. According to the rules, for every guess you make your friend has like noted three responses. First thing is like your guess will be correct or it will be either too high or too low. With respect to that, following these rules, the best strategy to choose, say for example, you have to guess your number and you have guessed a number, say 50. If that guess is too high, then you can choose 25. And if the guess is too low, then you can choose 75. So it is like you increment and decrement mid value of 50 and accordingly you keep on guessing the numbers. For each guess, you choose a midpoint by adjusting the lower range or the upper range of the numbers, depending on whether the guess is too high or too low. This midpoint becomes your new guess, and as long as this strategy keeps on, you will guess the correct number in the minimum possible number of the guesses. So this is how is the guessing name. Guessing name secret number is 82. So I have this path with me. My first guess is 50. Obviously 50 is like too low when it compares to 82 formality. So I get 50 as too low, which means that my guess is somewhere between 50 to 51 to 100. So I take another midterm and my first guess after this would be 76. I also get that 76 is also low. Then I again guess a value between 76 and 100. And my third guess is say a random guess which I say is 88. Now my answer which I am getting is like too high, which means that my number is somewhere between 76 and 87. So I again keep a guess. So my guess would be 81. Then again I get a value as low. But if I guess 82, then I get a value which is like, yes, my guess is proper. So midpoint is 82.5, which is recorded to 82 and which is the correct answer. Similar format takes place in binary search. In this search, to search for a particular element, we compare it with the element present at the center of the list. If it matches, the search is successful. Otherwise, the list is divided into two halves, from the zeroth element to the center element and another from the center element to the last element. As a result, all the elements in the first half are smaller than the center element, whereas all the elements in the second half are greater than the center element. The searching will now proceed in either of the two halves depending on whether the element is greater than or smaller than the center element. If the element is smaller than the center element, then searching will be done on the first half, otherwise in the second half. So this kind of process is done. Let's refer to this figure. My number to be searched is 57 and I have this number of elements in the list. So my number is 57. Suppose this is my array which consists of 10 stored numbers and 57 is the element to be searched. The binary search method when applied to this array works in this particular manner. Step number 1. 57 is compared to the element in the present at the center which is called as 11. And it is visible that 11 is a value which is lesser than 57. So what it does, if 57 is greater than 11, then searching of the element is restricted to the second half. Automatically it says that this element, there is nothing to be searched from this side. We have to go to this side, that is towards the right hand side, and here it will keep on searching. And now the next thing what it does, now 57 is compared with the center element, that is 25. Center element of the second half of the array. Here again 57 is greater than 25. Obviously we get that value. Now what it does is like we get 57 which is greater than 25, so that searching now proceeds in the element which is present between 25 and 19. The process is repeated until we get 57. So automatically in just 3 steps we found 57 is there. So it is like it follows an algorithm. Step number 1, set a lower bound to the first position of the array. Set upper bound of the element to the last position of the array, or set the upper bound to the last element of the array. While the lower bound is less than or equal to the upper bound, keep on repeating the step, that is set a midpoint, that is upper bound minus lower bound divided by 2. If the midpoint is less than the data being searched for, set a new lower bound to the midpoint plus 1. If the midpoint element is greater than data being searched for, set a new upper bound to the midpoint minus 1. Otherwise, return the midpoint as the found element. So this is the basic logic for binary search implementation. Now in the next chapter, we will focus about implementing binary search algorithm in JavaScript and the according output what we are getting in our browser. So let's start creating a file. So my HTML file and JavaScript file will be created in searching algorithm. So here I'll create with the JavaScript file, that is binary search.js. Here I'll start with the first function the way we did with our linear search or the sequential search, is generating the random values of the array. So we'll do that over here as function disperse array. And here we'll include the logic with the parameter of an array. There I'll call for a for loop for variable I equals 0, I less than array dot length, I plus plus. After this I'll call for console, that is console.log array of I plus a blank string. So I'll concatenate it with a blank string, and then I'll call for the if condition. So my if condition would be if I modulus 10 is equal to 9, which means that my generated values should be 9 elements at a string. Then console.log new line. Okay. And outside the for loop I'll specify if I modulus 10 is not equal to 10, then I'll print for console, that is console.log as new line. So I've created my disperse array, that is nothing but distributing a particular array, random array at a stretch with 10 number of elements in it. After this, I'll do one thing, is to create a numbers. So I'll say var numbers equals blank array, and then I'll specify for variable I equals 0, I less than 100, I plus plus. And here I'll specify numbers of I equals mat.flow, and there I'll specify the random values generated, that is mat.random into 101. So I specified the random values over here. Now I'll call for distribution array, that is disperse array function, with the numbers value, that is the array which we created right now, the blank array. So this has created our random arrays. Now comes the main logic for binary search. As I mentioned, binary search will have following steps like a simple steps of algorithm which should be kept in our picture. So that is like, first thing, set a lower bound to first position of the array. Second thing, set an upper bound to the last element of the array, that is length of array minus 1. While the lower bound is less than or equal to the upper bound, we should repeat the steps, that is set the midpoint, that is upper bound minus lower bound divided by 2. And if the midpoint is less than the data being searched for, then set a new lower bound to the midpoint plus 1. But if the midpoint is greater than the data being searched for, set a new upper bound to the midpoint minus 1. Otherwise, return the midpoint as the found element. So we'll follow this logic in our function, that is binary search, which will be given as function binary search. Here I'll give the array and data, and over here I'll specify where upper bound equals to array.length minus 1, and here I'll specify the lower bound where lower bound equals 0, while lower bound, so I'll specify the algorithm condition, the step number 3 which we discussed right now, while lower bound is less than or equal to upper bound. Then we call for a mid value, that is where mid equals mat.floor upper bound plus lower bound plus lower bound divided by 2. Okay, then I say if, here I specify the condition that if my mid value, whatever I am getting, that is array of mid is less than data, that is the element to be searched, then we set the lower bound limit equals mid plus 1, that is the middle value plus 1. Else if I get the condition that array of mid is greater than data, then we specify the upper bound limit as mid minus 1, that is setting up the value for the new upper bound to the midpoint minus 1. And then the else condition is like, if both the condition is not satisfied, then return the midpoint as the found element, else return mid. Okay, now we'll do one thing, is to create a variable. So my variable will be var variable as 20, the value which I am going to search for. Now I'll say for variable I equals 0, I less than 100, I plus plus. So I increment the loop in this format. Now I do numbers of I equals mat.floor mat.random into 101, and here I specify the disperse array. So this should be disperse array, that is numbers, and then I'll specify where val equals 22, where return val equals binary search. I'll call for this function name, that is binary search. I'll call it over here, and here I'll specify the numbers and val, Numbers means the random generated numbers, and val is the value which we are searching for, this number. You can see it over here as 22 or 20. We can, for the time being, we can comment this section also, this particular section. Okay. Now I'll do one thing, is to create a random generated value. So we have created numbers. Now the next part is to create a random generated value thing with the help of a console. So I'll just say if return val is greater than or equal to 0, then I should print that console.log found plus val plus at position plus return val. And next thing I'll say else console.log val plus is not in the array. Okay, so I've created the JavaScript file. The next step here I'll do is, after creating the JS file, is to create an HTML file. So that is binary search.html. Here what I'll do, I'll create a doc type first. So that would be doc type HTML, and then comes the HTML tag. Inside the HTML tag, I'm going to specify the head tag, that is head, and head tag will have the meta tag, that is meta char set UTF-8, and within that we'll have the title. So this is my title, which will be binary search implementation. And after that I'll have the body tag. So my body tag would be body. Here I'll call for h2, that is example of binary search implementation or algorithm implementation. So we'll enclose this h2 tag properly in the align format. After that I'll call for script tag. So that is script type text/JavaScript, and then I'll say source as binary search.js. Okay. Now let's go to the browser and check for the output which we are getting. So this is our browser, and here when we call for binary search.html, we get the output in this format. Like 22 is not there in the array because we mentioned for the value 22. But on the other hand, if you want to search for some other elements or the value, we can go inside the code base and change the values accordingly and search whether we are getting the value or not. So if I say again 20, it is not there in the array. So this is the way all the values it will search, and accordingly if you get a value, automatically it will show an output that it is present in the array. Starting with our sorting algorithm, first algorithm, which is called as the bubble sort. The fundamental concept for basic sorting algorithms is that there is a list of data that needs to be rearranged in the sorted order. From the word sort, it is clearly mentioned that the sorting should be in such a way that it should be either in the ascending order or descending order. The technique used in these algorithms to rearrange the data in a list is a set for nested of loops. The outer loop moves through the list of items one by one, while the inner loop is used to compare the elements. So basically we will have two loops over here. The one which compares the elements and the one which moves from one by one. It's like incrementing a position from one value to another value. These algorithms are very closely simulate how humans sort in real life, such as how a card player sort cards when dealt on a hand, or how a teacher sorts papers in the alphabetical order or grade order. So the first algorithm which we will be focusing on is the bubble sort algorithm. So let's understand what is bubble sort. From the way, I would like to just mention that bubble sort is the first basic sorting algorithm, and it follows a typical iteration kind of a method. It is an internal sorting method, and there are different types of internal sorting methods. We will discuss some of the standard methods that are generally used. Of that, the first comes is the bubble sort. The bubble sort with a minor change is used to sort a data in such a way in either in the ascending order or descending order. So in this method, to arrange the elements in the ascending order to begin with the zeroth element is compared with the first element. Okay, the zeroth element of an array is compared with the first element. If it is found to be greater than the first element, then they are interchanged. Then the first element is compared with the second element, and if the condition happens in such a way that it is greater than the second element, again they are interchanged. In the same way, all the elements are compared with the first element, that is the next element, and then they are interchanged if required. This is the first iteration. So it goes through iteration wise. First iteration and then splits the first element. And after the n number of iterations, say it for second iteration, the comparisons are made till the last but one element, and this time the second largest element gets placed in the second largest position. As a result, all the iterations becomes in the sorted list, and that is what it is called as the bubble sort. It sorts in the bubble sorted manner. Suppose an array consisting of 5 numbers. So this is my array 25, 17, 31, 13 and 2. It consists of 5 numbers. Bubble sort algorithm works in this format. In the first iteration, the zeroth element 25 is compared with 17. Since 17 is less than 25, or I can say 25 is greater than 17, they are interchanged. Now 17 is come in the first position, then 25, then 31, then 13, then 2. Now 25, now 31 and 13 are compared with each other. Now the first element 25 is compared with 31, so it is observed that 25 is less than 31, so they are in the proper position. Now 13 is compared with 31, so it is observed 13 is less than 31. Now again the swapping takes place to 31. After that 2 is compared with 31, for obvious 31 is greater than 2, so 31 takes the last position. So in this process is repeated till n minus 2 element, the second element. Now the second iteration takes place and we get 25. After that we have the third iteration and we have 17, 25, 31, and the fourth iteration gives you the proper sorted list. This process is repeated until n minus 2 element is compared with the n minus 1 element. During the comparison, if n minus 2 element is found to be greater than the n minus 1 element, then they are interchanged, otherwise not. At the end of the iteration, n minus 1th element holds on the largest number, and the second iteration includes the 0th element, which is 17. So the above process in the comparison and interchanging is repeated, but this time the last comparison is made with n minus 3, that is third, and n minus second elements. If n number of elements and then n minus 1 iterations are needed to be performed. Suppose you have 5 numbers in the array, then 4 iterations will be there. And if we have 10 numbers in the array, then 9 iterations will take place. So in short, the complexity of the algorithm is such that the best case will be when we get n squared, and the worst case will be in such a way, like in this similar scenario, when we have number keep on increasing for a particular value. In such a case, we can say it is said to be the worst case scenario for a bubble sort algorithm. So let's start with the basic implementation of sorting thing in JavaScript, where every sorting algorithm will be implemented. So let's move to our code base, and there we will create a sorting functionality with the help of an array testbed. So we start with this chapter by developing an array testbed to use and support for our study for basic sorting algorithms. We'll build a class for array data and functions that encapsulate some of the normal array operations. What are the normal array operations which it encapsulates is inserting a new data, displaying the array data, and calling the different sorting algorithms. included in the swap function. We will use all these sorting algorithms in the systematic manner. So let's start with our array testbed class and we will create it in our JavaScript file. So this is our code base, and here in the sorting algorithm I'll create a file and the name of the file will be sorting.js. This would be common for every files which we are creating. So let's start with our array testbed. So here the first function will be to create a C array class. So let's start with it. So it will be function C array and it will take num elements, that is nothing but number of elements as the parameter in it. And then I'll start with this dot data store. This dot data store equals blank array, and then comes the position at this dot position equals 0. This dot num elements equals num elements, and this dot insert equals insert. So once we are done with these parameters, we'll do the toString parameter, that is this dot toString. This dot toString equals toString. Okay. Now I'll do a clear functionality, that is this dot clear equals clear. After this, I'll call for set data functionality. So these all functionalities will be needed in our sorting algorithm. So we're going to follow the same structure over here. This dot set data equals set data. Okay. Now what I'll do, I'll use the swap functionality. So I'll call for swap functionality, that is swapping the numbers in the array. So this dot swap equals swap. Now I'll call for loop, that is for variable I equals 0, I less than number elements I plus plus. Okay. Now here I'll do this dot data store of I equals mat.floor, and there I'll call for mat.random value as multiplied number with this dot num elements plus 1. Okay. So this is the basic structure which it is following. And after that I'll call for the next functionality. So I'll start with our first functionality is setting my value for my array testbed. So that is done with set data. So here I'll say function set data as for calling for loop for variable I equals 0, I less than this dot num elements I plus plus, and inside this I'll say I'm going to set my value. So I'll set the random values inside data store of I equals mat.floor mat.random, and inside the random value I'll specify the product as this dot num elements plus 1. This is what we called it over here. So we'll call the similar structure over here, this dot num elements plus 1. Okay. So I call for my random generation of the set data. Now I'll do one thing is to clear a value. Clearing a particular value, for that include a semicolon properly. So clear functionality is done as function clear, and here I'll mention for variable I equals 0, I less than this dot data store dot length. It will call for length parameter, and then I plus plus, and inside the clear functionality I'll say this dot data store of I equals 0. Okay. After this comes the insert functionality, that is inserting a particular element in the array testbed. For that I'll say function insert element, and there I'll specify this dot data store, and the position of the array will be incremented. This dot position plus plus, that is the last position, will be embedded with the array. Then we have swap parameter. So I'll call for swap as function swap with three values, array, index 1 and index 2, where I'll swap the variable with the help of temp, where temp equal to array of index 1 and then array of index 1 equals array of index 2, and then specify the parameters properly, and then we have array of index 2 equals temp parameter. After swap, I'll call for the return string parameter, that is the toString parameter, that is function toString. Here I'll mention the toString value as value variable return string equals blank value for variable I equals 0, I less than this dot data store dot length I plus plus, and inside this I'll specify the return string, that is return string equal to this dot data store of I plus blank value if I greater than 0 and I modulus 10 is equal to 0, which means that my particular string length corresponds to the length which is divisible by 10, then I should return a new line. That is the logic which I am designing for. So I've done with my for loop over here, and the if condition is specified properly. After this condition of for, I'll return the value as return string. Okay, so we've done with the toString parameter. So this is what is the basic sorting algorithm. First is like we declare a C array, which is nothing but our array testbed. Then set data to set the elements inside the array. Then a clear function to clear the values of the array. Insert element to insert a value inside the array. Swap to swap the integer values, and toString to return the elements of an array in the format of a string character. In the next chapter, we will focus about analyzing the bubble sort algorithm in JavaScript functionality. Starting with the first thing is like we will create a basic file for bubble sort implementation, that is bubble sort.js. Here I'll create a function, that is function. It will be a testbed, so C array, and inside that I'll call for num elements. Okay, after this I'll say this dot data store equal to blank array, and after that this dot position equals 0, this dot num elements equals num elements, and after this comes this dot insert equals insert. After insert, I'll specify for next parameter, that is toString. So this dot toString equals toString, and after that comes the clear data, so that will be this dot clear equals clear, and after this comes this dot set data equals set data. So once specified with this parameter, the next thing is to swap the values. So this dot swap equals swap. So once we are done with this, after that we'll generate the random values of an array as for variable I equals 0, I less than num elements I plus plus. Inside this, I'll specify the data store value as this dot data store of I equals I. Okay. So this was for the bubble sort implementation. After that, we'll set the value as function set data, and inside that I'll get a value that for variable I equals 0, I less than this dot num elements I plus plus. Okay. Inside this, I'll give this dot data store of I equals mat.floor, and inside that I'll specify the random value as mat.random random value with the product, that is into this dot num elements plus 1, and we will enclose this num elements in a particular format. We need this array testbed for our bubble sort algorithm, so we'll follow the same thing over here. After this, I'll call for clear functionality. With after set data, the clear functionality will be called as function clear, and inside this I'll specify for where I equals 0, I less than this dot data store dot length I plus plus, and here I'll call for data store value, that is this dot data store of I equals 0. Now after this comes the insert functionality as function insert element. I'll insert a particular element in this array list, that is my array testbed, as this dot data store with the last position. So my position plus plus will be pushed with the value of an element. Okay. After this, I'll call for the next functionality. After insert comes is toString. So toString will be specified as function toString, and it will take a parameter variable return string equals blank value for variable I equals 0, I less than this dot data store dot length I plus plus. Okay, so it will return string value as return string concatenated with the value, that is this dot data store of I plus a blank value associated to it, and I'll take a condition over here like if I greater than 0 and I modulus 10 equals 0. In such a scenario, I should return string value concatenated with a new line character. So plus equal to new line character. Now I will return the string value with a return string variable in it. After this comes the swap parameter. So swap parameter will be specified with the swap functionality as function swap array index 1 index 2, and inside this I'll say variable temp equals array of index 1 and array of index 1 equals array of index 2 and automatically my particular array value, this like I'm swapping my index values and also the values of the associative arrays. Array of index 2 equals temp. Now comes my logic for bubble sort. So my logic for bubble sort will be like you're just checking the next value and you're comparing those values. Once you see that the next value is less than or greater than in that particular format, I will sort my particular numbers in the ascending order. So I'll say function bubble sort. Inside this I'll specify where num elements equals this dot data store dot length. After that I'll specify where temp, and I'll use the outer and inner loop. Outer loop to verify, that is to increment from one value to the another value, and the inner loop to compare the first value with the second value and accordingly swap the values. So where outer equals num elements and outer greater than equal to 2 minus outer. Okay, and now I'll say if this dot data store of inner is greater than this dot data store of inner plus 1, that is the next incremented value, then I should swap the variables, swap the data storage. So this dot data store inner and inner plus 1. Okay, so this is my complete logic for bubble sort. Now what I'll do, I'll create the num elements. So my num elements will be with the value, say 5 array elements, and here I'll call for my array testbed. So where my nums equals new C array num elements, and inside this I'll specify my nums dot set data, and after that I'll say console.log my nums dot toString with the value associated to it, and my nums dot my nums dot bubble sort. I'll call for bubble sort functionality, and accordingly I'll print the value of my nums over here. So I'll again say console.log and then console.log my nums dot toString. Okay, so we have created the associative logic for bubble sort with the outer and inner loop following a particular structure. Now what we will do, we will call for our functionality inside our HTML loop. So I'll create a new file. The name of the file will be bubble sort.html. Here I'll again call for the doc type HTML. Here I'll say HTML, and the values will be associated in head tag. Head tag will have a meta tag, that is meta char set UTF-8. Okay, and then we'll have the title tag. The title will be bubble sort. After that we'll have the, after title and head tags, we next move to the body tag. So we'll have the body tag and the h2 tag in it, which is bubble sort implementation. And then we'll have the script tag, that is script src equals bubble sort sorting.js. Okay, so let's go to our browser and have a look like how the sorting implementation takes place. So in our browser, if you like to check over here, this is the bubble sort algorithm, and if we check out, this was our sorting.js which we created for our random testbed. With the basic functionalities is declaring a testbed, array testbed, then set data, then clear, then insert, then swap, then toString, and so on. With bubble sort over here, I can see the random values which I got generated with the array. This first value was 05024. And after the bubble sort iterations, with the number of iterations, finally it is getting the value as 00245. So this is how bubble sort is implemented with the help of JavaScript. Starting with the next algorithm, that is selection sort. This is the simplest method of sorting. In this method, to sort the data in ascending order, the zeroth element is compared with all other elements. And if we get the zeroth element, like the first element of an array, to be found greater than the compared element, then they are interchanged. So after the first iteration, the smallest element is placed in the zeroth position. The same procedure is repeated for the first element and so on. And this can be explained very well with our iterations of selection sort in our example. This is my selection sort starting with the first iteration. Here you can see the first iteration, the zeroth element 25 is compared with the first element 17, and since 25 is greater than 17, they are interchanged. After that, the zeroth element 17 is compared with 31. We don't go adjacent wise, we go it randomly with the other numbers. 17 is compared with 31, and now it is seen that 31, 17 mean less than 31, they are not interchanged. Then afterwards, 31 is compared with 13, and later the position is swapped from 17 to 13 because it is observed that 13 is less than 17. So 13 takes a position over here and 17 takes a position over here. And after that, 13 is compared with 2, and later it is visible that 2 value is less than 13. So again the position is being swapped. So the process is repeated. Now if you go to the second iteration, so 2 is taken in the sideways. Next after that, 25 is compared with 31. Okay, fine. Now it is proper because 25 is less than 31. The sorting is perfectly working. Now 25 is compared with 17. Then I see that 17 value is less than 25. So this 17 takes the position of 25 and 25 is swapped over here. Now 17 is compared with 13 and it is swapped over here. If you look out for the working functionality of sorting over here with respect to the bubble sort was working with the adjacent element. Whereas in selection sort, it takes a random of all the elements which is present inside the array testbed. This process is repeated till the zeroth element is compared with the rest of the elements. During the comparison, if the zeroth element is found to be greater than the compared element, then they are interchanged, otherwise not. At the end of the first iteration, the zeroth element holds the smallest number, and the end of the first iteration also says that the zeroth number will have the smallest number and the first number will have the values which is less than or greater than the adjacent values. Now we have the second iteration and the third iteration. Again we call for 2 and 13 which is swapped together. Now 31 is compared with 25 and now I get 25 to be less than 31, so it is swapped again. 25 is compared with 17 and again 17 takes a position over here. So 2, 13, 17 has been sorted properly. Now 31 and 25 is checked and then we check that 25 is less than 31 and it is swapped accordingly. So after the fourth iteration, I get a value like 2, 13, 17, 25 and 31. So this was like the basic iteration solutions for the selection sort. But if I want to focus on the number of elements which are present in it and the complexity, I can say the complexity of the selection sort is similar to that of the bubble sort. The number of interchanges and the assignments depend on the original order of the elements in the array, but the sum of these does not exceed a factor of n squared. The next sorting algorithm, the major sorting algorithm, is the selection sort. Now, this sort works by starting at the beginning of an array and comparing the first element with the remaining elements. After examining all the elements, the smallest element is placed in the first position of the array and the algorithm moves to the second position. This process continues until the algorithm arrives at the next to last position in the array, at which the point we can say all the data is sorted. Nested loops are used in selection sort algorithm. The outer loop moves from the first element in the array to the next element and so on. The inner loop moves from the next second array element to the last element, looking for the values that are smaller than the element currently being pointed to the outer loop. After each iteration of the inner loop, the smallest value of the array is assigned the proper place in the array. So the example of how selection sort works can be typically represented with our fourth iteration, which we saw for now. The number of iterations depends on the array length. My array length over here was 5. So obviously the number of iterations which took for me was 4, that is n minus 1. So let's focus in our next chapter where we will create a basic example of a JavaScript functionality in insertion sort, and we'll have a look like how we get an output with respect to insertion sort in JavaScript. So the first step now we'll do is to create a basic file. So my file will be inside sorting algorithm, and here I'll create insertion sort dot html. And here I'll create the doc type, so that would be doc type HTML, and after that I'll call for the HTML tag, that is HTML head, and inside head I'll call for meta tag, that is meta char set UTF-8, and after that I'll call for the title tag, that is title specified over here as insertion sort. Okay, now after this I'll call for the body tag. After the head tag comes the body tag, so I'll say body, and inside body I'll call for h2, that is insertion sort example. So once we are done with this part, we'll call for the script tag, that is script tag script src equals insertion sort dot js. So we'll create this file insertion sort dot js after completion of our HTML file. We'll also specify the type tag over here, that is type tag text slash JavaScript. Okay, now what we'll do, we'll create a new file. The name of the file will be insertion sort.js. We'll take the same file over here, copy paste it in this particular format so that there will be no issues of the array mistakes. Here we'll call for all the functions which we have over here for sorting.js. So we'll call whatever the functions was associated over here. First was to create the array testbed. So each and every function will be called over here with the comments associated to it. So creating an array test bed with the constructor values. After that we created the set data functionality. So we start with the set data thing. We'll copy the same thing over here inside insertion sort, specifying that initializing the set data values. And after that we have the function for clearing. So I'll say function clear will be specified over here for clearing up the values. So I'll include all the values over here, and after that I'll take a functionality for insertion. So that will be inside insert. So it's like for inserting an element in array, or I can say array testbed. After insertion comes swap and toString. So I'll take both the parameters over here. So I have taken all the parameters with respect to sorting algorithm. Now begins my major search, that is the major part is selection sort algorithm. So this is will be done like, okay, we are focusing on selection sort, so we'll just rename this file as selection sort.html, and over here also I'll rename it as selection sort.js. Here I'll take it as selection sort. Next chapter will focus on insertion sort. So this path will be specified over here. After that, we'll call for functionality, that is selection sort as function selection sort, and here I will say var min temp. I'll take two parameters over here. First, I'll go for the outer loop for var outer equals 0, outer less than or equal to this dot data store dot length minus 2. After that comes plus plus outer, and after this I'll call for min equals outer, and I'll say for var inner equals outer plus 1, inner less than or equal to this dot data store dot length minus 1 with the incremental value of inner, and then we'll start with a condition specifying if this dot data store of inner is less than the next value, the adjacent value. So that would be this dot data store, and the value will be inner plus 1. Or we can even say this inner plus 1 will be initialized as a min value for our specific related to selection sort. Now I'll say min equals inner, and after the for loop condition I will swap for my value. So I'll say swap this dot data store, and outer value will be my second parameter, and after that I'll say min. Okay, now I'll call for variable numbers. So my variable will be var num elements equals 10, where my nums equal new C array, and here I'll call for my num elements. After that I'll say my nums dot set data with the value, so it will generate random elements over here. I would like to say initially 6 elements will be sufficient for me. After that I'll say my nums dot set data. This will initialize my set data value, and after that I'll print the console over here. So that is console.log my nums dot toString, and after that I'll say my nums dot selection sort. I'll call for the selection sort algorithm, and then I'll say console.log. After that I'll call for console.log my nums dot toString. Okay, I've specified for these values. Now I'll do one thing. I'll go to my browser and check whether the selection sort algorithm is working as per the given condition or not. So this is our browser, and here you can see for selection sort I get a random element, say 6 elements, which I generated as 631046. Following the selection sort algorithm which we designed in JavaScript, I'm getting the value as 013466. So this is like the ascending order properly arranged inside with the help of selection sort. So this was the complete implementation of understanding selection sort with JavaScript. Insertion sort. Insertion sort is implemented by inserting a particular element at an appropriate position. In this method, the first iteration starts with the comparison of the first element with the zeroth element. In the second iteration, the zeroth element is compared with 0 and first element. In general, every iteration an element is compared with all the elements before that particular element. And during a comparison, if it is found that the element in question can be inserted at a suitable position, then a space is created for it by shifting the order of the elements from one position to the right and inserting the element at the suitable position. This procedure is repeated for all the elements in the array. So let's understand this with the pictorial representation which we have now. So insertion sort begins with the first element. Considering this for the first iteration, so we'll have the step-by-step procedure for the same. So here in the first iteration, the first element of 17 is being compared with 25, and it is seen that 17 is smaller than 25. Then 17 is inserted in the 0th place and 25 is shifted one position to the right. So insertion sort follows for the first step as 17, 25, 31, 13 and then 2. After that, in the second iteration, the second element, that is 31, is compared with 25 and 17. And it is found that 31 is greater than 17 as well as 25. So nothing is done over here. So we left it in the same way. After this, what happens? Then the next element is compared, that is in the third iteration. The third element 13 is compared with the 0th element 17. Since 13 is smaller than 17, 13 is inserted in the first position. And after that, what happens is 17 is compared with 25, so it is proper. Then we check that 31 is compared with 2. In the fourth iteration, the fourth element, that is 2, is compared with 0th element, that is 31. And here we get to know that the element 2 is less than 31. And after that, we also see that 2 is less than 25, 17 and 13 as well. So it's like every element is compared with all the elements which is previously present in it. And accordingly, we get the sorted order as 2, 13, 17, 25 and 31. So this is the basic step-by-step implementation of an insertion sort algorithm. Insertion sort is analogous to the way humans sort data numerically or alphabetically. Let's say it's like I have asked a student in a class to turn in an index card with his or her name, student ID or sort biographical sketch. The students return the card in random order and I want them alphabeticalized, ordered in a particular format so I can compare them to my class roster easily. I take the cards back to office, clear off my desk and pick up the first card. The last card name is say Smith and then I see Brown, and accordingly I say okay, I should keep the card with the name A and then B and C and D accordingly, and accordingly I will have to do with the sorting loops. So insertion sort basically takes two loops. The outer loop moves from element by element through the array, while the inner loop compares the element chosen in the outer loop to the element next to it in the array. If the element selected by the outer loop is less than the element selected by the inner loop, array elements are shifted over to the right to make the room for the inner loop elements, just as described in this particular example. So let's go to our JavaScript code implementation, where we will create the insertion sort example and understand how this is basically done. So let's go to our code base and understand the insertion sort implementation with JavaScript. So here this is our code base. Here I'll create a new file and the name of the file will be insertion sort.js. And inside this, I'll create the first thing will be to create whatever the array testbed we had in our sorting.js. So we'll do all the functionalities over here. We'll copy it over here. So we'll keep it here. These functionalities include creating a testbed, setting up a particular value of data in the array element, clearing the value of the elements in the array, inserting a particular element in the array, swapping the values in it, and returning the value in string format. Now we start with the insertion swapping logic as function insertion sort insertion sort, and here I'll start with my functionality of insertion sort with some values associated to it. So first comes the value as variable temp and inner. Okay, and after that I'll call for loop, that is for where outer equals 1, outer less than or equal to this dot data store dot length. After that, that would be length minus 1, and after that I'll say plus plus outer, and after this comes the temporary value, that is temp equals this dot data store of outer, and then comes inner equals outer, because we compare every value with whatever the values which are initially present with it. And then we'll have the while loop, while inner greater than 0 and this dot data store of inner minus 1 greater than or equal to temp. Then we'll give the value that this dot data store of inner should be equal to, this dot data store of inner minus 1. So we compare every value of the element which is present in it with the other values. After that we say minus minus inner. So we have given the while loop consideration. After the while loop consideration, I relocate my value of data store inner with temp value, that is the temporary value. So all the values are properly initialized over here in the insertion sort. Now what we'll do, we'll create an array. So my array will be where num elements equals, say, 6 values of inside an array, where my nums equals new C array, and here I'll call for num elements. After this I'll set my value where my nums dot set data as some particular value, then console.log my nums dot toString with some value associated to it. Okay, and after that I'll say my nums dot insertion sort with some value associated to it, and then console.log a blank value, and then I'll print whatever it is sorted over here as my nums dot toString. Okay, so we are created with our logic related to insertion sort. Now I'll create a file inside sorting algorithm, and the name will be insertion sort.html. Here I'll say doctype HTML, and then I'll specify the value over here as head. Inside head we'll have the meta tag, meta char set UTF-8. After this we'll have the title tag as insertion sort. Then we'll have the body tag as body, h2 insertion sort example. Then we'll have the script tag as script. We'll have it over here as script type text/JavaScript. Then we'll call for src, that is insertion sort dot js. We'll complete our script tag. Now let's go to our browser and check what the output which we are getting as like it's following the particular algorithm for insertion sort. So this is our browser, and if we go to our insertion sort, I get the random value as 0105432. But following the complete algorithm structure, I am getting the output properly in the ascending order as 012345. So this was the basic implementation of the insertion sort in JavaScript. Moving on to our next chapter, we'll be understanding about quick sort and merge sort, which are the advanced sorting algorithms. Now we'll be focusing about quick sort algorithm. Quick sort algorithm is one of the fastest sorting algorithm of large data sets. Quick sort is divide and conquer algorithm that recursively breaks a list of data into successively smaller lists, sublists consisting of smaller elements and the larger elements. The algorithm continues this process until all the data in the list is sorted. The algorithm is divided, it's like divides the list into two basic parts. Now considering in this picture, we have elements, say 10 elements in the array. So quick sort follows a basic algorithm for following a step-by-step manner of implementation. The algorithm divides the list into sublists. So it takes the complete list as one list and divides the list into sublists, considering the first element or any element as a pivot element. Data is sorted around the pivot by moving the elements less than pivot to the bottom of the list and the elements that are greater than pivot to the top of the list. Now 11 is the element if I consider this as a pivot. So what it does, it just takes the one thing that 11 should be taken in such a way that all the elements which are less than 11 is taken on one side and all the elements which are greater than 11 are taken on the other side. So that is the basic step procedure it follows, and the algorithm for quick sort is in such a manner that it pick a pivot element that divides the list into two sublists. So this is 11. It takes a consideration in such a way like it takes 13, and in that case it says that 13 is greater than 11, so it takes 13 on that side and automatically it shifts the values accordingly, and it divides the sublist and reorders the list so that all the elements less than the pivot element are placed before the pivot and all the elements that are greater than pivot are placed after it. So these steps are repeated till all the smaller elements and the larger elements are sorted in the proper order. Here you can see that suppose there is an array which consists of say 10 distinct elements. The quick sort algorithm works in this following procedure. Starting with step number 1. In the first iteration, we place the 0th element, that is 11, as the final position and divide the array accordingly. Here we can say 11 is nothing but the pivot element. To divide an array, two index variables are taken, say p and q. The indexes are initialized in such a way that p refers to the first element, that is 2, and q refers to the n-1th element, that is 3. The job of the index variable p is to search for an element that is greater than the 0th location, that is 11, and so p is incremented by value till the value of p is greater than the 0th element. In our case, it is incremented till 13, and once we get 13, it is seen that 13 is greater than 11. Similarly, for q, to search an element which is less than 11. For q, it is nothing but to search a particular element which is smaller than the 0th element. So q is decremented by 1 till the value is stored at q is smaller than the value at the 0th location. In our case, q is not decremented because 3 is less than 11. When these elements are found interchanged, then again the current positions of p and q are incremented and decremented respectively, and exchanges are made appropriately if desired. The process ends whenever the index pointers meet and cross over. In our case, they are crossed with 1 and 25, 1 and 25. And once this is done, the indexes of p and q values are also crossed accordingly. Finally, the 0th element 11 is interchanged with the value of the index q, that is 1. The position q is now the final position of the pivot element, that is 11. As a result, the whole array is now divided into two parts, where all the elements before 11 are placed in right hand side, and all the elements which are greater than 11 are placed in the left hand side with the sorted format. So this is the basic procedure of a quick sort algorithm. Let's start in our next chapter to understand the implementation of quick sort with our HTML file and JavaScript file, and we will check out the output. Are we getting the proper output by sorting out the algorithm, considering one element as a pivot element and sorting the right hand side of the pivot element smaller than that particular element and the left hand side of the pivot element greater than that particular element. Now let's start on focusing the implementation of quick sort with our code example. Now in the sorting algorithm, I'll create a new file and the name of the file will be quicksort.html. Here I'll create the basic HTML file or the doc type declaration which would represent the quick sort algorithm. So doc type HTML. Inside this I'll specify the head tag, the title as quick sort implementation. After that we have the meta tag which should be implemented over here. So we have meta charset UTF-8. Then after that we have the body tag. So body tag will enclose all the related files for scripting, and the h2 tag which is important, which comes after the head tag. So this is my body tag which will have h2 tags saying example of quick sort implementation. Now after this I'll call for the quick sort example with the scripting element. So that would be script type text / JavaScript, and after that I'll specify the source as quick sort.js. okay, and after this we'll start with our JS implementation. So let's create this particular file quicksort.js over here. Here we'll create a new file, that is quicksort.js. Then we start with the functionality of an array. So we create a functionality like function qsort array, and after that I'll start with if array.length equals 0, return blank value, because if the length is 0 it means there are no elements present in the array. So we'll mention a comment over here. This is the scenario to check if elements are present in the array. Okay, after that I'll say where left equals blank array, where right equals right will have a specific value as the value as a blank array, and after that we'll call for pivot, that is where pivot equals array of 0 for variable I equals 0, I less than array dot length I plus plus. If array of I is less than pivot element, then left dot push array of I. This is like to check whatever the elements which are lesser than the pivot element will be on the left hand side, whereas the elements which are greater than the pivot element will be on the right hand side. So here I'll mention the else condition, else right dot push array of I. Okay, now after this, so this is my complete functionality and this is the start of my for loop. After the for loop, I'll return the value. So I'll say return qsort left dot concat pivot with qsort of right element. Means the left element, whatever is concatenated, will be with the pivot element, and then which will be concatenated with the right element. So we are following the logic which was designed perfectly for quicksort algorithm. After this, I'll create a variable, say where a equals blank array. For variable I equals 0, I less than 10, I plus plus. Inside this, I'll specify a of I equals mat.flow. This is like generating the random elements in the array. Mat.floor, mat.random into 100 into 100, and I'll take this plus 1. So mat.random plus 1. So this is like first functionality. I'll also take that particularly in the bracket so that I can get the product first, and then it will be some added with the one element. After this, I'll say console.log a, and which will print all the elements of an a. Then I'll say console.log. I'll call for functionality quicksort. So I'll say console.log qsort, and it will take the parameter as a. Okay. So now let's go to our browser. So this is how we design our quicksort algorithm implementation in JavaScript. So let's go to our browser and check out for the output what we are getting. So this is our browser. Here we all saw the examples with the different sorting thing, but now comes to quicksort. Here you can see we already took an note that this is an example of a quicksort algorithm. So first goes with the array 10, which includes a value as 93, 33, 68, 71, 49, 65, 39, 34, 36 and 7, which is obviously not sorted. But with the help of quicksort algorithm, we get a value as 7, 33, 34, 36, 39, 49, 65, 68, 71, 93 and so on. So this was the basic implementation which was clearly mentioned over here. So this is like implementing quicksort algorithm as per my understanding. So this was done as per my understanding. So we have got the output. Now in the next chapter, we will focus about understanding, which is the basic advanced type of a sorting algorithm, which is called as the merge sort. Next algorithm we will be focusing now is the merge sort. Merge sort combines two sorted lists in one sorted list. For this, the elements for both the sorted list are compared. The smaller of both the elements is then sorted in the third array. The sorting is complete when all the elements from the list are placed in the third list. Consider for this part, okay, so this is our sorting algorithm. We are going to take two arrays over here. Suppose arrays A and B, that is this is array A and this is array B. They contain of 5 elements each. The merge sort algorithm works in such a way that arrays of A and B are sorted using an algorithm. The 0th element of first array, that is 11, okay, and the 0th element of the second array is compared. It is like first array 0th element and 2 is being compared with the 0th element, okay. Since 1 is greater, or we can say over here 1 is smaller than that of 2, in such a case, it is taken in such a way that 1 is placed in the third array. I would like to repeat, the 0th element from the first array 2 is compared with the 0th element of the second array 1, okay, and 1 is smaller than 2, so 1 is placed in the third array. After that again the 2 is compared with that of 3 and we get 2 is less than 3, so we place 2 in the first position. Now the 0th element from the first array 2 is compared with the first element of the second array and so on, and 2 is smaller than 3, that is why 2 is placed in that position. The first element from this array and the third element from this array is compared, and so on recursively we get that the elements 1, 2, 3, 9 and 11 and then 13 and so on are like replaced, and we get this particular format syntax in this order. Then we get 17, then 25, then 57 and then 90. So in this way we saw that sorting takes place quite easier and we get a value. Now you can see the first element from the first array 9 is compared with the first element from the second array 3. 3 is smaller than that of 9, that is why we keep 3 over here. Then we place the position of 9. That is now the first element from array, that is 9, is compared with the second element from the array with respect to 17. And it is seen that 9 is less than 17, that is why 9 is kept in that place. The same procedure is repeated till the end of the arrays is reached. Now the remaining elements from the array are placed directly into the third list as they are in the sorted order. So that is why merging a particular two arrays in such a format that they sort with respect to the elements present in the array, that is why it is called the term as merge sort. So merge sort is so named because it works, we can say, merging two or more sorted sublists together to form a larger completely sorted list. In this theory, the algorithm should be easy to implement. We need two sorted subarrays and the third array into which we merge the two arrays by comparing the data elements and inserting the smallest value in it. In practice, however, merge sort has some problems because if you are trying to sort very large data set using the algorithm, the amount of space we need to store the two sub-arrays can be quite large. Since space is not an issue in these days of an inexpensive memory, it is worth implementing merge sort to have algorithm in such a way it compares with respect to efficiency with respect to other sorting algorithms. Basically, there are two types of merge sort. Say top-down approach and bottom-up approach. Top-down approach, it is customary, though not necessary, to implement the merge sort algorithm as a recursive algorithm. However, it is not possible to do so in JavaScript as the recursion goes deep for an array to take place. That is why we implement the algorithm in a non-recursive way using a strategy called bottom-up approach. Bottom-up approach is like an iterative version of a merge sort referred to as the bottom-up process. The algorithm begins by breaking down the data set being sorted into a set of one element arrays. Then these arrays are slowly merged by creating a set of left and right subarrays, each holding the partially sorted data value until that is left with one array and which is perfectly sorted. So in this way we have the approach with respect to merge sort. How is the bottom-up approach actually implemented with respect to JavaScript? For that, we'll do one thing, is that we'll create a code in JavaScript and then we'll understand the logic how merge sort is implemented with respect to JavaScript. Over there, you will hear for the term called as infinity. Infinity is used as a sentinel value to indicate the end of either the left array or the right array. Each array starts out on its own left or right array. Then the two arrays are merged first with 2 elements each, then into 4 elements each except for 3 and 5, which stay apart until the last iteration. When they are combined into a right array, then they are merged into left array to reform the original array. Let's go to our code base where we'll create a function logic for merge sort and the function for merge arrays and how they are implemented. So let's start with our code base where we'll understand the logic, and then in our next chapter we will implement the merge sort in JavaScript and HTML5. So let's start implementing our functionality for merge sort. So we'll create a file over here, the new file, and the name of the file will be merge sort.js. So let's understand it considering like we will have two arrays and we'll configure the particular output of merge sort in such a way that the value of infinity is used as the sentinel value to indicate the end of either the left array or the right sub array. Each array list starts off with its own array, that is own left or right array. Then the two arrays are merged first into 2 elements each, then 4 elements except each for 3 and 5, which stay apart until the last iteration is performed. When they are combined into a right array, then the merged elements into the left array are reformed to the original array. That is the actual logic for merge sort. So let's create a function. My name of the function will be function merge array, and inside this I'll call for, or I can give the name as merge sort, and the sort will take a parameter of array. Okay, after this I'll specify if array of length, array.length is less than 2, then I will return the value, because we should have at least more than 2 elements in our array. And then we have variable step equals 1. Then after that we have var left comma right, and after that we'll have the while loop, which will say step array of length, and inside this I'll specify left equals 0 and right equals step. It will perform the logic, that is the first algorithm, and then I'll check for another while loop which says right plus step equals, or it should be less than or equal to array dot length. Okay, so once this is performed, then we'll have the merge array concept, that is merge array left, and the next parameter is left plus step, and after that we'll have right, and then right plus step. And now we'll call for the logic inside the while loop. So we have merge arrays over here. Merge array functionality will be called, so we'll call this functionality later, but inside the while loop we will say left equals right plus step, and after that right equals left plus step. So we will append the values accordingly once we have compared it. Now after the while loop I'll specify the condition that if right is less than array dot length, then we'll have a value merge arrays as array left, and then left plus step, and after that we'll have right, and then array dot length. Okay, so we have mentioned for if condition as well and the values associated to it. Then we'll call for the function, that is function merge arrays. We'll take a value like array start left, and then stop left. These are the parameters I'm going to take. L should be capital, and then left, and then afterwards we'll have start right, and then the parameter stop right. This is like to start a particular operation in left as well as the right array thing. Now merge arrays will have these 4 parameters which is mentioned over here. So that is the value for merge arrays. Now I'll call for the operation for merging a particular array with the help of merge sort algorithm. So here I'll say variable right array equals new array, and then afterwards I'll take stop right minus start right, and it will take the append value plus 1, and after that I'll have the next value, that is variable left array equals new array with the values stop left minus start left plus 1. After this, I'll start with the initialization of a value, say for a variable k. So I'll declare a variable, say var k, and k equals start right. So I'll indice this particular value, or I can say I'll just initialize the value as start right. Okay. After this, I'll call for loop. So that is for variable I equals 0, I less than right array dot length minus 1, and then I plus plus. And inside this, I'll specify right array of I equals array of k, and then I'll increment the k value inside it. Then I'll initialize, after this for loop, I'll initialize for k equals start left, and here I'll call for again for loop for variable I equals 0, I less than left array dot length. It will be like left array. I'm comparing the way we did for right array. So similar functionality will be followed over here. And here I'll again call for another loop specifying this should be completed in one paragraph. And then I'll say I plus plus. Here I'll include a value in the same format the way we did over here. So I'll just copy paste these values, but the values will be replaced as left array equal to array of k and k plus plus. So we have done with for loop, and here I'll specify right array of right array dot length minus 1 equals infinity. So I'm giving this value as the sentinel value. So I'll just mention here in my comment as sentinel value, and left array will be left array dot length minus 1, which equals infinity. Again a sentinel value being initialized, a sentinel value. After this, I'll have variable m equals 0, variable n equals 0, and then these variables will be initialized in my for loop later to get the merging value aspect in the proper order. Okay, so after specifying this, I would like to say right array of right array dot length minus 1 will be specified within the for loops condition, or we can even try with a different logic. Here I will like to say for variable k equals start left, and then I'll say k less than stop right, and then I'll increment my value for k. Now after this, I would like to specify a condition over there that if left of array of m is less than or equal to right of array of n, then I'll specify a condition over here that array of k equals left array of m, that is merging the value with respect to the condition, and m plus plus. After that, I'll specify the next after the if condition is the else condition, that is the else logic for it, that is array of k equals right array of n, okay, and then n plus plus. Now these conditions are given over here properly, so I have taken the logic for loop and the for loop over here is also mentioned. So now what is the next step we need to do is that we need to initialize the variable numbers, and these numbers will be sorted out. So I'll just say where numbers equals 6 comma 10 comma 1 comma 9 comma 4 comma, so I'm just trying to use the logic of merging elements. So I'll say 8 comma 2 comma 7 comma 3 comma 5, and after this I'll use console.log numbers, and after printing the console, after that I would like to say merge sort, and here I would like to include the logic that is of numbers. Before that I'll give a console of a blank string, so I'll say console.log blank value. So once this is specified, we call for merge sort and we will print the values over here. So I'll say console.log numbers. Again, the numbers will be printed over here after calling for the merge sort algorithm. Let's start creating a new file, and the name of the file will be merge sort.js .html, because we have created the JS file. Here we will have the doc type declaration as doc type HTML, which will have the HTML file, that is HTML, and then we'll have the head tag. The head tag will also have the title tag. My title is merge sort. Prior to title tag, I will include the meta tag, that is meta char set utf8. Okay, with this implementation, and then later we will have the, after head tag we'll have the body tag. So my body tag will implement over here with h2 merge sort implementation, and then later we'll have the script tag as script. It should be script in this particular format, script src, and the source element will be merge sort.js. Now we need to go to the browser and analyze whether we are getting the proper output or not. So considering for the merge sort implementation, this is the HTML file which we called for. Merge sort implementation is like the h2 tag which we mentioned in our HTML file. If you want to focus on the output, so this was the array which we called, that is 6, 10, 1, 9, the random unsorted values. But here with the algorithm of merge arrays, that is the way we created. So here you can see it is clearly visible over here. We have the left array, right array, and so on. So here you can see the left array and right array is imposed in such a way that 6 is taken and infinity is taken, that is the sentinel value. And then the next value taken over here is 10, and then the value is like infinity mentioned over here. So every value is like appended with the infinity value, which is merged later and which is sorted. And after that, with respect to the sorting algorithm, we get the properly sorted array list, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the way merge sort implementation actually takes place with respect to JavaScript. Moving on to our next chapter, we'll be focusing about hashing, which is like implementing hash tables in JavaScript and the output with respect to that. Hashing is a common technique for storing data in such a way that the data can be inserted and retrieved very quickly. Hashing uses a data structure which is called as the hash table. So here we will focus everything with respect to hash table. Although hash table provide fast insertion, deletion, and retrieval, they perform poorly for operations that involve searching and sorting, such as even finding minimum and maximum value. So it is a common technique for storing data in such a way that data can be inserted and retrieved very quickly. Hash table is designed around an array, and with this array we will be overcoming and understanding what all hashing techniques is actually used. For these operations, other data structures such as binary search tree are more appropriate. We learn how to implement hash table in this chapter, and later we learn to use hashing as a data storage and retrieval technique. Hashing consists of finding a value in data structure in the shortest time possible. Let's have an overview of hashing with respect to structure. First, I would like to say each data element is stored in the array based on an associative data element called key, which is similar to the concept of the key which we examined in the dictionary data structure. If you remember, for dictionary data structure, we had a look about what is the key value pair association we had. So similar thing is observed over here. So this is the hash table what we have. The hash table is designed around an array. The array consists of an element 0 through some predefined size. Though we can increase the size when necessary. Each data element is stored in the array based on the associated data element called key, which is similar to the concept of key which we have seen in our dictionary data structure. To store a piece of data in the hash table, the key is mapped into a number of range from 0 through a hash table size called hash function. Ideally, the hash function stores each key in its own array element. However, because there are unlimited number of possible keys and a limited number of array elements, a more realistic goal of hash function is to attempt to distribute the keys as evenly as possible among the array. Even with the efficient hash function, it is possible for two keys to hash the result of the hash function to the same value. This is called as the collision, and we need to strategy for handling collisions when they occur. We'll discuss how to deal with the collisions in detail later in the chapter. The last thing we have to determine when creating a hash function is how large an array is to create for a hash table. One constraint usually placed on the array size is that should be with respect to prime number thing. We'll explain why this number should be prime when we examine the different hash functions. It is always better to have a hash value with respect to prime number concept. After that, there are different kind of the unique strategies which are called with respect to the particular array size and everything. All of them based on the technique to handle the collisions. Now, if you can see, with respect to name, say Durr, Smith and Jones have some hash function associated to it. With respect to the hash value, the hash table has embedded the values in key value pair. Like this is the hash value and the value associated to it is the name of the user. Then we have another value and the value associated to it is again the name of the user, and so on. We have all these hash values associated in that thing. So we need to represent a class to a hash table. The class will include functions for computing hash values, a function for inserting a data into a hash table, a function for retrieving a data from the hash table, and a function for displaying the distribution of a data in the hash table, as well as various utility functions. So let's go to our code base where we will have a simple implementation of hash function in JavaScript, and later we'll have a look like how hashing is possible in JavaScript. Let's move on to our code base. So this is our code base. Inside hashing folder, we'll create a new file, say hashing.js. And over here, I'll create a JS file with a simple hash table concept, and we'll have the representation over here, that is choosing a hash function depends on the data type of the key. If your key is an integer, then it's a simplest hash function that it is to return the key modulo of the modulus of the size of the array. There are circumstances when this function is not recommended, such as when the keys all end with a 0 and the array size is 10. This is the reason why array size should be always a prime number, such as 137, which is a value which is used as a preceding constructor for function. Also, if the keys are the random integers, then the hash function should be evenly distributed, which is also called as modular hashing. Starting with a simple type of our function. So my function begins as function hash table, and over here I'll specify this dot table equals new array, and over here I'll have the value as 137. So we are considering a prime number which is greater than 100. So first prime number which is greater than 100 comes in our picture is 137. After that, we'll call for a simple hash function. So my simple hash function will be this dot, over here I'll include this dot simple hash equals simple hash, and then later I will say this dot show distro equals show distro, and later we'll have this dot put. Put is to put the values within the hash function. So this dot put is equal to put. So we have declared our hash function. Later we'll have the function for simple hash. That is our first implementation of hashing table in JavaScript. Function simple hash with the value of data, and where total equals 0. Later we'll have for variable I equals 0, I less than data dot length, and later I plus plus. After this I'll specify total plus equals data dot. It will take the ASCII character code with the function, inbuilt function called char code at. This is the inbuilt function for JavaScript. So here every ASCII character will be added as the total product, and later it will return a value in the modulus form, which is the hash value, that is return total modulus this dot table dot length. After this I'll call for put data functionality to put the values inside my table. So I'll say function put data, then I'll call for where position equals this dot simple hash data, this dot simple hash dot data, then this dot table of position, this dot table of position. So position will be taken as my parameter, and here equals data. After this I'll specify function show distro, and then I'll say variable n equals 0 for variable I equals 0, I less than this dot table dot length I plus plus, and then if this dot table of I is not equal to undefined, and then console, I'll print the value of my distribution of hash table as console.log I concatenated with colon value associated to it plus this dot table of I. Okay, so this was for showing up the particular value in my hash table as show distro. Now I'll declare some names. So my names will be where some names equals, the values are David, and then comes Jennifer, and after that I have a value that is Donnie, and after Donnie comes, so this is Donnie, and then Donnie later it comes as Raymond, and after Raymond comes Cynthia. So these are some of the values which I want to associate over here. Then after Cynthia comes Mike, after Mike comes Clayton, okay, Clayton, and then after that we will have Danny. So this is Danny, and then the last value I would like to add is Jonathan. Okay, here I will specify now where edge table. I'm going to create a new hash table as where edge table equals new hash table. So this is my new hash table. Now I'll call for a for loop, that is for variable I equals 0, I less than some names dot length, and then I plus plus. After this, I'll specify the value as htable dot put some names of I, and after that I'll have the call for the distribution function as htable dot show distro. This is my distribution function. So now after this, I would like to create inside my hashing a new HTML file, hashing.html. Hashing.html. So I'll create a doc type now. This would be my doc type HTML, and after that we'll start with the HTML tag HTML. Then comes my head tag. After that comes the title tag. The title is hashing algorithm implementation. After this comes, after the head tag, we should also specify the meta tag, that is meta charset UTF-8. After head tag comes the body tag. Inside the body, I would like to specify the h2 tag as hashing algorithm in JavaScript. Now I'll specify for script tag. So this would be script type. Type will be text/JavaScript, and the source will be hashing.js. Okay. So this was our implementation of hashing algorithm with respect to what we have seen in the basic thing with respect to JavaScript. Let's move to our browser and let's have a look like what is the value we are getting. As per the knowledge, we should get a value with respect to David, some value associated to David, then Jennifer, then Donnie, and so on. So let's have a look in our browser. So if I have a look, so this is our browser, and here we call for hashing.html. So as per the logic, we should get the output accordingly with respect to what was expected. Like every name should have some hashing value associated to it. So if you inspect for the element over here, you get a value for Cynthia as 35, Clayton 45, Donnie 57, David 77, Danny 95, Mike 116, Jennifer 132, and Jonathan 134. So let's have a look in our code with respect to simple hash functionality. This is what we created. The simple hash function computes a hash value by assuming the ASCII value, whatever the value of each name of JavaScript function. It takes the summation of these numbers and divides the total with respect to that of the table length. And show distribution function, that is show distro, displays where the names are actually placed in the array using the hash function. So as you can see in the output, the data is not particularly evenly distributed. The names are bunched up at the beginning and the end of the array. So this was like a very important thing. A close attention is given with respect to simple hash function. In the next chapter, we'll have a look about the better hash function, a better implementation of hashing technology. This chapter is to understand about better hash function. To avoid collisions, you must first need to make sure that array you are using for the hash table is sized to a prime number. This is necessary due to use of the modular arithmetic in computing the key. The size of the array needs to be greater than 100 in order to make more even disperse the keys in the tables. Through experimentation, we found that the first prime number greater than 100 didn't cause any kind of the collisions of the data set. That's why, if you remember in our last chapter, we focused on creating the hashing with respect to 137 value of an array, which is the prime number greater than 100, immediate prime number. After properly sizing the hash table, the next step to avoiding hashing collision is to compute a better hash value. Algorithm, which is called as the Horner's method, does the trick. Without getting deep into the mathematics of the algorithms, our new hash function still works by summing the ASCII values of the characters of a string. But it adds a step by multiplying the result with respect to a prime constant. So instead of a simple hash what we had over here, we are going to implement a better hash function. So let's create a new file. Name of the file will be better hash dot js. So here we will first of all include the better hash functionality, and over there we'll call for the simple hash function, and later we'll compare and have the output how it is visible on the screen. So the first thing we need to do is create a hash table, that is function hash table. Inside this I'll have this dot table equals new array, that is 137 value. After that I'll have this dot simple hash equals simple hash, this dot better hash equals better hash, this dot show distro equals show distro. After show distro we have the put functionality, that is this dot put equals put. Now we'll call for put functionality, that is putting up the elements in the hash table, this dot put data, and it will say where position equals this dot better hash. It will call for better hash function of data, and then it will say, so here we are changing the put method over here instead of the traditional method which we applied in our last chapter. So this dot table position equals data, then we'll have function simple hash data. Inside this I'll call for where total equals 0, for variable I equals 0, I less than data dot length I plus plus, and here I'm going to add up the ASCII values. So total plus or equal to data dot char code at to get the ASCII values of I. After the for loop I'll check for the hash values in the particular format, so I'll just say console.log hash value plus data plus the modulus format of it plus total, and then we'll have return total. So this will return my value, that is ampersand this dot total dot this dot table dot length. It will modulus it with the table length. Okay. After this, after the simple hash function, the next implementation comes is to show the function with show distro. So I'll show distro, and over here I'll include the logic as where n equals 0, for variable I equals 0, I less than this dot table dot length I plus plus, and after that I'll mention if this dot table of I, okay, table of I is not equal to undefined, and later I'll say console.log I plus the modulus format with respect to the value added over here as this dot table of I, okay. This was for show distro functionality. Now comes the better hash functionality. So here I'll include a comment implementing better hash functionality. So here I'll say, I'll take a constant over here. So better hash functionality, what it does, It does a simple thing is multiplying the product, whatever the amount we are getting, with the constant. So I'll say it as constant. So here I'll call for function first of all as function beta hash. We'll take two parameters, but we are now considering with one parameter, that is string. So this should return me a string. So I'll take a constant, which is, I can say it as a prime number, constant h equals 37. Then I'll say var total equals 0. After that, for variable I equals 0, I less than string dot length I plus plus. So this is my string dot length. So I'll specify the string over here as string. This is my string, whatever the value I'm getting of that particular string. Now I'll take a total. So my total will be nothing but the summation of h, whatever the h value I'm getting, into total, h into total, plus whatever the string value I'm getting, that is string dot char code at I. So whatever ASCII values I'm getting the total over here. I'm adding up the total inside this variable. This was the basic functionality for beta hash. And I'll say total equals total modulus this dot table dot length, and then afterwards I'll specify if total is less than 0, and then I'll take total plus or equal to this dot table dot length minus 1. Then afterwards I'll return a value, that is return parse int of total. So this was the basic implementation of the beta hash program. So we have done this, we have called for the variables. Now I'll do one thing, I'll declare a variable, that is variable sum names equal what all values we had in hashing.js. So we'll include our same values over here, those 10 values as my variable sum names. So this was the first implementation. After that I'll say, so this was like my all the 10 values of my variables inside it. Then I'll mention var h table equals new hash table, and after that I'll specify for variable I equals 0, I less than sum names dot length I plus plus, and after that I'll specify h table dot put sum names of I. Okay, so this value will be taken over here, and then we'll call for show distro function htable dot show distro. Okay, so this was my implementation of beta hash with some values associated to it. So let's have a look in our browser. So what is the output we are getting for the particular value which we have designed over here? Let's have a look in our browser. Before that, it is also important to create a HTML file. So I'll create beta hash dot html. So here I'll say doc type HTML tags associated to it, and here it will have a head tag. So this is my head tag. Inside this I have the title. So title is beta hash implementation. I'll also call for the meta tag over here. So this would be meta char set equal to UTF-8. After this, I'll call for the body tag. This is my body, and here the body tag will have the associative code, that is H2 better hash implementation. And next we'll have the script tag, so this would be script src equals better hash dot js. Okay, so this was my better hash implementation. So that let's have a look in our browser. Is the better hash functionality working properly or not? So this is my browser over here. If we go for better hash, here you can see associated values are given, like a key value pair is given for 12. For Jennifer it is 12, Raymond 22, Donnie 55, and so on. So if you want to have a look of what was better hash, I would like to brief it again that it is used for avoiding collisions. You first need to make sure that the array you are using for the hash table is sized to a prime number. This is necessary to use the modular arithmetic in computing the key. The size of the array should be greater than 100 so that we get the particular value aspect designed in a systematic way. After properly sizing the hash table, the next step to avoid collision, so that is why we implemented the logic of better hash, where we had a constant which was added up to the product whatever we are getting of the ASCII values. An algorithm was used over here, so we are implemented this algorithm, and based on the JavaScript implementation we are getting the desired output, that is 12 for Jennifer, 22 for Raymond, 55 for Donnie, 58 for Clayton, 80 for Jonathan, 82 for Mike, 103 for Cynthia, and 110 for Danny. So on we are getting whatever the values which we want inside the better hash implementation. So this was a complete overlook about the better hash implementation. The next we will focus about hashing integer keys, like how integer keys has been hashed, considering a student example and how it has been implemented in JavaScript. Starting with a concept which is called as hashing integer keys. In the last section, we work with string keys. In this section, we introduce you to hash integer keys. The data where we are working out with the student grades, the key in 9 student digit, or we can say we are going to generate a 9-digit student unique identification number, which will generate randomly although with the student's grade. So here are the functions which are important for implementing the student data. So let's get started with it. So first thing we do is to create a hash table the way we did in our last chapter. So first of all, we'll do one thing is to create a file which is called as integer hash.js. Okay, so here I'm going to implement the hashing table. So first of all, I'll start with function. So that is function hash table. So we'll create a function that is hash table, which will have the values associated to it, that is this dot table equals new array, and the array length will be 137, which is like the next number after 100, the prime number. Then we'll have simple hash, and after that we'll have better hash functionality. This was for simple hash, and then comes the better hash. Okay, so this is for better hash functionality. Once we are done with this, again I'll call for other functionality, that is show distro. And after that I'll call for put functionality, that is this dot put. Okay, now I'll call for put functionality, that is put data. So I'll say function. So let's start with a new line as function put data. Inside this I'll specify where position equals this dot better hash data After that, this dot table of position equals data, and after that we'll call for next function, that is simple hash data, that is function simple hash parameter data, where total equals 0 for variable I equals 0, I less than data dot length I plus plus. After that, total will be concatenated, that is total parameter will be concatenated with data dot char code at I. This will be there in my for loop. After that, you need to just print the value as console.log hash value as data. This would be data plus, taking it in pointer format with the appropriate space, and then total. Okay, and now we'll return the value. So we'll say return total modulus this dot table dot length. Okay, after this we'll call for the better hash functionality the way we had over here for better hash. So we'll take both these functionalities over here. So we had simple hash, we'll take show distro and better hash, both the functionality just copy pasted because we are just using up to get the summation value of the integers. Once we have copied up the file, now it is important. So we have better hash, we had show distro, simple hash and put data. So all these functionalities has been called. Now I'll create a random value. So I'll say function get random int. Get random int is the random integer with the value of min and max value. After that, I need to specify the return parameter is return mat dot floor, which will return a parameter that is math dot random into the value as max minus min plus 1. Okay, so we are done with this parameter. So it will return a random value with max and min parameters plus 1. Next is to generate the student data, that is the unique identification number of a student, as function generate student data, that is generate student data, and this will be an array parameter will be considered over here. So that would be for var I equals 0, I less than array dot length I plus plus, and inside this I'll specify for variable number equals blank value, and then for var j equals 1, j less than or equal to 9, j plus plus. Later we'll call for number, that is number concatenated with mat dot floor with math dot random value into 10. So this will generate a random value or a random unique identification value of the student. After that, we'll embed these values inside concatenation operator, and this is like get random int, and here I'll specify the min and max value of the random numbers as 50 and 100. Later I'll specify the array value, array of I equals number So once I've done with the student data, the next is to initialize the value. Prior to that, I'll create an HTML file that will be integer hash dot HTML. I'll rename it. It is like integer hash dot HTML. Now I'll create a doc type over here, doc type HTML. Inside this, it will have the HTML tag and the head value associated to it, that is head, and then comes the title. Prior to title, I will have the meta tag, that is meta char set equals UTF-8, and later I'll have the integer hash implementation. So this will be my title as integer hashing technique, and later we'll have the body tag. So we'll have a body tag over here. Inside body tag, I'll include a h2 tag like integer hashing algorithm, and inside this I'll have the script tag, that is script src integer hash .js. Now inside integer hash.js, we are going to create a variable for students. So here I'll just do one thing. Here I'll create a variable, say var num students equals 10, and later variable array size will be 97, and my length, the ID length which I need, the unique identification length, equals 9. After that, I'll specify the variable student as variable students equals new array num students, and inside this I'll specify the value as generate student data, and this will take a parameter of students, and inside this I'll say console.log student data, and later I'll specify the new line character over here, and here I'll generate the student data with the help of a for loop like for variable I equals 0, I less than students dot length I plus plus, and after this I'll take a value over here as console.log students of I dot substring 0 of 8, and after that I'll take a value embedded over here with a blank string, and then comes students of I dot substring, I'll take a parameter over here as 9. After providing the substring, the next important information which is to be done is to print the console of it. So for that we'll have a console over here. So we have taken the for loop. Now we'll take the next console. This was for student data. Next we need to show the distribution. So we'll say console.log data distribution, and after that I'll specify with a new line, and then I'll take a value as var h table. This will be my new hash table. Var h table equals to new hash table, and this will have a value associated to it as for variable I equals 0, I less than students dot length, and then we'll have a value considered over here, students dot length and I plus plus, and later we'll print a value inside the hash table as h table dot put. It will take up method of put for putting up the value inside the table. So we'll say put, and here I'll take the students value over here, that is students of I, and later I'll print whatever the values I have in my table which show distro, that is h table dot show distro, and the functionality is done. So let's have a look in our browser. What is the output which we are getting? So this is our browser. Here we had implemented our integer hashing algorithm over here. So here you can see the random values are generated. We have the student data and the distribution data. So in this way you can create a unique 9-digit value with the help of hashing algorithm, and we can implement this with the real world use cases. Let's start with our next data structure, which is called as trees. Trees are commonly used data structure in computer science. A tree is a non-linear data structure that is used to store a data in a hierarchical manner. Tree data structures are used to store hierarchical data such as files in a file system and for storing sorted list of the data. We examine one particular tree structure with respect to this chapter. We are going to learn is the binary tree. So tree are commonly used data structure in computer science. It is the non-linear data structure that is used to store data in the hierarchical manner. Tree data structures are used to store hierarchical data such as files in the file system and for storing sorted list of the data. A tree is made up of nodes which are connected with the help of edges. Binary trees are the main focus in this chapter. So let's have an example of a tree. So as I said, trees are made up of nodes which are connected by edges. The pictorial representation shows you the example of a tree. The purpose of an organizational chart is to communicate the structure of an organization. So this is my figure where each box represents a node. The nodes represent the positions that take up the organization, and the edges represent the relationships between the organization. For example, the CIO, that is the Chief Infrastructure Officer, reports directly to the CEO. So there is an edge between these two nodes as it is visible over here. The development manager reports to the CIO, and that is why we have kept the adjacent node over here. The development manager has its reporting functionality. The VP of the sales and the development manager, VP sales, development manager, okay, they have connected with the CEO, but they don't have any direct adjacent edge connecting to them because they connect to the CEO. So there is no direct relationship between these two positions. So with this figure, you also get that there is a tree definition where the top node of the tree is considered as the root and we have child nodes associated to it in the tree. So let's have a look about the binary trees. Binary trees are the special type of trees which are called binary trees, restrict the number of child nodes to no more than 2 elements. Binary trees have certain computational properties that make them very efficient for many operations. The series of edges you follow to get from one node to another is called as the path. Visiting all the nodes in one tree in some particular order is called as tree traversal, which is a peculiar property with respect to binary trees. Let's have a look with various set of terminologies associated to binary trees as it is visible over here. So my first set of the terminologies comes with this levels which is visible over here. We have levels, we have root node, left child, right child, and many more things. So let's have a look on each one of them. With this figure you get a better representation. Say the tree consists of nodes with a parent-child relationship. Each node has a parent which is visible over here, except for the first node which is called as the top of the node. So the first node is the top of the node. So let's have the terminology. Root. The top node of the tree is called as the root. It is a node which does not have any parent. There are internal nodes also and external nodes also. So keep that picture also in your mind. So this is my root which does not have any parent, which is called as the root element of the node. Every root element will have a child. So each and every element present in the node in the tree is called as the node. An internal node is the node with one child, whereas a node that does not have any children or leaf is called as the external node. Say it for our picture which we have over here, all are internal nodes because this is the pictorial representation of a binary tree. So if a node does not have any child, then it is called as an external node, but if a node had at least one child in it, then it is called as an internal node. A node can have ancestors or descendants. The ancestors of a node are parent, grandparent, great-grandparent, and so on. And we should keep all this picture in our mind. What are ancestors and what are descendants basically used for? Moving on to the next terminology, a node can have ancestors and descendants. Ancestors of a node are parent, grandparent, and so on. Subtree consists of a node and the descendants. Say for this example, this 759 is a subtree, 15, 13, 20 is a subtree, 536 is a subtree, and 9, 8, 10 is also a subtree. Then we have 13, 12, 14 which is also a part of a subtree, and 20, 18 and 25 which is also a part of a subtree. So subtree consists of a node and its descendants. The depth of the node consists of the number of ancestors. The height of the tree consists of a maximum depth of any node. A tree can also be broken into many number of levels. The root is on level 0 and its children is on level 1 and so on. Say it in this example, we have level 0, level 1 and so on, where levels define the depth of the tree. So depth of the node consists of the number of ancestors. Say for example node 3, okay, has a depth because it has 3 ancestors in it. So the depth of the tree is considered as 3. The height of the tree actually refers to the maximum depth of the node. A tree can also be broken into levels as it is given in the pictorial 1. This is level 0 and then comes level 1 with the 2 nodes which is 5, 7 and 15, and then comes level 2 that is 5, 9, 13 and 20. Then level 3 which represents 3, 6, 8, 10, 12, 14, 18 and 25. So this was the basic representation of the tree. The height of the tree consists of the maximum depth of any node. A tree can also be broken down into levels. The root is on level 0 and the children is on level 1 and so on. Now considering for the basic example, so this is the binary tree example. A node in a binary tree has 2 children at most, one left side and one right child. The definition of the binary tree is such that it allows more efficient algorithms to insert, search and delete nodes to and from the tree. Binary trees are largely used in computer science. A binary tree is a binary search tree, but it allows only to store nodes with the lesser values on the left hand side, and the nodes with the greater values will be there on the right hand side as visible over here. So this has 2 nodes. 7 is lesser than 15, so that is why 7 is on the left hand side, and 15 is greater than 7, so that's why it is there on the right hand side. So this was the basic pictorial representation with the binary tree example. So if there is something which you need to understand for the binary tree algorithm, is that set the root node to the current node. You should always set your root node to be the current node. That is this one, the 11 which we saw in this picture. If the data is inserted in the node is less than the data value in the current node, set the new current node to be the left child, and if the data value inserted is greater than the data value in the current node, then you should go to the step number 4, which says that the current node to the child node of the current node. If the value of the left child of the current node is null, the insert node will exit the loop and otherwise skip to the iteration of the loop. If the value of the right child of the current node is null, then insert the new code and later exit the loop. So this is actual implementation of the binary search tree. So in the next chapter, we'll have the basic implementation of a binary search in JavaScript. Let's start with the binary search tree implementation. So this is our folder binary trees, and here I'm going to create a new file, that is binary tree.js. Here I'm going to create, the first thing is about creating a node. So let's start creating a node as function node. Inside this I'll specify data, left and right. And after that, I'm going to specify the value as this dot data equals data, and this dot left equals left. After that, I'll have the right value associated. This represents the left node and the right node. So this dot right equals right. And then we'll call for show method, that is this dot show equals show. So we're done with the node implementation. Now I'll call for function show. So my function show would be function show. This will include a logic to return whatever the data I have it. So I'll just say return this dot data. Okay. After this comes the next is the binary search tree functionality or the constructor, the way we did for other data structures. So that will be done as function bst this dot root equals null, and this dot insert, this is for insert functionality. This dot insert equals insert. After that, I'll call for in order functionality. So that would be this dot in order equals in order. Okay. Now after this, there will be a functionality for inserting a data. So for that, I'll say function insert data, and this will call for variable n equals new node data null null, and after that I'll specify the parameter as if this dot root equals null. Like if I get the root module as null, then I should set the value as this dot root equals n. Else I'll call for where current equals this dot root, and after that I'll say where parent as one variable, and after that while true, and here I'll say parent equals current. Now I'll specify for one condition, that is this is for true parameter. Inside that I'll say if data is less than current dot data, then current equals current dot left, and if current equals null, then parent dot left equals n with a break parameter. Now after the if condition, I'll also specify the else condition as else current equals current dot right, current equals current dot right, and here I'll specify if current equals null, then call for a console and show up the values. So that would be console.log. I'll call for show method, so it would be node.show plus the value embedded in it, and then comes the values whatever I want to show. Then I'll call for my new number variable, so that would be where nums equal new binary search tree, and then comes numbers dot insert as 23. So I'm going to insert these nodes inside my binary tree, so I'll just copy paste the values over here. After 23 I'll insert 45, after 45 I'll insert 16, after 16 I'll insert 37, after 37 I will insert the value as 99, after 99 I'll insert the value as 22, after 22 I'll insert so I've inserted a number of the values. Now I'm going to print a log, which is like printing up the root. So I'll just say console.log nums.root, console.log nums.root. Okay, so this is my particular representation of insertion. Now I'll create a new HTML file, that is binary tree.html, where I'll create the doc type HTML. Inside this I'll specify the HTML tag. After that we'll have the head tag and the title tag, And prior to title tag, I'll have the meta tag. So this is my meta char set as UTF-8. And after this, it's like I'll print a value over here, that is binary search implementation. And now we'll have a call for a body tag. It's my body. This will have script src as binary tree.js. Okay. After that, we'll have the h2 tag over here as h2 binary search tree implementation. Okay. So we had the difference association with respect to binary search tree. Now we'll check in our browser what is the output we are getting. Are we getting the nodes printed in the proper manner? So this was a binary tree implementation, and if we checked out over here, the traversal is showing up the node that is 23 with the left node 16 and the right node 45. So it is automatically arranged in a proper order such that the left node is like lesser than the right node. So this was the basic implementation of binary search algorithm. So this was about the complete understanding about the binary search algorithm. In the next chapter, we will understand about the various traversal techniques of the binary search algorithm. The next major concept which is important to understand is traversing a binary search tree. We now have the beginnings of the BST class, that is the binary search tree class, but all we can do is insert nodes into the table. We need to be able to traverse a binary search tree so that we can apply the data in different orders such as numeric or alphabetic order. There are three traversal functions with BSTs: in order, pre-order and post-order. In order traversal visits all the nodes of the binary search tree in ascending order of the node key values. Pre-order traversal visits the root node first, followed by the nodes in the subtrees under left child of the root node, followed by the nodes in the subtrees under the right child of the root node. A post-order traversal visits all the nodes of the left subtree to the root node and then visits all the child nodes of the right subtree onto the node. So this is how we are going to understand about different type of the traversals. Considering for the first one, which is called as the in-order traversal. So here the algorithm goes in this way. To traverse a binary search tree in order, following operations are carried out. Traverse the leftmost subtree starting at the left internal node. You should visit the node and then you should go to the rightmost subtree. So that is the in-order traversal, where you go to the left node first, then go to the root node and then you go to the right node. Basically, traversal is nothing but traveling from one node to another root node in a binary search tree. So we are following this with respect to three different traversals, that is in-order traversal, pre-order and post-order. In order, the leftmost subtree is taken the first part, then it goes to the root and then the right one. Let's consider for the pre-order. Pre-order algorithm has these three steps. To traverse a binary tree in pre-order, following operations are carried out. Visit the root, traverse the left subtree and traverse the right subtree. Visit the root, which means that you'll have to visit the root node first, then you should go to the left subtree and then right subtree. So that is the basic ordering when it comes to pre-order traversal, where you have to calculate in this particular format. Whereas in order you went to the left node first, whereas in pre-order traversal you go to the root node, then go to subtree, right, left subtree and then right subtree. For post-order traversal, to traverse a binary tree in post-order, following operations are carried out. So we saw a look of in-order as well as pre-order. Now comes is the post-order. Traverse all the left external nodes starting with the leftmost subtree, which is then followed up by the bubble up in the internal nodes. Traverse the right subtree starting at the leftmost external node, which is followed out by the internal nodes. So what it does, leftmost subtree will have all the internal nodes. You have to calculate whatever the internal nodes. Internal nodes specifically means if a node has a child node, then it is called as an internal node. If it does not have any child node, then it is called as the external node. So basically, keeping these points in mind, say we have to traverse all the left external nodes with the leftmost subtree, which is then followed by a bubble up with all the internal nodes. Traverse the right subtree starting at the left external node, which is followed up by the bubble of the all the internal nodes, and then visit the root. So this is the basic combination which takes place with the post order traversal. So let's go to our code base where we will analyze all the pre-order and post order traversal concepts and everything, and we will understand the implementation of this code in JavaScript also. Consider for this binary search tree, so we are going to just save this particular file again, and here we will implement in order and pre-order traversals. So it will be served as binary tree 1.js. Okay, here I'll implement whatever the code we are going to do for tree search. So we have a traversal concept over here. So we'll have a look over here in this example with the binary search tree implementation. So traversal is nothing but traveling from one node to another node in binary search tree. So these all logic will be similar, but for in order we'll have a code associated to it. So let's design the code for in order, which would be, so we'll start with the in order as the first node. So it will just check out, first thing is that if not equal to node equals null, which means that if the node is not equal to null, well, in this scenario you should call for in order method, in order functionality with node dot left. So it will go to the left value first, and then it will print whatever the values are there with the help of show method, that is node dot show plus a blank string, and then it will call for in order in node dot right. So it will call for left, then root, then right element. So this was with respect to in order. Now coming for pre-order. So pre-order will be in this particular format: function pre-order, and it will call for node, and this node will call for if not equal to node equals null. In that scenario you will just say console.log node.show plus blank string. Then it will call for in order left, in order dot left, the way we did over here. So that is node dot left, and then in order node dot right. Okay, so we did this with this part. Now after understanding the pre-order functionality, the next step is to give out the post order. For that I'll say function post order as node, which equals to if not equal to node equals null, which corresponds to post order. So what will post order do? It will take all the subtrees in the left and the right, and then it will move to the root node. So it will take left, and then it will call for right, that is node dot right, and afterwards it will show the root node, that is console.log node.show. The root node will be present over there. Okay, then this is like a basic implementation with respect to in order, pre-order, and post order. So we have implemented all this logic successfully over here. Now we will do one thing, is like we'll create a binary search tree which is already been created. So now we'll call for in order traversal. In the similar way we'll call for pre-order as well as the post order traversal. So we'll do now in order traversal is done. I'll do for pre-order traversal, and the similar way I'll call for post order traversal. So this would be my post order traversal. So I've done for this logic. Now let's go. Now we'll do one thing. We'll just save this particular file binary tree, and I'll save it as binary tree1.html. And here I'll just say it as binary search tree implementation with the concept as traversal. Okay. So let's go to our code base and see what is the output which we are getting. So if you just check out for it, this is our binary tree 1.html. So here I had a look for in order traversal, which is representing the left node, then root node, then right node. In pre-order traversal, it goes to the root node first and then left node, then right node. For post-order traversal, it travels in this format with the root node and then left node, then right node. So this was the basic implementation of traversal in binary search algorithm. Let's start with the next data structure, which is called as the graph. The study of networks has become one of the greatest scientific hotbeds of the century. The mathematicians and others have studied these networks for many hundred years. Recent developments in computer technology and social theory, not to mention about the social media, have put a spotlight on the study of networks. So in this chapter, we look at how networks are modeled with graphs. We'll define that what a graph is, how it is represented in JavaScript, and how to implement the important set of graphs. We'll also discuss in importance of choosing the current data representation when working with graphs, since efficiency of the graph algorithms largely depend on the data structure used to present the particular graph. So let's start with the graph implementation. A graph consists of a set of vertices and set of edges. Think of a map of a US state. Each town is connected with other towns via some type of a road. A map is a type of a graph where each town is a vertex and a road that connects to two towns is called as an edge. So basically, graph is set of vertices and set of edges. Edges are defined as a pair of V1 V2 pair, where V1 and V2 are nothing but the vertices of a particular graph. Okay. So graph can also have a weight which is considered to be called as the cost. A graph whose pairs are ordered, or which we can say which has a particular direction from one point to another, are said to be called as an ordered graph. Whereas on the other hand, the directed graphs indicate the flow from one vertex to another vertex. A flowchart that indicates the direction of a computations in computer program is said to be called as a directed graph. A directed graph can be represented easily with a particular scalar or vector quantity. Consider for a scalar quantity, we always have a scalar quantity which has a value in it. That is nothing but a weight of a graph or a cost. But there is no point of showing from one point to another. So there is no direction from one point to another. So that is why it is called as a scalar quantity. On the other hand, if two quantities have a direction from one point to another, then it is called as a vector graph. Directed graphs indicate the flow from one vertex to another. A flowchart that indicates the direction of computations in a computer program is an example of a directed graph. Consider for the structure of the directed graph, it is represented in this particular format. Say A pointing to B, A to D. B points to E and C. C points to E and F. E points to D as well as F. F points to H as well as E. And F points to G as well as D. So this is the basic simple example which represents the directed graph. When it comes to unordered graph or undirected graph, is like we just have a cost added to it, but there is no direction from one point to another. In such a scenario, it is typically called as an unordered graph or the undirected graph. So let's have a look about various type of the terminologies for a graph. Path is a sequence of vertices in a graph such that all the vertices in the path are connected by the edges. The length of the path in the number of edges from the first vertex in the path to the last vertex can be considered typically as a particular path. A path can also consist of a vertex to itself, which is also called as a loop. Loops have a length of 0. A cycle is a path with at least one edge where one vertex and last vertex are same. A simple cycle is one with no repeated edges or vertices from both the directed and undirected graphs. Paths that repeat other vertices besides the first and the last vertices are called as the general cycles. Two vertices are considered strongly connected if they are in the particular path, from one vertex to another vertex and vice versa. If graph is a directed graph, all its vertices are strongly connected. Then directed graph is said to be strongly connected graph. The best real-world implementation of a graph can be set as graphs which are used to model different type of a real-world system. The best example is the traffic flow. The vertices represent the street intersections and the edges represent the streets. Weighted edges can be used to represent the speed limits or the number of lanes. Modelers can use the system to determine the best routes and the streets mostly likely to suffer from a traffic jam. Any type of transportation system can be modeled using a graph. For example, an airline can model its flight system using a graph. Each airport is a vertex and each flight from one vertex to another is taken as an edge. A weighted edge can represent the cost of a flight from one point to another point, or perhaps the distance from one airport to another airport. Computer networks, including local area networks, are much broader networks, includes of an internet, which is modeled with the help of a graph. There is also important to understand different type of the searching algorithm in the graph. So the first comes is the depth first search. Depth first search means what? Depth first search involves following a path from beginning a vertex until it reaches the last vertex. Then backtracking and following the next path until it reaches the last vertex and so on. So this is kind of a depth first search. What it does is that it visits all the vertices which has not been visited previously. The basic algorithm of following the depth first search is relatively very simple thing. It visits the vertices that has not already been visited, and which has been visited, it marks it as visited so that it will not be revisited again. This recursively visits the number of unvisited vertices in the particular graph. Basically, we determine which vertices can be reached from a specified vertex, which is a common activity for the graphs. We might want to know which roads leads from one town to another, and based on that functionalities, we have implemented the logic with respect to depth first search. The depth first search algorithm has a typical peculiarity, like whatever it has been visited, that vertices will not be revisited again. So that is the first step. The next comes is the breadth first search. For the breadth first search algorithm, it is quite simple because it starts from the first vertex and tries to visit whatever vertex which are closer to that particular element. In essence, this search moves from one graph layer to another graph layer. So it goes by layer by layer. So if A is nearer to K, H, E and B, so it focuses on accessing these elements with the value K, H, E and B instead of going to the next layer. So this is a particular way of breadth first search. So the typical algorithm for breadth first search uses a queue abstraction instead of an array abstraction for storing the vertices. The algorithm works as finds the unvisited vertex and adds it to the end of the list, adds it to the queue, takes the vertex V from graph and adds it to the list of unvisited vertex, adds all the unmarked vertices that are adjacent to V and adds them to the particular queue. So this is the basic logic for understanding the peculiar example of the breadth first search algorithm. So this gives a better picture and the scenario for breadth first search. This was a typical example representing. Now in the next chapter, we will have the implementation of graph with respect to HTML and JavaScript file. Let's start with our graph implementation. So here this is our graphs and here I'm going to create a file that is graph.html. So which begins with a doc type. So my doc type is doc type HTML and later we'll have the HTML tag associated to it, which will have the head tag, and the head tag will have first element that is meta char set UTF-8, and after that we'll have the title, that is title, which comprises of graph implementation, and later we'll have the basic knowledge for understanding the body part. So this is the body, which will have h2 tag, which also says the same, that is graph implementation in JavaScript. Okay, so this is the first thing. After that we'll have the script tag, which says script src, which represents the graph element, that is graph.js. Okay, so this was the typical graph.html implementation, and after this inside graph I'm going to create a new file that is graph.js. It's like graph.js. We'll keep that particular nomenclature in this format. Now we'll start, as we have seen with other data structures, we'll create the constructor. So let's create a constructor as function. So this will be function graph, which will have a value v. Inside this it will have this dot vertices equals v, and this dot edges equals 0. After that it will have a parameter that is adjacent equals a blank value. Then comes the next parameter that is for, where I equals 0, I less than this dot vertices I plus plus, and later we'll have a value that is this dot adjacent I equals a blank array, and after that it will have a value this dot adjacent I dot push as a blank value. Now after this comes the next value that is to be taken is this dot add edge equals add edge, and later this dot show graph equals show graph. Now this is like we have initialized our element over here with the for loop constraint. So after this we'll create a function for adding up an edge in the graph. So we'll include this in our comment as adding an edge in graph. So this will be done as function add edge, which will take a parameter. This will take a parameter that is v and w, and inside this it will say this dot adjacent v dot push. It will push whatever the vertices I have over here from one point to another. This is like adding up an edge, and this dot adjacent of w parameter will be pushed with to v parameter. Okay, then we'll add these particular edges. So this will be this dot edges plus plus. This was for adding up an edge in the graph. After this comes the next logic is like to show a particular element in the graph. So we'll call for show graph as function show graph. Here we'll have a logic for show graph as for variable I equals 0, I less than this dot vertices and then I plus plus. This is to show whatever the nodes we have in the graph. So first of all I'll print console.log I. Inside that I'll print a value in this format, and after that I'll call for another for loop. So that for loop will be inside this for loop only, which will be for variable j equals 0, j less than this dot vertices j plus plus. Okay, so this will take if this dot adjacent I of j is not equal to undefined, and then console.log this dot adjacent I of j plus blank value. So this was for show graph implementation. Okay, now I'll do one thing. After show graph we'll have a look even for the depth first and breadth first search. So that for we'll call for the adjacent functionalities with a particular name. So let's consider for the breadth first search. That would be the best example to understand. So breadth first search will have a function over here. So this will be called as this dot BFS equals BFS. Okay, So BFS will be a functionality for adding up the breadth first search logic. For that, I'll just say function after show graph. I'll call for breadth first search as function BFS of V, which will include a parameter in queue format because we are representing here arrays in the format of a queue, and this dot marked of S equals true, and q dot push as S, which will be add to the back of Q. Then we'll have the while loop, that is while Q dot length greater than 0. After that, where V equals Q dot shift, and after that we'll have if V equals undefined, and that will be console.log visited vertex will be called over here plus V, and after that we'll call for the logic. So this gives the visited vertex whatever is visited over here. So this was for the breadth first search implementation. Now let's create a graph. G equals new graph, okay, with the nodes of 5. After that, I'll create an edge, that is G dot add edge 0, 1, G dot add edge 0, 2, G dot add edge 1, 3, and after that G dot add edge 2, 4. Then we'll have a show graph functionality, that is D dot show graph will represent all the nodes in the graph, and then we'll call for breadth first search algorithm, that is G dot BFS 0. So let's have a look in our browser what is the output which we are achieving with respect to this particular graph implementation. So now inside the graph section, we'll call for graph.html, which will have all the nodes represented in the particular format. But if you want to check out for the specific visited vertices, say it for 0, so we'll have the breadth first search algorithm implemented in such a format because it goes for the nodes which are nearer to it. So it calls for 0, then 1 and 3, and later it calls for 3, 2, 5, which is like nearer nodes which is there with respect to 3 or 1. So this was the basic implementation of graph in JavaScript.